Hello, everyone. Welcome to the Bytedance Open Source Developer Summit. Do I have everyone's attention? Yeah, thank you. So there are some logistics things you have experienced are very efficient security today. So thank you for bearing with us. Um, and we will appreciate if you stay within the area. People asked about restroom. If you go on the last door, take a left. The restroom is on the right. There is the break room for tea, coffee. There is snacks. Go easy on the snacks, so we don't get complaints later. Lunch will be served here. And there is a feedback form that I will share the QR code of later. And there are some fun prizes to win after. So because our keynote speaker is here and he has another meeting to get to, so we'll go about the overview of Bytedance open source, etc. after his talk. So with that, please join me in welcoming Arpit Joshipura, Senior Vice President and General Manager at the Linux Foundation. He has over 35 years spanning software, hardware, silicon across various C-level roles. He's a visionary in networking, AI, edge computing, IoT, energy, and open source. And I have had pleasure to work with him in Linux Foundation networking since 2016-17, I think. And a lot of projects, DPDK, Acreno, etc. We have gotten into Linux Foundation and grown them together. So please join me in welcoming Arpit Joshipura.
Thank you, Sujata. Ah, works. Thank you, Sujata. All right, thank you. So I'm going to spend a few minutes just talking about, the open edge. Edge and edge computing is so hot right now. And we're really excited to host several of these new technologies. But just a, a show of hands, how many of you are familiar with Linux Foundation? Oh, good, good, good. I know Ray is. But for those of you who are not, we're a nonprofit, obviously. We host um, world's largest projects. And the goal is to create shared technology and enable global collaboration that everybody can benefit from. Vendors, end users, North America, Asia, Europe, doesn't matter. So we go across the globe, okay? We had originally just Linux, and now we have over 1,000 projects that we are hosting. And these projects are grouped by either a vertical market, telecom, agriculture, automotive, energy, etc., or they're grouped by an area of technology, right? Security, blockchain, um, edge IoT, etc. And then it's hardware, software, and everything in the middle. So if you're not familiar with it, I do request you to browse, a lot of things. From our perspective, we don't have any engineers. We support neutrality, neutral governance, development processes, sort of CI/CD. Think of us as R&D ops, right? Program management, infrastructure, ecosystem development, and most importantly, IP management. Okay. A bunch of events. Some of the largest events like KubeCon are hosted by us. Events like Open Networking and Ed Summit hosted by us, etc. training, and developer operations. So there's a whole bunch of things that we do that I want to make sure that you're familiar with. Now, with that said, we have one foundation, sub foundation called LF Edge, and I'm going to double click on that a little bit today, given the importance of what you guys are doing. Uh, we have a whole bunch of new applications that require two things: less than 20 milliseconds of latency and accelerated processing. That's it. Okay. And these applications are going to create a market that is 4 times the size of cloud computing. Okay. Um, but it is not going to be just beneficiary to like the 5 to 10 big cloud service providers. It's going to go across a whole bunch of vertical markets. Okay. And I'm going to skip a lot of slides, but this is actually a very important slide where how does it make it to the market? How do we enable innovation in open source to make it to the markets, right? So let's say there are a whole bunch of, I think it's a little messed up here, but there's a whole bunch of open source projects, right? These logos are just open source projects. Um, they get packaged into, so you all develop software for that under a neutral governance. That software makes it to a blueprint, or it makes it to either an enterprise, a service provider, or specialized end users like governments. And then within an enterprise, they make it into a specific vertical that you see on the top. Now, the thing I want to emphasize on edge compute is the verticals you see on the top, that's a linear priority list that our community has already provided. What does that mean? That means edge compute is most relevant to the industrial manufacturing folks first, followed by energy, followed by commerce, et cetera, et cetera. So you can see our projects are all geared towards kind of doing that work. Okay, so what is LF Edge? LF Edge is really an umbrella or a sub foundation, we call it, that provides a framework for open and interoperable edge compute. Right now, what does that mean? So it has, think of, the first thing is think of edge as a terminology definition, and I'll get to that in just a minute. But uh, our goal is to unify these frameworks. So there are 4 edge markets today that everybody wants to play in. There is an IoT edge, and it's their view of what edge looks like. There's a telecom edge, there's a enterprise edge, and then there's a cloud, a service provider edge. And these are markets. These are not definitions. These are markets. And they all cross into each other because a manufacturing site can be served by one telco, operated by another public cloud provider, and have their own private data center for their workloads that reside somewhere else, right? So our goal is to bring these markets together and have frameworks that make full sense, okay? So the first thing I want to emphasize is the terminology, okay? The LF Edge community sort of sits in the middle of the core cloud data center and the access technologies. Okay, so for those of you who are familiar with the whole end-to-end picture, this diagram actually shows the full stack from data plane and the network operating systems that run the data planes, right? Like Sonic, for example, to newer technologies like P4. So these are all networking technologies. You go up the stack into control planes, SDN controllers, cloud native automation engines like Nefio, all the way up to applications. Okay. Whether the applications are based on eBPF lifecycle management that Walmart runs, or telco applications or APIs, doesn't matter. So that's the whole stack. And then on the other side, and I'll get to the edge in a bit, you have 3 modes of connectivity. You have the traditional 3GPP RAN connectivity that you see on the left-hand side. So we host projects there. You have the broadband or the GPON connectivity, and then you have everything else, enterprise, fixed wireless access, etc. So LF Edge is sitting right in the middle, and it has done one thing very well, which is defined what edge compute is in terms of terminology. Okay. So there are only two types of edges, terminology wise. There's a so people say, oh, thin edge, thick edge, far edge, near edge, all of that stuff. It's all bogus, right? You need to throw that out because that's all a relative terminology. There's only two types of edges, a user edge and a service provider edge. A user edge is under the control of a user, and a service provider edge is shared. So let's look at that in a little bit more detail. Okay. So you can see here at the bottom, user edge under the control of a user, service provider edge shared as a service. And there is no hard line, but generally the last mile separates the two. Okay. Now, there is no one implementation of user edge. There are three. There is a, it's not very visible here, but there's a constrained device edge. So microcontrollers and things like that, embedded compute, or it could be an IoT gateway, like a server, or it could be a mini data center that's still under the control of an enterprise. Okay, so there are three implementations of a user edge. And then for the service provider edge, you can stay within a RAN or a smart central office, because that's typically within 20 milliseconds. So I always give this example. If a sensor wakes up and dumps data in a public cloud every day, it's an IoT application, but it's not an edge compute application. Okay. You need that latency dimension to make it an edge compute application. So that's kind of the lay of the land. What we have done is we have all these projects on the top that are hosted by LF Edge, everything from infrastructure up to applications and applications in interfaces. And I think we have a few of them sort of to look at. And again, as I said, proximity, responsiveness, and mobility are sort of the anchor drivers here. There is one project that has kind of created what is called blueprints, is to pull it all together based on use cases. That's a Crano. I will not go into all the blueprints, but there are about 20, 25. Some of them are archived, some of them are active, but anything from a connected car to a connected city to a predictive maintenance, these are all use cases that the community kind of does integration on. Okay. All right. So I'm going to just focus on a few new projects that have come in. There are existing projects like EdgeX Foundry and Eve that are going, well on track. But in this year, in 2024, we added 4 new projects, and these projects are actually very important because in the new age of AI, where you want data to stay in a local edge deployments or installations, this project Edge Lake is very important because what it does, it creates a decentralized network locally with edge nodes and then prevents the data to go to a public cloud. Okay, why is that important? Because now you can run models, whether it's inference or LLMs or whatever, right? If you can fit it, you can run them locally. And the first application of this happens to be in a smart city. So this project just got deployed in sort of Midwest city as a smart city. All the traffic sensor data, everything kind of comes in, uses this project. They run, whatever they want to run on it in terms of analysis, insights, etc. But the billing from an Amazon or an Azure perspective just significantly was cut down. Okay, so you can see the true power of edge compute is not until you get the data to stay within the edge, and you prevent the transmission costs back and forth. So that's one important thing. So AI is no good without data solutions. Okay. The other project, which I know you all, several of you may be working on, is quite important as well, because it's a unified platform to simplify the deployment of these AI tools. whether it's LLMs or whatever, but it's on the constrained devices. And this project, is an incubation project. Some of you might. How many of you are working on that? By show of hands, or no, or maybe on the call. Okay, so if not, do take a look at it, because this is something that you know uh, a lot of you support. I know Tina is on the call. She has been very active on this project as well, but it's gaining a lot of traction from that perspective. Okay. Then there's this project called OpenBow. Now, keep in mind, this year of 2024 was quite interesting. There were a lot of forks. And for those, I mean, this is an open source developer day, so I want to emphasize this. Forks are bad. Never fork, okay? Always work upstream, right? Because if you fork for whatever reason, you may feel that you are ahead for the short term, but the rest of the world and the community will basically destroy you, okay? What does that mean? That means if there were fork on HashiCorp, which is kind of what happened, right? The community forked, so they changed the license to make it a non-OSI approved, non-open source friendly license. All of a sudden, the community kind of took the main line and created an open version of that called OpenBow. And that was for encryption management system. IBM is behind it, obviously, but you can see the value of doing this. Okay. And then one more project I want to point out is something called InstantX. So this was a project donated by Vodafone. So for those of you who are working on vehicle to edge cloud communications, V2X, this is a very important project because under a federated environment where an edge cloud needs to run across multiple countries, multiple cities, and vehicles are kind of traversing that boundary, how do you get the responsiveness and the applications to cut across these federated edge? So Vodafone has already kind of launched this project in multiple areas. So the use cases are hazard detection, collision avoidance, right? Everything. It's not limited to vehicles. The framework is not limited to vehicles. It could be drones, et cetera, but very powerful project. And Sampara, who's kind of also on the board of LF Edge, is really behind it. There are several universities that are pushing this project. So we're really excited on this one. Okay. So then in summary, again, our goal is to unify these frameworks with a lot of these things. There are a lot of projects that are incubating, stage one, going to growth and impact stage. We have a wide section of kind of members, and there's a whole landscape if you want to see the diagram there. I'm not going to go into that. Okay. Okay. Now, there's one thing I want to point out, which is domain-specific AI. Okay, and what that means is everybody talks about these LLMs, and everybody talks about generic stuff, right? We have our sister organization for doing that, but anything that is domain-specific gets done in LF Edge, like the InfiniEdge AI and things like that. So just keep in mind. If there is an AI at the edge, LF Edge is the place to be. If it's a generic data or a AI project, then we can, and this kind of spells it out. You can see, infrastructure with data sets that train and learn, and then all the use cases for the edge are here, and then everything generic is done by our sister foundation, LFAI and data. Right? So this is where the open llamas and the open AI models are stored. All the data governance, right? So how do you share data through a CDLA license? All that stuff is managed here. Everything domain-specific use cases and models, plus anything that is infrastructure and data that comes from the infrastructure that you need to vertically train on is done at this level. Okay, so finally, just to wrap up, and I think we have some time for some questions. Yep. Um, as I said, we are integrating the 4 markets and communities across IoT, enterprise, cloud, and edge telecom areas. And we're going to keep it an open and interoperable, right? So you can see I did not call out on any specific hardware, any specific silicon vendor, or even as a matter of fact, operating system, right? And that goes in the edge, right? Is it Photon? Is it Clear Linux? Is it, proprietary? Is it Zephyr, right? It could be RTOS. There's multiple OSs that go in. And each of these OSs are customized for that device with regulatory requirements, physical requirements, hardening requirements, right? So we are not going to dictate that because at the LF Edge level. And we'll do it in collaboration with the consortiums and other communities. Okay. So I think that's pretty much what I wanted to say. Questions? I can take any questions. Yes. So the question is, how do you calculate latencies? And I'm just repeating it for the audience, right? I mean, for the online people. How do you calculate latencies and it's about 1,000-mile roughly distance. So that's the network latency, right? You've got to add the application latency and the processing latency on both sides. The moment you do that, it's not 1,000 miles, right? It's pretty much a city, roughly. It could be, unless you have massive fiber that cuts down on the network latency. AT&T originally did a lot of work on calculation of these numbers, and they are generally roughly in that 20 millisecond range. It's not a hard number because of topology differences and all that, but it's definitely not 1,000 miles. Other questions? Wait for the mic. Yeah.
What projects are there in the Linux Foundation for kind of local device meshes like mobile ad hoc networking that don't involve a public routable internet? So if two, say, PICO XR devices, which are Android open source based, are on the same kind of Wi-Fi network that's non-routable, think like DoD kind of scenario, what kind of projects does the Linux Foundation have for those devices to elect and self-organize and share compute between them?
So I did not mention there's another foundation, sub foundation called LF connectivity that covers all the alternate means of communications or connectivity, right? So could be 60 gigahertz connectivity. There's a project called Telegraph. There is a fixed wireless access project. There are a couple of other projects in that which span generic non-3GPP access. Wi-Fi specifically, we don't have a specific project on Wi-Fi. Okay, so there's a couple open source Wi-Fi projects under TIP, but again, not very very pervasive.
Yeah, hello, can you hear me? Yeah, this is Sridhar again. I'm hearing like the FANG companies are building their own huge edge device network. Are they going to use the LF Edge technology, or they're going to build their own proprietary so that like the customers, the end users who are using their services, they connect to their devices, the edge devices, and eventually connect to their
Sorry, I
cloud.
missed the first one. Who is building the edge
The
network?
FANG, like the Facebook, Meta, the public cloud providers.
Okay, so the the actual build outs of edge are done by three people, three categories, right? The public cloud providers that are doing, big city edge deployments, right? Let's bottle that. The most prevalent are the service providers and the likes of Equinix, for example, right? CDNs and that have colo data centers. That's where bulk of the work is being done, and that's where you would put an enterprise project like this in that location, And Equinix is part of LF Edge, right? So they push some of that. So I would say longer term, the private networks and the private enterprise things will ride on this plumbing layer, right? Remember, open source, the goal of open source software is to work on non-differentiated code. That's 80%, 70% of the problem. A device starting, stopping, logging, connecting, API, like 160 messaging protocols, MQTT, this, that. Why reinvent the wheel with all the drivers, right? Why should I connect to, why should I have 150 devices connect differently to a public cloud? That's the frameworks that we're talking about. So everybody's going to use that and then build on top for differentiation.
So do you expect these people will be working with Equinix to deploy their own caching devices so that like it performs
They
well for
are,
their?
yeah, they are already either them or they're working with the AWS or they're working with the telcos themselves. Um, now, if they're doing a private edge enterprise inside their own like campus or whatever, that's a different problem, right? But they also are part of open source, right? Because remember, all the vertical industries are solving a problem. So we just had a webinar on industrial automation yesterday. So if you're not like familiar with that, the problem is between machines and applications inside the factory. How do you standardize that so that a Siemens and a Rockwell machinery talk to each other? So the way they are solving the problem, it's not a location independent problem. It is making sure that the standards are correct, and then the open source that comes with it can orchestrate interoperability between edge devices, right? The goal of LF Edge is interoperability. All right, I think that's it. Yep, out of time. Thank you. Oh, question online, okay.
What can we do to find out more about the activities of Linux Foundation here in the US and internationally?
Just go to the website, look for the project, search, or just send me an email. I don't know. I don't know what you're looking for, but ajoshipura@linuxfoundation.org. Yeah. Yeah.
Yeah,
Thanks,
actually,
Tina.
we'll have a meetup today in the evening after we're done with the developer summit. Yeah.
In general, the way you so go to LF, get an LF Linux Foundation ID, which will get you into the, pretty much there's then start with LF Edge, get the ID. I think I had a slide on that, but
Yeah, and
yeah.
also most LFH projects have wiki, right? So it's very
Yeah, so
easy
here,
to.
this is the slide, right? So
Yeah.
just get the ID, go to the wiki, and start subscribing to mailing lists, participate, just join, right? Now, if your company is not part of LF Edge, just contact me. We'd love to have you on board, or contact Sujata. She can bring you up to the right people, and you can be part of the board, or you can be part of the membership profile. I mean, remember, LF is a nonprofit, so we request as many people as possible to join and contribute, so that we can do things like this.
Yeah, and also nonprofits and universities can join for free, right?
Nonprofits and universities can join for free. Yes.
Yeah.
Okay. Good. Thank you.
Thank
I'll
you.
leave it here.
Yeah, yeah.
Okay.
Thank you. Thank you so much, Arpit. I know you took time out of the Members Summit. For those who don't know, Linux Foundation Members Summit is an annual event. Some of us were there, myself, Tina included, came back yesterday, and Arpit took time out just for this talk to come out of Members Summit, which is not here, which is in Napa. So he drove back. Okay, so with that, let me go to the Bytedance open source projects overview. Okay, so I'm sure everybody must have question about what does Bytedance do in open source. Very easy. This QR code is the link tree that you will see in my presentation throughout. So this link tree has the Bytedance open source wiki. And of course, my LinkedIn profile, the Bytedance meetup group, the Twitter, most of the open source projects that we'll be talking about today, those wiki links, sorry, GitHub links are there as well. Sorry, I said wiki. This is GitHub link. We were just in LF presentation. Morning brain fog. So these are some of the projects that we'll be talking about today. veScale, PICO 4, BMF, Babit Multimedia Framework, KubeWharf, Rspack, CloudWeGo. Raise your hand if any of you have heard about any of them before. Yeah, I know, usual innovators, but not others. So you're in for a treat. You'll learn about them. So little about me. Like Tina mentioned earlier, I am at the Linux Foundation Edge Governing Board. I've been working in open source and Linux Foundation and with Linux Foundation for quite a number of years. I would say in 2016 is when my open source journey started, which I can't believe is more than 8 years ago now. But before that, I was in networking software and I used to work for the usual suspects, Cisco, Broadcom, Avaya, Ericsson. I don't know if you've heard of any of those names. So today I work in Bytedance open source program office. And Bytedance, like I mentioned, has 50 plus open source projects. So it's our job in the open source program office to talk about them, to evangelize them, to influence the community to adopt these projects. And this is one of the ways in which we are doing. We are having a Bytedance Developer Summit to inform you and also to acknowledge the developers that who have worked with these open source projects throughout the year, and I'll talk about them later. Fun fact about me, my master's thesis was in computer vision before AI was even a thing. But sadly, there were no jobs in Bangalore, which is where I graduated at that time. So that's why I moved to networking software. And any runners in the room? Oh, two. Yay. So maybe, I know, Kirlo, you're not here locally, but maybe you, maybe we'll meet each other on the trail sometime. I like to run outside and yoga is how I can run. And I'm an artist when I'm trying to de-stress from my job at tech. So we have a program called Bytedance Open Source Innovator Program. So please pay attention to all the open source projects that you'll be hearing about today. And if you're inspired, which I hope you would be, because we have awesome presenters today, um, and you have ideas on how you would want to use these open source projects in your day-to-day work, or you have some new ideas about that, we want to hear from you because we want to encourage the work in open source. Now, why should anybody work in open source? Can anybody tell me why? Why do they think they should work in open source? Yes. Can we pass on the mic to him? Thank you so much.
Now is it on? Now it's on. Um, so, uh, so I've been using open source in Linux since 1994 when we built an internet provider on Linux. And even back then, being able to leverage open source for that small business, what that meant is that we got to market faster, but
Mhm.
also by giving back into that community, we got to be sort of on the, at the leading edge, no pun with the previous thing, kind of on the leading edge of technology at that time. And so as a kind of a small or medium-sized business, once you get to know those communities and the technology base very well, what seems insanely risky to other people, you know, is okay because you know the community, you can leverage those assets much earlier than the broader market does. So that's one of the ways I think open source works great.
Thank you so much. And did you have a? Oh,
Hi, my name is Svikar, and I'm currently working as open source contributor for Apache Kafka.
Mm.
So in my previous role, I'm a software engineer. So I work on T-Mobile, Ericsson, IBM, and yeah, so those companies heavily used Kafka. So I was always fascinated to learn what's behind the scene, what's cooking behind the scene in Kafka, how those architecture and everything works. So and I only know like Java very well, and I came to know like this open source project Kafka is heavily written in Java and from LinkedIn. So I learn a new technologies every day, Kafka, and there are lots of community. They are trying to update loads of faster. So you really get good exposure if you're working on open source, and you really get like very good like the best of the best people from all of the other companies around there. Things really feel like proud because Kafka is used, for example, lots of companies around the world, right? So they always passionate to contribute. So
yeah,
that's the
that's
reason.
great. So, um, exposure for the company, exposure for the individual, learning new technology. You had something else?
No, that's it.
No, Chris had something. And then I'll proceed because I would run out of time.
Yeah, my was like new. I'm new to open source, and I working and I want to get up to date with like latest tech. So one day I go to meet up to see the event, and I found about Sujata event, and I feel in the farm. I learned about Babit MF. It was really cool. That was the demo that day was about using it to create a rack model to for video search, and it was inspire, and then got a chance to learn all about the framework with the greatest people ever. That's
Yeah,
great.
thank you. So full disclosure, Chris is going to be a speaker today. So he learned about BMF and he worked on it. So yeah, thank you guys. You actually covered all my points. So you work with talent outside your organization. You're able to upskill. You can do career shift. Like, you want to learn a new technology. Open source is a really great way, gives visibility, ability to choose on what you want to work on and choose a project that makes a difference to you. So yeah, so this is what we want to encourage Bytedance Innovator Program. So we give you recognition. This QR code is if you are interested in becoming an innovator with us, you can just fill up that form and then we'll get back to you on that. Once you're an innovator, there are some limited, perks available. I shouldn't say stipends because it's not a lot. It's more of a recognition. Of course, developer spotlight. We want to always shout out your accomplishments. And our engineers and maintainers will work closely with you once you're approved. And these innovators will be talking about that next. So since I don't have much time, I'll just take names of these innovators who were recognized this year. Some of them are here in the room today. Chris and Anna are. Kirlo is here in the room. Russ and Zach Jappel, Ate, Saurabh, Yannick, and Kelvin, all of them are not here. But they have done awesome job in working with these open source projects. They have created tutorials, videos, they have contributed, they have found new use cases of the open source projects that we ourselves did not think about, and build new communities, have been champions of these open source projects in their own companies. And today we'll have 5 innovators talking at Developer Summit today. Like I said, Chris, Anna. Now we have Meet and Yashas, who are like, newest entry to our innovator program, and Kirlo as well. So like I said, you get a spotlight and you get showcased if you're part of an innovator program. And there are new innovators who have been inducted into the program. I'll not read out all the names, but you get the gist. So here is the agenda. People have been asking you, all of you probably have come through the meetup. The agenda is there in the meetup as well. And this is what I was talking about. This is the event feedback form. And in return to that, you'll get this fun sound bar. One lucky winner will raffle it towards the end of the conference. Okay, this is the second half. Lunch will be provided. So with that, I will give the floor to Tina. I think we're at time, right? Tina and Wilson. So while they set up their slides, let me introduce them. So Tina and I, we work in the same open source program office. Tina is a seasoned AI professional with extensive experience in machine learning and open source technologies. She's been pivotal in integrating open source AI solutions within Bytedance. Wilson Wong is a software engineer specializing in OS kernel development, hardware virtualization, and lightweight virtualization like Wasm. He actively contributes to projects like OpenCruise, etcd, and Argo CD. So please welcome Tina and Wilson.
Hello, everyone, and welcome to the annual Bytedance Open Source Developer Summit. We change to the Dev Day. My name is Tina Zhou. I'm the Director for Developer Relations in Bytedance and oversees the Open Source Program Office overseas. And before that, I joined Bytedance this year. Before that, I spent 7 years in ARM, being the Director for Infrastructure Ecosystem, and prior to that, I was the fellow for Philips Lighting for 2 years, and I spent 16 years in Huawei and FutureWay as the technical expert and also the leader for standards and open source, mainly for routers, switches, and servers. I'm so happy to talk with you today. And alongside today with Wilson Wang, we'll be exploring how Bytedance is empowering the developers with AI open source. So the purpose of this presentation is to introduce Bytedance suite of AI open source projects and showcase the ways in which these projects empower developers globally. How many people have been using like codes? Raise your hand. Using mass code? Raise your hand. Okay, I'll get you using it after the launch. um, so our goal is to illustrate how our AI tools, resources, and frameworks can demonstrate AI development making it scalable and flexible for all developers. Bytedance AI open source is a suite of tools designed for scalability and flexibility. Our mission is to democratize AI development, providing developers with solutions that can be deployed across a wide range of environments. Let's discuss our key features. We support distributed computing for scalability with deployment across both edge devices and cloud instances. Additionally, our tools are flexible with modular components that can be tailored for specific use cases. Like today, you use the coding. I don't know, you probably use the other like Copilot, Devin, and Mars Code. Today, maybe I feel like 20% of the features were complicated. You put some code there, it can come up with to complete your code. But if you wanted to do the detail requirements, design the ALD, it doesn't work properly. If you wanted to do the proper debugging, it's not 100% meet our needs. So we wanted to complete the gap. So, and support for real-time processing in cloud or edge environment, Watson will talk about more. I think Api also mentioned some of the cases. So one of our key priority is making AI tools developer friendly. We focus on intuitive tools and APIs, comprehensive documentation, and building a supportive, collaborative community for all contributions and contributors. So think about you are a developer, you come to the office, you turn on your laptop, and you say, hey, and what's the upstream open source software? Do they have their new version? Do I just import into my products? No, I need to verify and validate whether it's actually working, no problem. I don't want to create any code crash for the company. So for the whole through the day, and then you have a design meeting, you want to take notes, and you started doing your design and coding. You want a really your buddy for the AI developers and your buddy for the more advanced coding for you to do, right? So our AI open source portfolio includes ByteIR, an end-to-end model compilation solution, and veScale, a PyTorch native framework for parallel training, Diffusion GPT for text-to-image generation, and Spear, which is part of Infinite Edge AI, by the way. I'm wearing the shirt of Infinite Edge AI today. A distributed AI agent OS. Each project is designed to tackle specific challenges in the AI development workflow. Many industries benefit from our AI open source tools. For example, IoT applications can benefit from real-time analytics at the edge. Robotics can gain advanced perception and control, and the healthcare can leverage AI-driven diagnostics and monitoring. Here is a real-life example. We deploy AI models in a smart factory setting. The outcome included a 30% improvement in efficiency and reduced the data processing latency, demonstrating the power of scalability and flexibility in the AI applications. To help developers get started, we have a GitHub repositories for our projects, detailed documentations for setup and deployment, and the community ready to support you through the forums, webinars, and workshops, hackathons, and meetups. We welcome contributions. You can join discussions, submit the pull requests, report issues, or even advocate for our projects within your own networks. Together, we can shape the future of AI developers and developments. Our roadmap is ambitious. In the short term, We are enhancing edge AI support. In the midterm, we are expanding our collection of pre-trained models. And in the long term, we aim to establish these projects as the standard tools for AI development. We are always open to collaboration. We are seeking partnerships with other tech organizations and academia, open to join the R&D projects and eager to engage developers through community events. So I will let Wilson to talk about our Spear projects.
Thank you, Tina. So, okay. Hi, everyone. I'm Wilson Wang, and today I'm going to talk about one of the open source project that we have. It's called Spear. So Spear is like AI agent OS, and the goal for this project is like want to provide a global unified like executing infrastructure for the for different AI agents. And in the design for Spear is that it's highly distributed and also it's agent centric, and we want to support multiple different runtimes. And most important is open source. So I will talk about the details. Okay, so here it's all platform basically allow you user to use like AI agent to run seamlessly across all the cloud, edge, and the endpoint environments. And here we can have the different environment. For example, like for the portable devices, we can have like or cell phone, we can have or laptops or some like other devices. And for the edge, like we also want to take advantage of the edge computing power, like the for some of the for example small like the small edge small edge data small data centers. And actually for the large data centers, we'll have like more GPU resources. And in case of some like the resources not enough on the edge, then we will shift some of the requests to the data center. So all are done seamlessly across the different like the regions. And okay, let's go to that. So the next one is actually multi runtime support. So like right now, people developing the AI agents in different languages and using on different platforms. And what we want to do support is like we want to support like the Docker containers and like also some of the Linux processes, because for example Linux processes like for example Longchain and people developing different like AI agents. We actually want to support these cases so that the user like the existing AI agent can be running on our platform. And most importantly, the WebAssembly is something that in progress. So the WebAssembly compared to container is more lightweight. So we want to have like WebAssembly support on our platform, so that later the AI agent can be run, can be start up and shut down very quickly, like within a few like millisecond or even lower. Okay, this is the general architecture for our Spear platform. So when you see the red boxes, it's as a component in our Spear platform, and there are other components around it, like for giving support. For example, we have like backend support. We can run model as a service to like in the backend, so that we can take advantage of different different models. And we also can have some, for example, like we are actually working together with other projects. For example, Opia, it's from Intel, so like they can provide like other like more features to our platform. And on top of that, we want to support different agent frameworks, and also we want to have like other, like for example, like vector DB or related data and knowledge support. Okay, so we're actually collaborating with this is a collaboration among different different organizations, and this Spear project is open source under the Infinite Edge AI, which is a part of the Linux Foundation Edge. And we're also working with Intel's open platform for enterprise AI, this is called Opia. And me myself, we have engineers who are working from from Bytedance global edge team. So we actually will make sure that this platform is distributed and the traffic can be directed to the most appropriate place to get processed. And we're actually working with like the Southeast University. They have they have teams like working with us and to try some of the new advanced technologies. And for the WebAssembly runtime, we're actually working with Western Edge and to make it possible later run WebAssembly on our platform. Yeah, that's the part from the Spear for my part. Yeah.
Yeah, so the Spears architecture supports both open source and proprietary models, various agent frameworks. We also have the AI agent marketplace in the Infinite Edge AI at the wiki page and repo, and also low code platforms. I just mentioned codes, and there are many the others. And are the best tools. We are excited to continue building collaboration that enhance this ecosystem. Thank you for joining this presentation. The floor is now open for questions and feedback. You can contact me via email or explore our GitHub repositories for more information. Yes, that gentleman, can you pass the microphone? You'll be next, don't worry. Turn on the microphone. No more battery? Yeah, so we're still living in the physical intelligence world. So. I can use my mic.
Use this mic. Yeah. Hello?
Yeah.
So my question is like, is it possible for students studying at some Indian university working in these projects by collaborating with your company?
We already have students from Stanford University. What are you talking about?
No, I'm talking about the India
Yeah.
universities in India.
Of course, we already have universities southeast from China. Of course, Indian is from Asia. Of course, welcome, very welcome.
So I can get in touch with you, like to connect with
Yeah. Join
students.
our lab group. Give him the barcode to scan in. Yeah. Why don't you print, put it here, print a barcode, put it here, and people can scan, or put it there. Yeah. So you have questions?
Sure, I'll stand up. Hi, my name is Yeshis. So I know you mentioned about the WebAssembly and you were comparing it to the Docker containers. So I was just wondering, like, if you have more specific information on what the difference is between the two and like what exactly makes WebAssembly more optimized.
Yeah, for WebAssembly, you can think of as more lightweight JVM. So for Java, like it's JVM is very heavyweight, right? You have classes that running on top of that. But for WebAssembly, it's very simple. It's just like virtual ISA, like virtual instruction set architecture. And yeah, that's the WebAssembly. So basically, it's very lightweight. It can be brought up and shut down very quickly.
Okay, got it.
Yeah,
Thank you.
compared to container, I think it's one level like faster than the container. When the container compared to VM is one level faster, right? So yeah.
Got it. Thank you.
Yeah. Also, one more question. Can you pass the microphone? One second. Can you pass the microphone? Yeah.
Thank you. Yeah, my question is, since you mentioned the agent AIs, so is this going to replace for example, the OS on laptop or just on top of a layer?
So right now, the design is just, you can think of it as a platform, but our final goal would be, make it more like for a platform, in order to make it running faster, you need to do a lot of low level stuff, for example, like kernel modules. And then as the platform grow bigger, definitely will make it, like will make the layer like OS underneath it more like black box, or we need to have a or highly customized kernel, something like that.
Thank you.
Yeah, so you don't like we have two kinds of AI agent. One is more to developers, and also two kinds like for the beginner of AI developers, and you it's happy to use. The other is more like advanced. You can still see some of the lower level things, and we also have agent to the industries like to finance, to fashion, to gaming, those things. Yeah. Go ahead.
Yeah, hi. My question is at the intersection of your talk and the very first gentleman who gave the keynote. So it's from the perspective of an end user application developer. Let's say I'm building generative AI apps or virtual reality apps as such. What tools or technologies are available in the stack that let me focus on the experience and not worry as much about the infrastructure? So it can abstract, oh, maybe this workload should run on the edge and this should run on the cloud, or this should just run across both of them. So that's my question. Yeah.
Yeah. So that's why I said we have a AI agent marketplace. We already have the codes as the first offering in the marketplace. And so, for example, in September 11, we have AI hackathon. We have the director of design from Max Mara, is an Italian luxury brand. The lady has nothing, doesn't know any technology. They just come in and we do the tutoring, and they won the champion. They won the champion of the hackathon. And we also have people from the finance industry doing the CRM and people doing the robotics. Yeah. So the extreme case is the fashion people can even use our AI agent to win a hackathon champion. They don't need to know the details. But they have the know-how technology about all the fashion and the user behaviors. That's the key. That's we don't know. They know, right? I think this is the merits and the beautiful place of AI agent. Other questions? Wow. Okay. Thank you, everyone. Talk to you more.
Thank you so much, Tina and Wilson. So now we have a break before our next talk. We will resume at 11:20. So people online, you can also go get coffee, restroom break, and we'll meet at 11:20. Thank you.
Long time no see. Yeah, long time no see. So how are you? It's like I didn't even realize you were at Bytedance. Oh. Because you've been at ARM for a long time. I know. Just, oh, you guys know each other? Yeah, she was part of one of the elements. Oh, yeah, yeah, yeah. I chased her. Yeah, good for you. So, yeah. Yeah, I just had lunch with Sujata like a couple of weeks ago. What project are you working on right now? So I'm at PinCap. So you probably know who we are. So we member summit or in the PICO. Oh, okay. Yeah. It was probably at Huang. No, that's yes. Yeah. And I also attended the summit. Oh, okay. Last year or this year or last year? Okay. Yeah, because I was talking to Sujata about doing like a joint meetup. Like we can probably, because it looks like you guys have like a bi-weekly AI meetup. Yeah, tonight is Yeah, so I'll talk to like Wilson about that too, but maybe in the future, like we can, yeah, or I mean, I unfortunately need to leave like in like about an hour, but in future meetup we'd be happy to like participate. Yeah. Okay. Yeah. Okay. Yeah. I mean, we can come like in like January or something. Or like our senior architects. Like, I mean, our founders they're on plane most of the time.
So Anna, you should have
But we
the
have
meeting invite
like a lot
now.
of architects here
If
that
you join the
talk
meeting, you
about
should
our
be able to share
database
it.
and doing like especially in the AI space what that is very. Yeah. I mean, we're like I think we're registered now outside of China, but yeah. No, but our founders are Chinese, right? And the bulk of it. Yeah. I mean,
No, meeting invite.
yeah, our CEO Max, he
Should be in your
even in the
calendar.
office with Chinese colleagues, he uses to speak Chinese. Speaks English, so I'm good for him. Like, so yeah, we should definitely. I mean, we can even host you guys at our event too. Like, it's easier to get outside people to like come in because like their challenges to security and things that we have. We're at Plug and Play in Sunnyvale, but we also have a SI partner that are in Santa Clara. So yeah, if the venue is something that you want to provide. Oh, okay. Oh, okay. Yeah. So is your meetup, like I'll talk to Wilson too, like is it mostly like Bytedance employees or do you have people that are on site? Oh, okay. Okay. So yeah, we can advertise it to our community and have people come and about what we're doing. No, I know. Yeah. So yeah, we can figure something out. So yeah, it's good to see you. It's like it's a small world. So no, it's funny. Like I saw the agenda and I saw Arpit and you as the first two speakers. I'm like, this brings back memories. Yeah, I have to go.
Just one is fine. Anytime.
Cool. It's good seeing you.
I've been
Presentation. Wow, you're still in open
got to
source.
take Wilson's.
Like, I mean, it's once you're in, you're hooked.
Did it? Yeah, let's put it on the log groups.
Oh, I can't.
It's not that cool anymore.
Yeah, that should work.
Okay. I just joined. So, we use Lark too, obviously, so
Okay,
it's
you
easy.
joined?
Yeah, I just
Perfect.
joined. So. You have Lark on your phone? Oh, okay. Just with your camera. Yeah. You must do, I guess you must need to do some setup or something. I don't know. Like, because I've done such a long time ago. Let's go with it. Yeah. Yeah, sorry. Like,
He's using Android.
huh? Android? Oh, okay. Yeah, I don't know. I don't know why that would make a difference. Hey, Wilson. I'm Ryan.
Hi.
I'm from PinCap.
Oh, hi.
So,
PinCap,
yeah,
I'm Stacy.
I've known like both Tina and Sujata for a while. So then we've actually been talking about doing like a joint meetup or something. But it sounds like you already have like a meetup that's going on. So, yeah, Tina was asking. Yeah, we'll be happy to.
After the break. Hello, hello.
Hello, everyone. So now we have, I hope everybody is settled after the break. So now we have Dr. K. Jing, Senior Product Manager at Bytedance, specializing in PICO XR's OS, developer products, and ecosystem. He will present PICO virtual and mixed reality developer tools, exploring the innovative features and major upgrades of the new PICO 4 Ultra MR headset. Thank you, Dr. K.
Yeah, thanks, Shweta, for the introduction, and welcome to the Bytedance open source talk. And PICO is one organization under Bytedance, and I'm a product manager working on its developer product. And so, first of all, how many of you have heard virtual reality or mixed reality, or just okay, cool, 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 yeah. So if you are new, today is also a good chance to learn what we offer. So PICO has been in the VR space for about 9 years. We most of our developers are actually based in US. This is our latest headset, PICO 4 Ultra, and then it's our standalone MR headset. So you can see the dual camera at the front, it detects steps. So today I will walk you through all the XR capabilities and then the developer products. And then we also will talk about the opportunities we can collaborate with open source developers. So this is the overview of our hardware and OS capabilities. So you see we use the latest Snapdragon chip, and then we have the the new camera, the lenses, some OS features. You can actually wear the headset and have multiple screens in overlaid around you. And then we use the dual camera is very good for spatial video. So you take the video and then view it spatially with depths. And then we have multiple interaction support, like controller, hand interaction, even connecting with mouse and a keyboard for some work use cases. Another device or hardware we release is the new PICO motion tracker. So this is like a 6-DoF tracker. You can put it on like a cap or put on your legs, and then be more embodied in social VR. Like VR chat has used this. Other like VR like fitness or dancing apps have used this. So an overview of our developer resources, the best places to find is first on the developer website. It's developer.pico.com, where you find the like all the newses, documentations, and resource to download. We also have a Pico developer GitHub where you can get the SDKs and some sample projects. So, so first of all, for developers, like we put our capabilities through the SDK. This is like our all-in-one feature SDK. So it includes fundamental features for like rendering in VR, and then mixed reality capabilities, input and interaction support, platform services, spatial audio, etc., etc. It supports Unity and Unreal, and we also support web platform and the native platforms. Most of our developers actually they are also working on like Meta, so we have very good reputation in the industry. If you have apps developed for Meta, like it's very good to just port to Pico. So you have a market in China and many other countries in the world. Some developers they come from the enterprise background, so they are solving some really like training, simulation, medical use cases. We have the most developers actually based in the US, so that's why I'm here. And we have very good customization for these enterprise developers. We also have a OpenXR SDK, it supports Unity and Unreal. It's very good for the cross vendor OpenXR development. We recently launched like a AR foundation framework. If you are like a mobile developer, you know this framework. We add a support for that. So just an overview first of the mixed reality development. So we have key features like capture the objects in the scene. This is like a wall, this is a painting, this is a sofa, lamp, etc. And then we can create meshes, we can create anchors, and then share the anchors. We can go and see this demo. This is a demo we did at one of our launching events in Beijing. So this is a demo area, and then as a person walks around, the headset does like real-time mesh scanning of the environment, so you can see the the meshes created. And we in our latest update of the SDK 3.0.5, I believe, we added more object labels. Before we had like 7 labels. Right now we can recognize like bed, painting, cabinet, screen, a refrigerator, washing machine, air conditioner, lamp, wall art, etc., etc. And then you can do some creative stuff with these things. Next, we can see this demo of a spatial anchor. So here, like I was placing some like slides, and then these slides are like anchored in space. So if you move around, these virtual objects stays where they are. So you can design a game based on like the physical distances, and then do a little educational thing in mixed reality. Next is like an interaction demo. So our interaction support include like basic controller handset input, haptics, local motion like teleportation in VR, hand tracking interactions, custom hand gestures, spatial keyboard, and we make it really compatible with like industry standard tools such as the Unity XR interaction toolkit and then the XR hands. So it's easy for developers to build. And yeah, this is the controller locomotion. This is the haptics. Yeah, you will feel the haptics when actually clicking the objects. So this is the demo of the hand interaction. You can see we have the support for the hand arrays, and then different ways you can use the gesture. Also a scene you can test the create your custom gestures like a Spider-Man gesture. You can create that with your hand. And for the rendering features, we're also giving away very high quality scenes. Even if you don't use this for VR, these objects, these assets are all free and open source. You can grab this scene for your own development. This is our one of the projects we were about to release. It's like a high quality cyber alley thing, like a 3D environment, and then it's used for like profiling some of the the graphics resources. So we're also giving away these free assets you can use for your projects and demos. And this is our another latest work in progress, and we are releasing it soon. It's using the what people say is the next approach of rendering. It's using Gaussian splatting. So different from traditional like triangle-based meshes, this is using what's called Gaussian splats. So it's very good for rendering details like textures, hairs, laser services. This is a thing we scanned and rendered. Like just if you recognize this table tennis in the office area. So we are first just want to send this out as soon as possible on the Unreal marketplace as a plugin and a demo app for developers to experience, having realistic scene and view the splats on headsets. And then this is some demos for the motion tracker. I see like the left video. We put the tracker on the legs, and then this is some of the testings. And you can also on the right, you can put this tracker as like an individual object tracking tool. So you can put on the like a can or like a a stick or a sword or something. So we also have this capability called a spatial audio. So it's like a concept of spatializing audio around you, so you can hear the sound more immersively. And then we have a sample scene to test all the functions. This is another latest framework we are working on. It's it's called the Spatial ML framework. This is a concept video of it recognize people's faces. Besides that, you can also deploy your own models like a object recognition model. So its own device model, like the work that Winston worked on. So you can deploy a model on the headset and then use the pass-through data. So our system will return the results to you. So you don't need to worry about the privacy and then the the constraints of not getting the camera access. You can just deploy a model and then get a result, and then use that to build your apps. So we are also launching that in next year. PICO also has a very good and open avatar platform. So we have different styles of avatar, from like cartoon, anime, and some other new styles. So we recently updated the avatar SDK to 2.1, and then you have a asset management platform. You can upload wearables, heads, and then customize your avatar and then share it with other developers. So if you upload avatar, set it to public, other developers can use it. We also provide some official avatars, and then you can use it in apps. It's very good for social VR and just start a project with some characters. So to summarize, we have a variety of different resources, and we're trying to expand to more users and be more open. Though many of the samples are like in Unity right now, we are working on Unreal's support, and we release some samples next year. And we're also actively working on long-term projects for the native Android and the web. So stay tuned for that. As for collaboration with the Bytedance open source program, so one of the examples we did in the past is like we collaborate with a developer in a different country, and then we send them the device, and then they make like a video tutorial. You can also just develop based on our open source samples and assets, and we can help you promote. We can go through the the application and then help you iterate the ideas. So if you like collaborate with us, we can have you as one of our like early testers for our future projects. And just there are ways to stay connected. One is like follow our Twitter. We also have a Discord community you can join, or you can just search me. My email is here. Search my name, Kejing, on LinkedIn, and or just come and talk with me. And then hope you enjoy, and hope we can collaborate more in the future. Yeah, thank you. And feel free to ask any questions about VR, about PICO. Yes, please. I think it's PICO, because it's if you want to upload the assets, you need to register with the PICO developer account. Yeah. But the assets, I think they are under some license. I need to double check, but I think it's for PICO. Yeah. That's a good question. I don't think we encourage that, but I think it's called PICO Outer SDK, so it's PICO. Yeah. Yes. We're not open sourcing that, but I think we will have sample projects. You can see how you deploy your own models, and like grab like off-the-shelf model and put it there. And the sample projects will be open source, but like the detailed implementation, we might have a plugin that's not open source. Yeah. It will be more clear next year. Yeah, but. I think we'll have some of our first-party models, like we just put there, and now you can see ways to put third-party models to use this framework. Yeah. Yes, please. Yeah, the first question is about how do you deal with safety. Is actually in our latest SDK, we enhanced the MR safety. So if you go to the news web page of the developer, you can see like when you touch the surface, it's gonna show you like the real hand, the real surface, even though there's a virtual content. So that adds to your safety. We also have like a safety zoom. It's all real time, and then it just reminds user there's a boundary if you VR. So that's some of the implementation we had. Yeah, yeah, please. I don't think we have that, but you can implement maybe using the I don't think we have sensors to detecting temperature, but like mostly if you build an app, you can use the pass-through, and then it's all based on like maybe your knowledge of the environment. Yeah, we don't have specifically have building functions for temperature detection. Yeah. As for a second question about addiction, I think it's a good question for addiction in VR, but as a platform provider, we don't have any guidances, mostly for developers to implement how the game can be like not so addicted. But we have some general rules of design for VR and the tools we provide. But like, what's maybe your concern specifically about VR addiction is a a problem? Like what do you want to unpack it a little bit more? Yeah, we can talk also offline about this. Yeah. Okay. Yeah. Thank you. Yes, please. Yeah, I actually heard a GDC talk about like oh yes, the question is like if you have a game for MetaQuest, and how easy would it be to port to Pico, right? So I heard from like a GDC talk this year, it's about like one engineer about 3 weeks, maybe like another week to QA and test. So about like 3 weeks to port it, because most of the functionalities we have very good feature parity over the past 8 years we're in the space. So basically, I remember they mentioned on the slide, we run some Quest, run some Pico. So we actually, a lot of developers, they build for Quest first, they have the game, right? And then they reach out to us, they want to get into the China market, and then they want more users, build cost platform. So we have a good feature priority for that. And then it's just gonna implement like the input, and then the SDK, the features, API, you have a different branch. For example, is for Pico, and then maybe another branch for another device. Then you switch branches, and then you replace the SDK and the function APIs. I think that's how it's done. And then if you are like a game developer working with us, like you have a big game title, we have a team to support you for the process. Yes, Matt. Yeah. Mm-hmm. Yeah, we use the platform SDKs we provide, and then basically you need to create like an account and then use that. It, I think it's mostly for co-located experiences, like two people together. Yeah. Yeah, I have to check the details, but I do think you need to connect to the Wi-Fi. But I can maybe check the documentation, the technical details. Yeah, absolutely. Yeah. 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 Yeah, so another good question. I think you can, the SDK will provide you APIs for the semantics, right? Like this tables, like maybe one person do the mapping and then save those labels and then data to another person. Yeah. But Yeah, so as a developer, you can get those data and then implement your own solution to share. The solution we provide is basically to connect two devices in a shared space. Like if you share other information, I think maybe you can use other third-party networking solutions or to share more data. Yeah. Yes, please. Yeah, the models are, they're not like, so we focus on the XR related things. Like the models, like we provide the spatial ML framework is like a framework to deploy your own models on the XR devices. Like the models, we don't provide like our first party models, but like we provide the framework to use them on our device without worries about privacy and the camera access. But like in the future, maybe when the camera access in the industries is more open, then we will also think about how we can be more open to that. Yeah. Right now, there's no specific plan to release like our models. Yeah. But yeah, there are many good models you can deploy. But and we were mentioned like which are those and the support. Yeah. Yes, Tina.
Can we try PICO today at this room?
It's good. Yeah, I can bring one device down. Yeah.
Yay.
Yeah. 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 I think. Yeah. Thank you.
Thank you so much. So now we'll have first innovator for the day, Anna Sims, presenting Gralex, sorry, preserve privacy by open sourcing synthetic data generation.
Javier, can you take over by the digital character? Javier, we are at the after PICO presentation. 请主持. Can you hear us?
Oh, yeah, sure.
Yeah, can you take? Yeah, can you run the meeting by the digital character?
Sure. Just want to make sure the next speaker is Anna, right?
Correct.
Okay.
Are you ready? Javier? No, sorry, because this is our new character. Can you play now before Anna's talk? Javier? Can you play the digital characters?
Oh, yeah, sure. Give me 1 minute.
Oh no, let's skip for the. You really need to take 1 minute as a digital thing?
Yeah, maybe half a minute.
Okay. So maybe you start. Please get ready. Start after Anna's talk.
Okay.
Thank you.
Okay.
Yeah, so like I earlier said, She's a Bytedance innovator, open source innovator. She works on the project BMF, which you see on the board. She's a winner at Hack MIT and quite a few other hackathons that she can tell us about. She has diverse experience as a design engineer and XR developer, contributing to research projects on carbon emissions and deep learning.
Hi, everyone. Okay, so I'm going to start by introducing you guys to the actual framework that we're going to be speaking about. So not just me, but Chris and some other people are going to be speaking on this framework. So just so you guys know what it is, I'm going to tell you.
Um, Typically, the project leader would introduce BMF to us, but then he is sitting all the way in China. So this is not a good time. And it speaks volumes that he trusts our innovators to introduce the framework. So thank you.
So this is the leader is Xiaofei, and he is a fabulous leader of the group. He's done a lot of help with us on building on this framework, and this framework is super cool. You guys are into video processing, so it has like 3 different names. All of them essentially are the same thing, but basically it's a framework that helps developers to construct and develop efficient and versatile video processing pipelines, which is like probably the simplest way to put it. And so if you're wondering like maybe what could you use it for, there's transcoding, editing, meeting, broadcaster, and GPU acceleration, which is what I used it for my project, and AI integration. So there are so many use cases, but I included these ones specifically because there are actually collabs where if you want to test it out today and experiment with your own, you can get started pretty easily to really figure out how it works. And then some of the key features include the multi-language interface and modality, and the graph-based processing and scheduling, which is a personal favorite. And it's really nice that if you work with videos, it is compatible with FFmpeg, and then GPU acceleration and heterogeneous processing. And then you see some of the multiple processing modes. I'm not going to go through them all, but you can see them there. And yeah. Okay, so going into the project I've been working on, the title of my talk is going to be Preserve Privacy by Open Sourcing Synthetic Data Generation. And I've named the project Graux. So before I get started, I did want to introduce myself a little bit so you guys know who exactly is talking to you guys about this and why exactly this project's being built. So my name is Tiana Sims, but you guys can call me Anna, and I'm currently a data science student at the University of Michigan. I've worked part-time as an XR dev and lab manager for 2 years, and I've done a lot of things from being a trader in New York to doing design engineering in Boston, and then just being on several research teams, everything from exoplanet characterization to carbon emissions to computational finance and deep learning implementations of high-frequency trading. But my sweet spot, the thing that I'm really interested in, is how computers, AI, in the real world can interact in a meaningful way. That's my bread and butter. So I'm gonna give you guys 3 fun facts about me quickly before we dive in. When I was a kid, I was a little bit different. My family used to go to Disney World every year, and all the kids want to be princesses. I had something else in mind. I wanted to be the evil queen and like characters, and so there's a photo of that. I've also adopted a son, and he's very spoiled, as you can see. And he kind of takes over everything, but I love him anyway. And then finally, in 2023, I spent the entire year flying out to a new hackathon every other year, every other week. I bought one of the Frontier passes on Black Friday, and took advantage of that when I was flying all over the country at these different hackathons because I realized that I needed to upskill. And this is what really helped me to do it and helped me to really execute on some ideas I wanted to work on that I'd never really taken the time to actually do. And I loved it so much, I forced my little brother into it as well. And so he loves it and he's doing robotics now. But I bring this up because the project that actually got this all started and the basis of this project, where the idea came from, happened at a hackathon. It was a little bit different. You guys can check it out. The QR code to the dev post is here. But it was just as a text data mask that preserved context. But I want to take a step further after that because I realized this is actually a huge need, especially moving forward. And so with that, I decided to and it eventually evolved into what is going to be a multimodal data mask that preserves vital context for training data that are used to train different models. So the problem is that the training data that we use for fine-tuning commercial LLMs and other LLMs require masking or removing of private data. The issue right now is that our methods of data masking also cost vital context that decrease a model's accuracy and abilities. To kind of give you an example of what the traditional data masking look like, you could kind of see it here. You see you lose her face and things like that. And for basic information like her name, sure, no big deal. But you never know what the AI is actually going to be used for, especially when it comes to a multimodal framework. So in terms of text and audio, this just kind of gives you an example too of vital things that are lost when typical like words and things are masked or blacked out. So as you can see, vital things like his name, maybe his location, things like that could all really be important. And then this is where I think it has the most relevant use case today, which is in dash car cams, monitoring drivers, or in self-driving cars monitoring passengers. Because as you can see, there's not as much data you can get when his face is like that. You can't see his facial expressions. You can't see if it's a man or a woman. You can't see the age. You can't see if they're wearing glasses. So there is so much valuable information data that can be helped to make these models more accurate that it's just being missed. And there's no way for us to really, solve that issue. At least there wasn't. And hopefully by the time this all is done, we have at least a decent working solution. So the idea is with the recent developments, especially with video generation, we're able to solve this problem by automating multimodal synthetic data generation, which is typically super expensive, not very good, and just not genuinely available to the average person who doesn't. If you're not like a big company, those kind of resources just aren't available to you. So the idea is to build a system that is open source and that everybody can do it, use it, and that is affordable for everyone. So I'll take you step by step by how it works. Okay, so first, you're gonna upload a video. So like I said, I think autonomous driving is probably or dash cams are like the most prevalent use case maybe right now, one that you will see. So that's the specific example I've been building for, because this is a rather complex system. So taking it step by step. And the first is just monitoring drivers. So we'll just go ahead and see like this clip that we'll be working with. Yeah, so think videos like this. This has already been split. So right now where it's at, it does scene by scene, because there are going to be situations where the scene's changing, where you'll see later on why it's important that if there's a dramatic change in the scene or perspective, it's going to be a big deal. So the first step is just splitting into those separate scenes that are more or less stable. Sorry, the media is being kind of funny. Yeah, okay, so that should be an image. So imagine that's just a picture. So what I used BMF for was the hard part is extracting frames from these videos and using the GPU acceleration to do that. So this is where BMF really came in really handy for this part. So, and it's also handling when the videos are processed out as well. Oh my goodness, sorry guys. Does not like videos. Okay, so the first thing, once that frame is extracted, that image, it actually goes through, I sent it through a dense captioning system, which is basically ChatGPT that can understand video and explain to you what's happening in the scene, what's the scene look like, and things going on. So I chose not to go with the video for processing and expense purposes. It's easier to process a frame, and for what we need to do in the next part, that's all we need. But so what you'll see is from here, it'll take this image, and you could see that it's using its positioning to really tell you kind of what's going on in there. And then it'll give you back something like this. And I took the time to highlight some of the things that would be considered vital context of this image. So that would normally be missed if it were blurred out like the other one image from before. So I'll just read it. So black and white portrait of a young African-American man with an average slender build. He has a slightly outturned, ungroomed beard and is wearing glasses, et cetera, et cetera, et cetera. It goes on to describe the exact scene. Now, this is particularly useful because we can use this prompt now that we know what's going on in this image, and we've identified those key terms to generate a new video that preserves all those key things without it being that person, therefore preserving his identity. So this is using Kling. I'm sorry, not Kling, Flux. So yeah, so this was generated with the latest version of Flux. The prompt that what you just saw is sent to Flux, and an image is generated that closely resembles the initial video. As you can see, the vital context is maintained. So after you do that, then we send it over to be animated. Okay, before I play this, this is a new thing that just came out like in October. So it's not great, but it'll give you an idea of where it's going. And I'm building my own custom one, but I'm building off of some open source projects right now. And so this is I picked this example for you to see kind of some of the challenges with low quality video, bad positioning, and night lighting. So as you can see, it's not great, but training is expensive. And it's also difficult, but the thing that's made it a lot easier, that's going to be really able to improve this as I continue forward, is using key point detection and using the graph neural network to interpret those points and to progressively and iteratively, whatever you guys know what I mean, go through and like expand it from the face to then include hand gestures and so on and so forth, and have more use cases. Okay, so some of the use cases to give you guys a better idea, we already talked about that, the autonomous vehicles. So whether that's detecting behavior predictions, so if a driver is maybe falling asleep, or there's road rage or something that, whatever they want to read that could be useful for that. And like I said, I think self-driving cars with passengers is also a really big thing. And the next one, which I think it is the most complicated one, but also the most exciting, which is in the healthcare fields, patient monitoring systems. And this is really useful for maybe in countries where healthcare isn't as widely available. They can set up a camera and have the patient either monitored. If something goes wrong, they could detect signs early, things like that. Or there's also surgical procedure training to give feedback on their hand movements and things like that. So that's another one. Then we have retail and customer service. They have, I should include the text with images, but you have the customer interaction analysis, which would be lost, especially facial expressions. Once again, is the biggest thing. Like facial expressions, you need those. And then theft detection systems. Smart home especially, nobody wants to be watched, even though we kind of know that that's going to be a thing. But the idea that the highest level of privacy is probably going to be in your home. So it would be really important to have these kind of systems for home security systems and active recognition models. And then education and training. Yeah, so I like this one about the students. You could tell engagement. and things like that. But maybe you could tell maybe girls are more engaged than boys for certain sections, and you could identify where is that if you had that kind of masking solution. And so kind of what's next, there's a lot to do in terms of improving accuracy with the key points, but that'll go and improve as video generation improves it. But the biggest thing is being able to process large sets of these data at a low cost, which is really difficult and is a problem I'm working on now. And then once that's able to be done, we can fully open source the project and then do all the deployments, since everything is going to be built using open source projects and resources into one single deployment method. And yeah, so these shout out to the open source projects that have helped me along the way and been great resources. I definitely suggest you guys check them out. Video chat especially, they've done some amazing work. And live portrait. And of course, BMF at the top, we love open source. And I hope that you guys will all stay connected. I would love for you guys to add me on LinkedIn. That's where I'm gonna be providing updates on the project when it's officially released, and updates and anything else. You guys can also just message me if we wanna stay connected. I wanna see what you guys are working on as well. So, yeah. You said evaluation?
Safety evaluation. Is there something done on that side? Make sure the model is not giving like unwanted content, and then how are you approaching that? Maybe there's like a continuous testing. The second question is, so for the video you showed, is there anything like kind of protection on celebrities, and then maybe some restrictions on children, because like deep fake has been a big problem.
Yeah, so these are actually all meant to be self-hosted, whether it's in a private cloud or anything like that. So the only people who would ever touch it is people who have access to the data in the first place. In terms of the protections for the deepfakes, I think the open source projects or like Flux and things like that have a lot of those protections already built in. So depending on what tools are built, I think the more customized parts, obviously that'll be considered, but the parts will be more so the key point estimations. And so that I don't think that'll be very applicable in that part. In terms of the evaluations is like a whole nother like aspect of this. That would be like a whole part 2 in terms of development. But the idea is to get the project out first, and people can build up their own evaluations because it's meant to be extremely versatile in different fields. This is just a starting point. But I would like to have evaluation methods at some point to keep testing and things like that.
Thank you.
This
low latency.
This cannot be done. I mean, it can be done in real time, but this is not something. This is meant to be used on data that's used to train models. So it's like data training says real time. I haven't even considered that. I'm working on another project that's processing real time data, and I just don't even want to go there with this project.
But could you take your frame-based concept
Mhm.
and apply that where you have a low sampling rate to still pick up basic human cues or behavioral cues from that?
Yeah, I suppose it could. I don't know. I don't know. That's a good thought. I haven't really thought about use cases with the real time, so I don't have a great answer for that. But that's something I'll definitely have to think on.
Thank you. Sure. So I know that OpenAI also has a feature called Sora that they're developing, which is based on like video generation based on like language like LLMs. So I'd love to know your take on that, and like how if there's any way your project may benefit from that as well.
So I don't recall, is Sora open sourced or not? Or is it the weights open? No, yeah, okay. So
I don't think it's open source yet.
yeah, I think that's the part where it becomes not useful for most people. That's why I initially started this, was because now there's a lot more open source projects than when I started, but the fact was that everything was closed and you can't send that kind of data to those companies who don't tell you what's going on. So it's great that they're working on it. What they do really helps people because eventually people figure it out and open source a version of that. So I think that's great. But I think there is definitely a need for a version where people have full control over it. But I also think these are really good for solving synthetic data solutions, which I really am all about synthetic data because I think where we're going with AI, it's going to be very important because models are only good as their data, right?
Yeah. Thank you.
One more question. Maybe provide something similar for sound, for voice.
Yeah, so I have the first part I did was the audio version, but the text to speech is not, the open source models are not great right now. They don't sound good at all. I actually did the webinar with the audio version. It's okay. Now, if I could use like 11 labs, so the way I did it initially, that was a whole different kind of framework. So I used, you have like an open source privately hosted language model. You use Presidio, which is a software that uses traditional methods to mask using from Microsoft. Use that to identify the key terms or whatever. Send them to your self-hosted cloud LLM. Get the equivalent. So like if somebody's name was John, you return Joe, and then that would be switched. So pseudo-anonymization with the text, and that text would be sent out to the text to speech, where that technically then could be used with more with privately used APIs.
Have you tried voice layering technology?
No, I haven't played around with that too much yet.
Very realistic, but in the future it may be. Is there any like fingerprint, watermark, or anything indicating this is AI generated video, or if it's multimodal, right? It's like image, text, anything. Yeah.
Yeah, so actually it's pretty interesting. NeurIPS had a invisible watermark competition. I definitely suggest you guys all check it out. They're going to be presenting their workshop at the conference in December, where it handles something like this, like testing if see if you could remove those invisible watermarks, which I think will be a big thing, and including in these models to confirm whether they're true or real. And I worked on that competition. I didn't get this submitted in time, but I learned a lot from it. So if that's something like you guys, I definitely at least check out the paper that they've been working on. It's pretty good.
I'll check with you the information offline. Thank you.
For sure.
So the online question is about data masking. Do you think it can add another layer of bias? Should we use the data in machine learning models? Do you have any idea on what can be done to reduce the bias?
So actually the whole point of this is to prevent bias. It was very intentional, and the example that I picked here is using a African-American man in the video because had his face been masked, the actual video is something happening with the customer in the black, which is blurred out for their privacy. You can't even see what's going on with them, which is also a great comparison, but you never know if that's like an indicator. So the idea is to prevent the bias by whatever it's switched out with is the equivalent in that perfect context. So the people who are running these models determine what context they want to preserve. So whether it's gender, age, maybe they wear glasses, whatever it is, they determine it, and we just switch it out with something that is the equivalent in that specific term, including like names. Let's say like you have a name that's like like specific to your culture or your language, it will switch it out with the equivalent to that, or as close as you're going to get.
Thank you. I hope that answers your question, Nicholas. Any other questions online? Okay, so thank you so much, Anna, for that. Tina, is the digital character going to introduce the next one? We cannot hear. Can you click play button?
Thank you, Anna, for highlighting the importance of data privacy. Next, we have a lightning talk titled Iris, an exploration of PII real-time censorship with Babit MF by Christopher Liu. Christopher, also Bytedance BMF open source innovator, is a software engineer at Advanced Technologies Group, LLC, working on federal EHR systems. He's excelled in various engineering roles and has won 4 hackathons in a row from companies like Google and MongoDB. He's passionate about blending technical expertise with user-centered design.
Hello. Hi, everyone. Thank you, Sujata, and thank you, Anna, for your presentation. We have a lot of things in common, too. And so today we're exploring video censorship with Babit MF, or the Babit Multimedia. And my name is Christopher. I'm a software engineer from ATG. It's a federal electronic health record for prison. And the talk will contain 4 parts: the background, process, challenge, and final thought from what I collected so far. The background is before I was a software engineer, I was a video editor. And a lot of times, sometimes the video come into me, like they have like license plate, credit card, or something that called PII, personal identifiable identity. And what I do with the video editing software is to select frame by frame and to blur them out manually, would take me about 30 to 60 minutes on average to finish a video content. And so when I got a chance to learn about Babit MF, I was like, wow, what can we do to save the time for the video editor? And so I found that Babit map compared to open famous video framework like OpenCV is it's you synchronous model with you can process video frame and audio at the same time, and also have multi-language support with Python, Go, C++, and of course it's used with Bytedance to be high TikTok and process million of video daily. The architecture is very simple, but we will talk more about that. So they have two streams going to the image frame and the audio. So for the image frame, it will go to the OCR to get the text from the frame, and then we'll go to the PAI to detect like which part of the text contain the PII, and then we'll blur that out using with the bounding box with OpenCV. For the audio, I'm using Whisper from OpenAI. So the text generated from that will have the start and the end time frame. So whenever they have the PII, it will insert with the beep audio to blur that out, and they will join together to combine them into a one single video at the end. So that is here. I think we have some technical issue with the video. Yeah, that would be fine. Let's see. Yeah. All right. I'm sharing right now. Okay. How can I do that? I don't have the link. Is there any way I can do that? Oh, I have it. Okay. Sorry, guys, some technical issue. My address is 1122 Des Moines. So with the sound is not coming up from the monitor, but the before video is containing like several object that have the PII, and after the processing, it will blur out the information that it thinks is a PII, but sometimes it does not recognize correctly because I have some fake ID I got it from the internet. So using the data mass, open source data mass from Microsoft Presido is not always work. So the main idea is that using NER and text anonymization to detect if the text is a PII, similar idea with Anna, but we have some issue. There's three challenges I encounter. First is the speed. Usually we use open source OCR. It generally slow for video. And so luckily the Babit map, they have the built-in resize function. So you can resize the video frame. And you can also, in my case, I use a RTX GPU 380 to speed up the processing time. And also I check if the work is already detected, and usually frame is detected multiple times, so it saves a lot of time in this speed. Secondly is the OCR may not be accurate. Some of the false detected work can be, you can see right here is the name of the extracted from the credit card, or the name of the bank or the visa is not correctly detected. And this is the first case I used with the easy OCR. And what I did is to do a little bit of pre-processing before I put it into the OCR and the PII detection layer. So I do skew correction, binization with adapt thresholds, some noise removal, and I also custom the model to fit with this case. And also I found that using GCP is helping me with the speed for the OCR detection. And finally, with the PII database, the question is that am I going to use reinvent the wheel to create my own PII database, or I'm just gonna get something that already there. So something already there is Microsoft Presido, and we can also use with the Gen AI with custom prompt, like detect if this work contain any PII like credit card, license plate, and you give them some example. They both all fast, but I found that cloud version is also the fastest one that I using for the optimization. There's some trade-off with the cloud, of course, is the security that later on I need to address when you push the PII data to the public cloud and need some encryption. And at the result, I got the compared to OpenCV, when you process it with just OpenCV and you have to do asynchronous image and audio, it take like more than double the time compared to Babit map, and of course with some optimization with Babit map. And who is this project for? I think it will be good for like video editor. We have a lot of time, so if you use this PyPy package, you input your video, and you output the video with the blur PII. It will save you some time for to think of auto script, or you can, if you are a user who care about your privacy, you can use that to detect if your video have any sensitive data before you upload it into social media. And so that's the end of my presentation. Right now it's still in the work in progress. So before publish to the PyPy package, because I need to take care of the encryption before public to the using for the cloud. But this will be released soon, expected in December and January as a PyPy package. Yeah, thank you so much. Any question or? Um, it's quite good, but it's really also depend on the OCR that come from that. So sometimes with the OCR, for example, name is cannot detect correctly. So when it comes to the Presidio, then it cannot detect that as a PII. But I also need to do some customization with the Presidio to define like a deny list or what is seem to be like PII in my case to make it a little bit more accurate here.
Did you do Presidio both with pre-processing, or processing the image and without processing the image? Did it
Yes.
help
Yeah.
Presidio the same way it helped the other models?
It helped with the pre-processing. After pre-processing, the OCR come better accuracy. So when it go to the Presidio, it can detect that segment of PII.
Okay, awesome.
Yeah. Yes, it worked on sound too. So what I did, when I extract with the sync model with the audio, and I use Whisper OpenAI to train that to text, and then I use the same PII technique to detect the PII and insert with the beep audio with the start and end time frame.
So you'll keep the synchronization and
Yes, synchronization.
I was wondering, like, what were some of the challenges you faced in integrating all these components together? So, like, individually, okay, like maybe for the PII identification, there could be some challenges, or working with Whisper, there could be challenges. But I was wondering, like, what challenges did you face, like, uh, getting all the applications to work together for the final product?
That's a good question. I think the first of all, the Babit MF is new, and so the documentation, and I have to navigate a lot. Without the help of Suchata and Shelfei from Babit MF team, I would not do it right now. And I think the challenge right now is more on the technical, trying to get the real-time work. But the OCR and all the processing, blurring, OpenCV is take more time than usual for me to make it near real time. So it's a work in progress right now, but I expect it to have the version that you can upload your video without real time, and you can have the end, and you can, if you want to customize that, you can do that too, to add more out in box yourself. But yeah, does that answer your question?
Yeah, that's good. Thank you.
Yeah, thank you.
Javier? Javier? Chutze? Digital characters, get up.
Thank you, Christopher, for that insightful presentation. Moving on, we'll explore open world object segmentation from videos with Meet Sony. Meet is also Bytedance BMF open source innovator, is a graduate student at Stony Brook University pursuing an MS in computer engineering, with experience integrating deep learning models into web and mobile applications.
Hello, so my name is Meet Soni, and I'll be presenting open world video segmentation using Babit MF and grounded segmentation anything model. So rest of the presentation will be divided into project overviews. Then I will explain the open source models that I've utilized and I will also go through the full workflow of how we can how I achieved this, and then we'll go through some demos. So like video segmentation is the task of extracting the perfect boundaries of object. So there will be like multiple objects in the videos, and we want to localize the objects and find the exact boundaries so that we can proceed with the numerous use cases. So like we can, with the video segmentation, we can go with the object editing. Like once we have extracted the boundaries, we can use some models like ControlNet or any other diffusion models to edit the objects, or like we can do some simple stuff using classic computer vision as well, like color collect correction or anything else. After that, like if for object tracking, if we want to monitor the like motion of some of the objects, we can also do with the object tracking. And the latest SAM2 model also supports this object tracking. So that's also we can achieve with that. Also for medical analysis, like we have a lot of use cases for video segmentation or like image segmentation in medical analysis. So with this application, we can utilize it to segment some of the neurons, or we can segment some of the cells to see if recognize any disease or any patterns from the medical images. Also, like for the brand visibility, so if suppose I have advertisement for the brands, and I want to monitor like what number of frame the brand logo or something brand item is visible, so I can also do that with it. Also, there are lots of applications in XR as well, as we seen so in the PICO XR demo. So we can just tag the products, or we can understand more about the product just by segmenting it. So like now, as I mentioned, like there will be multiple objects available in the image. So won't it be good like if we can just provide the text and it will segment that particular object only. So suppose that the first example is of car, and I just provide the just segment the wheels. So it will just segment the wheel and doesn't segment anything else. So suppose like we just want to do something with the wheels, then we can do that with the further post processing. So like why to use BabitMF for this kind of workflows? So like this approach utilizes like multiple models, and BabitMF provides good functionality of modules. So all the modules can run asynchronously. So we can achieve like very high FPS on HD or like 4K images that cannot be achieved using classical approaches like using just OpenCV or any other software. So like also this video and audio processing also is very seamless, and we can also like do separate modules for videos and audios and work them parallelly. And also it has easy integration with all the major platforms, and it has cross language support as well, so that is also very useful. And also it provides a lot of customizability, so you can provide your own modules to work as we saw in a lot of demos. We can build our own modules on top of BMF to support our functionalities. So now for the video segmentation, I utilize this open source model, which combines two of the models. One is grounding dyno, and another is segment anything model by Meta. So the whole procedure is like that. So first we'll give the text prompt to the grounding dyno model, a text prompt and the image video frame to the grounding dyno model, and it will extract the bounding boxes for the object. And that bounding box will again pass it to the segment anything model, and that will generate the mask for the video. We'll combine all of this and annotate using just I have utilized supervision for the annotation, and that annotation we can just show it in the video using BabitMF encode function. So this is the full workflow including the BMF. So first it will go to the decoder to extract the frames frames from the videos. Then we'll pass it to the grounding dyno model to extract the bounding boxes, and then it will go through the SAM model to extract the masks from the images that we can just utilize for the further post processing. Like suppose we just want to count the number of objects that we encounter in the video, or we want to do any further enhancement or any editing stuff, then we can also do using for the post processing. So I will show some demos. So like first one is just normal segmentation. So I'm just segmenting the cars only from the videos. So these are like most of the cars will be are segmented, and if you want to just count the particular cars in the frame, that also we can do using the post processing modules. So this is like a human face blurring. So this is the application. I will just build a post-processing function on top of the existing model, and just I'm doing the phase blurring. So that also we can do. And last one is for the tracking. So the first video we saw, every car are treated as like separate entity. Even if the same car is in the multiple frames, it is treated as a separate entity. But in object tracking, we cannot do that. So object tracking, we have to treat the same object in the multiple frame as a one only. So that is the that we also we can achieve using SAM2 model. So we can, with this, we can also identify the motion where the car is moving or where it will go next, or predict the motion as well using this. So like most of the application, Babit MF almost gives around 20 to 25% improvement compared to OpenCV. And also on 1080p images, I'm able to achieve around 6 to 7 FPS for video segmentation. And so the Babit MF is gives a real performance boost for this kind of task. For the object tracking purpose, it doesn't give that much performance improvement because like of the how SAM2 models work. So SAM2 we require all the images to be in a single folder. So just Babit MF can just give performance improvement in the frame extraction, which we can do on GPUs. So my future work will be, I will try to divide the whole procedure in multiple modules. So that like, because I have two models that are that can work in parallel. So I will try to divide the functionality of both the models in separate modules that can run parallelly. And I guess that will give us the good performance boost and maybe some real-time accuracy or real-time with 20 to 30 FPS. I can achieve the video segmentation. I'll also try to provide the ONNX support because it is very good for memory management, and it consumes very less memory once if you're on ONNX runtime. And also like it's also very fast. So I also try to provide the flash attention support, so that can also give the very improvement in the speed. And I will try to release the full package, full code as a package, so that other people can utilize and build modules on top of that they can use for the multiple applications. Yeah. So any questions?
You mentioned 6 to 7 frames per second real time. What kind
16, 6 to 7, yeah.
what kind of hardware was that on, just for context?
Yeah, NVIDIA A6000.
What?
NVIDIA A6000.
And that, what's the consumer card equivalent of that? Is it a 4090 or a 4080 or a?
I guess it will be around, I guess, 4080, somewhere around that.
Okay.
Range.
Awesome. Thanks. Under what scenarios does SAM kind of lose tracking, right? Like there's been a couple of public demos of like if you are looking like someone in the Olympics or whatever doing like a tumble forward, it kind of loses track of the person, for instance. And Samurai, which is a newer approach, enhanced approach to this, helps with that. But in the things that you were testing, where did you see SAM kind of stop working in ways that surprised you?
Yeah. So like as we saw in this phrase blurring demo as well. So if the object is not in some focus, or it's not, it is in the very background and it's difficult to identify, then most of the time SAM fails to segment those properly. And if it is occluded as well. So if the occlusion is there in the image frame, then also SAM fails to track those kind of objects. So I guess those two mainly I've seen in the SAM2 segmentation.
Other questions? So If not, thank you. So I suggest we have a group photo before everybody start eating. Sujata will join soon. Yeah. So should we do this side or there in the front? Maybe we can gather in front and have a group photo. Just in time. Group photo time. Yeah. Oh, come on, everyone. And the digital characters, can you show up your face too? There we go. You don't talk. No, 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 not talking. No talking.
No, wait, let's put the Bytedance Developer Summit backdrop.
Okay, whatever. Come to me. Yeah. Everybody. Oh, thank you. I use our champion hackathons as app to style myself.
Oh, really?
Yeah. Everything's AI based.
That's funny. Do it like tell you where to buy each individual piece?
Yes.
Oh, neat. It's a cool agentic.
Yeah. Join us and build your own agent.
Yeah, exactly, sure.
Okay, let me grab somebody.
No, I want to put the Bytedance. The slide is not showing up. Yes, yes, 1 second. I'm putting the slide. No, wait, wait. This, yes, this is it. Some people also wanted a campus walkthrough. It won't be a tour, but walkthrough, right? So Dr. Kaching is volunteered for that. So quickly eat your food. Ensure that he eats his food also. And then you can do a walkthrough. No, 1:30 is the panel. So yeah.
OK，我以为他们是拿这个 cable 来的。
Hello. So did people realize that there is tea, Indian tea, in that black thing? There's some glasses also. So it's milk tea. It is different from Starbucks chai tea latte. You'll thank me later. Thank you.
Overlay, right? On the physical world. I see the pool curve on top of the. Oh yeah, you see like. Yeah. Oh yeah, it's like a safety thing. Oh, okay. So I have to be in zone. Yeah, right. Yeah, right. You have plan to integrate it in in-house. Yeah, we have a people review. Wanna try the thing? I do. Yeah. Are you in the university for VR or? Oh yeah. Oh my goodness. You can look around. Yeah, came from the biggest application or has the current devices. The rest. But people also use it always a lot of applications. And you ask about the question whether the private you let's go to other
Everybody, we are going to start at 1:30. Looks like we didn't get to the tour. So I encourage everybody to, like, go wash their hands, take a break, come back. You can still eat while we are in the panel. And I don't know if there is a Vivek Chawla in the room, because his sticker is here. Vivek Chawla. Somebody, they just stuck their sticker on the glass. No, outside. Now we're starting at 1:30. So I think the next break would be the tour now. Okay, and I think we need 3 chairs here. Oh yeah, and some people had been asking me about the innovator program, and that's why I put the QR code here. I saw some people already filled up that form. How to become a Bytedance open source innovator. This is the QR code. You can fill in the form and express your interest, and then we'll get back to you. Yes, and it is for all the Bytedance open source projects. No? Okay. Yeah, I got one person. Yeah, thank you. So did we tell the hybrid audience that we are getting back at 1:30? That's fine. Okay, I think we are at 1:30, so we should start the panel now. Everybody, hello. Hello, we are starting. Okay. Yes, yes, yes. Hello. So welcome back after lunch, everybody. I hope we can interest you enough to stop your chit chats. So the panel is titled Beyond Code, How Open Source Contributions Can Fuel Business Growth. We have with us Ali Leclerc from IBM and Sudha from One House. So I'll let panelists introduce themselves and then we'll.
Hello, I'm Ali Leclerc. I currently head up open source strategy at IBM, primarily for data and AI. I have been working in open source for about the past decade. I kind of fell into it with my first company called Couchbase, which is a NoSQL database company, and from there worked primarily in open source data infra companies, really kind of working with communities, whether that was doing events like these or actually coming up with how we get more people involved in certain open source projects that we wanted to get more involved in these sorts of things. And so I'm excited to be here today to talk about open source. I'm very passionate about it. And I think I'll just say that there are a lot of ways to work with open source. It's not just about development. It's not just about events. It's kind of figuring out the mix of everything and creating inclusive and welcoming communities around open source.
Thanks, Ali. Yeah, hey, my name is Bhavani Sudha Saktishwaran. I go by Sudha. I'm currently head of open source at One House. I'm also a PMC member in the Apache Hudi project, been associated with the project since 2017-ish. Our team is responsible for all of open source, supporting the community, content, growing the ecosystem in terms of development, integrations, and things like that. I've been there with One House for almost 2.5 years now, heading open source. And before that, I was part of Moveworks, a chatbot AI company, where I was heading the data infra, leading their data lake migration using Hudi. And before that, I was part of Presto team at Uber, one of the early contributors of the Hudi Presto integrations. And prior to that, I was part of different data infra teams, both at Uber and LinkedIn. And like Ali mentioned, I've been blessed, like it's I consider it as a bliss to have been on the open source so long. Since I started at Voldemort, an NoSQL store that LinkedIn open sourced, and then worked with Presto and Hoodie, and so far it's been fantastic.
Thank you so much. I mean, I have introduced myself, but then just for the sake of somebody who joined later. So I'm at Bytedance Open Source Program Office, and I have been working in open source for quite a while. Started with networking software, um, have been witness to the SDN revolution. Anybody know have heard of SDN, software defined networking here? Yeah. So back in the days when people said, "Oh, it's just a science project and it's not going to happen," to now it's become de facto standard. And of course, every cloud runs on software defined networking. And one of the key projects of that DPDK used to be at that time called Intel project, and now it's a Linux Foundation project. And it's a de facto project. Every networking software runs on that. So really proud of that. And have worked with Tina on Akreno and any a whole bunch of networking software projects. Have seen our company get a lot of customers because of that as well. So yeah, love and have been working in the community, helping developers in the garage and developers at national labs, and you name it. I've done that, and that's the thing I love about working with the community. It doesn't matter where you come from, what badge you're wearing. It's all merit based. So let's get started on the panel. So earlier I asked a question in the audience on why you should contribute to open source. And the audience here is quite educated and they actually covered all the points that I wanted to cover. So let's start with some things which are probably not very well known or underrated. So what are the things that you think are not very well known or underrated in terms of business impact of open source for any company?
Sure. So I think, first of all, I think most people here are involved in open source in some way. And a lot of what I see from working with open source technologies and the communities around them is the ability to work cross-functionally across many different companies and across many different diverse backgrounds. And one of the really cool things about open source is you're getting the opportunity to work with people you may not have gotten to work with if you're just kind of sitting at your desk at your company, right? And so, as an example, I work on Presto, an open source SQL query engine, it's a massive collaboration effort between Uber, between OneHouse, between IBM, between Meta, right? And that's just a few of the companies. But this idea of you're getting like top engineering talent across all these great companies is really cool. And so you kind of get exposure, right, to engineers with different backgrounds and with different degrees of where they kind of are in their careers. And then you're learning so much, right? And you're bringing that back to your company. And I think that's a huge benefit is getting that exposure with these companies, with these projects, and then bringing that expertise you learn and implementing it into practices for your actual day-to-day job. So I think that's one of the biggest benefits that I see. And there's a lot more, but I'll pass it over. So.
Yeah, thanks, Ali. That's a great topic, right? We can skip that. I just wanted to complement that from the business side, right? Like from business side, I feel like you know, as a engineer or like someone who's working on open source, you bring solutions to your team. Discuss about that, get help from the community. You also have ideas, like you generate ideas, like talking to different people, not just within the pod. And like these things slowly convert into systems in your own organizations. And then what this I have seen like has benefited is like you go on to write more about this as you go. That kind of develops the engineering brand for your own business. And these usually like reflect in the form of blogs or like going deep in talking about in what you have implemented on top of an existing open source solution specifically for your need. And that kind of broadens the credibility or like the knowledge authority of your own business. And that kind of helps attract talent, more talented people that you can hire for your to work with.
And I'll just quickly mention, I think establishing credibility within an open source community is really awesome for your company and for your brand, right? I mean, to the point you just made, getting that talent through those channels is a real thing, and I see it every day at IBM. One other thing I'll mention is if you're looking at it from a selfish perspective, which you shouldn't do all the time, but you can move much more quickly. So as an example, within the Presto ecosystem, we have been working really hard to build Presto C++. This is our next gen native engine. We're rewriting everything from Java to C++. If it was just one company doing that, this would take like years, right? But this is a real collaboration between 4 or 5 companies working together. And because of that, we are able to accelerate our development cycles so much faster. And so I think that's a huge benefit of open source as well.
Yeah, and one of the things I would just add, which is the cost saving that company has in working in open source, like, and one of the proponents is just sitting right across, Jackson. He would be talking about it later. And so some of these projects that, like you mentioned, they become your internal company projects, or like, if you were to develop them in-house, what would be the engineering cost of that? If you were to maintain it yourself, what would be the cost of that? If you were to test these projects yourself, what would be the cost of that? If you were to look for use cases for these projects, what would be the cost of that? And also the marketing that you get for free. You can't, the word of mouth marketing that you get through open source and credibility of open source, that's one of the things that, like, it's very hard to pin the value at it. We were at the members summit this week, and Jim was talking about they've stopped tracking the value of Linux in the community. And I don't know, Tina, probably you're better at numbers. What was the number he put? Some 100 million or billion, something like from the members summit. No, the impact of Linux. Yeah, it was like something crazy because they can't even track the impact that it has. So, yeah. Anything else you want to add on this point?
Just wanted to add, like, every open source project, comes from some use case in some company where they lack solutions externally, or like they're just they don't have enough resources, or like there is an urgent need to kind of solve that, and then they spend more time extending that, or like like making it more generic, and that's how the projects grow forward. Apache UD also did that, like started at Uber, and like it just spread a lot in terms of adoption and contributions from different companies. And I cannot say simply like how much the community has contributed to the project itself. We have different collaborations, like Sujata mentioned, like various companies working with us on features that matters to them, of course. There's nothing, you get involved only when there is have incentives to do that, but that is still a huge proponent of open source projects.
Thank you. Yeah, we have 2 mics now. So. Okay, so so the next question is it's about developers. This is a developers day. So from the perspective of developers, so assuming open source is not part of their responsibilities, I mean, it's a different story if they are like, tasked to work on open source, if they're in a company that has hired them specifically to work in open source, which if you are one of that, you're lucky. But if you're not and you still want to work on open source, how does a developer manage their time between whatever they're currently working and how much they should work on open source, and how should they measure the ROI of the time that they're putting into the open source?
The way I would think about it is like there is always like you should try to keep it aligned to your business needs, and there is some, it kind of gets gray over time, but definitely like prioritize what aligns to your immediate projects, and how you can spend time relevant to that and increase any start with like baseline metrics where the current situation is like, and how you can leverage or like even contribute or extend to some like basic solution that's already available, to an extent that you can like make significant progress that would make sense just for you as a business, and then try to contribute that back to see if there is more that use case resonates generally with other open source users, and that kind of also justifies to your company that your contribution is also used across the community by different companies, right? And generally like when you start with this, and then generally what I find people doing is like they start with this very centric piece or like need for their specific use case, and then slowly as they gain interest, they also kind to tend to like go into adjacent areas and like try to spend more time, and sometimes it's like budgeted by their companies, sometimes they do just out of their own interest, but usually it starts this way.
I agree. I think, I mentioned earlier this idea of credibility. If you can point to the credibility that you're building within an open source community and bring that back to your organization, that's something that you can't buy. I mean, you can't throw money at that, right? That's really a case of you as a developer showing up and helping a community, or contributing to a community. And from my experience, I've worked at 5 different over the last few years. 5 different open source companies. The developers that were active in communities and bringing that back was always really good for our company. It established us as a leader in the space, established our brand as someone that could be trusted with developers. And so showing the ROI on that to your organization, I think is really, really awesome. And again, in my experience, has helped our companies grow in ways that we wouldn't have been able to do traditionally. I think another, if it's a challenge and you're getting pushback from management or whatever, that you shouldn't be spending time on open source, to Sudha's point, I would say, okay, here's what we have to do as a company. Here are my objectives, and here's the projects that I'm working on. Here's how those align to that. While it may not be specifically the project the product that I'm working on, here's how this project is going to help us as a company and me as an individual get faster with my development cycles, understand things better, and maybe even get some help, right? We can get people hired in these communities. And so these are all kind of tangible side benefits that that can happen when you get involved in open source projects.
Yeah, thank you. And one story I'll tell about this project Rspack that we'll be talking about later. One of the developers really liked that project, and this is a financial company. Can't take the name without the permission of the company. But he was so bought into this project because it was leading into his productivity. It was saving his productivity. So what he did was he set up a meeting with the management and said, this is how much time it will take for me to move the existing workload into this project. And within the duration of the meeting, he was able to move that workload and also show them the performance benefit. So that was powerful, and he made it happen.
I mean, I think if you can tie back your open source work to showing how it impacts something positively at your company, whether it's performance or price performance or gains or whatever, I mean, that's amazing, right? And so that's a win if you can do that. And I think something to strive for. Absolutely.
Yeah. And then earlier I was talking about in the morning, individually, if you want to shift careers, if you want to learn a new technology that you're not getting to learn in your company, in your current, whatever is your assignment, open source is a really good way to get your feet wet into that new technology. Open source it's a duocracy basically. Typically open source projects are underfunded. They always need resources. And other than code as well. So, I mean, contribution in terms of document, and tutorial, marketing, ecosystem building, events, all of those are valid contributions to open source. So whatever you want to get your feet into, open source is a great way to do that. I can tell so many stories of people getting hired because they were working in the open source later on, because they just got that visibility. Like you said, you can't throw money into it, right? Like whatever is your target, those maintainers, those companies will see your work and they will recognize your work.
Just one thing to add to it, it's also from the individual side, it's also like pure visibility, right? Like meaning, you already mentioned this. I've seen a lot of people like candidates when that I used to interview show me like their GitHub profiles and like go into like specific code that they contributed and then talk about those problems. It simply adds like credibility to what they say they know. And that also kind of, I believe like companies use that to even screen candidates for strengths and weaknesses in terms of what they're hiring for. It is a great way of adding to your profile and say that, hey, I know this technology, or I've worked on this project, or I've contributed to this project in this way. And those are all like publicly available and can be verified, and that kind of adds a lot of credibility to what you say.
Yeah, new age hiring, right? Social media for developers. Go on GitHub, ask questions on GitHub. It'll be publicly available. People will know you know stuff. Okay, my next question is, there's a lot of talk about security and open source exposing security vulnerabilities. So what is your take on that?
I would think it is too generic or like a broad statement to cover it. I would definitely think about what layer that you're working on in open source, like what kind of dependencies, and how how that kind of ties to your project. Typically, businesses use a lot of services to kind of screen these dependencies for their own sake. I think that is still needed, no matter leveraging an open source project or not, because it's very human, or like it's any kind of bug or issues tend to creep in. There is no like 100% safe way, but I don't think that's a deterrent to using open source. It's very well possible. And even in closed source, if you didn't know what is an implication of using a certain type of license as a dependency in your project, or even like, for example, if you're Googling for some code and then you just directly copy paste code, that is also like some kind of you need to be aware of the implications there. I feel like it's more it's overrated than what it is, in my opinion. And I think using open source does not mean you're prone to these situations. It's just that it has to be part of the discipline of the business itself to kind of filter through this.
Yeah, if I was being told at my company to second guess using open source because of security vulnerabilities, I would challenge that. First of all, I actually was just reading a report on, over this past year alone, the amount of open source that's being used in government companies, financial companies, has grown significantly. And as we know, those are some of the most highly regulated industries, right? And so this idea that these industries that have pretty stringent security policies are adopting open source at a pretty rapid rate, I think goes to show that open source isn't just, pie in the sky code thrown against a wall and you're going to grab it and start using it. Second of all, this idea of communities, governing open source projects, to me even makes it more secure, because it can be hard to merge a PR, right? It goes through a ton of checks, and a lot of people weigh in on it, and especially open source tech that's running at significant scale at companies today. You're not going to be able to just merge anything, willy-nilly and hope it gets in. It goes through pretty stringent checks. So, I think those two data points alone would be enough for me to say, well, I'd argue that open source may even be more secure than some of the other software we can just grab, right, and start using today. And to Sudha's point, right, if it is a concern, there's a ton of different tools that you can use internally to run vulnerability checks and security scans. And so I don't think it's, I personally don't find it to be a huge concern from a security and vulnerability perspective. I think that's one thing. I think the other part of that question is, if you are, as an example, a Bytedance employee contributing to an open source project, is there any risk of like IP or something, right? And I think that's kind of up to the individual developer. I mean, we probably shouldn't be contributing code that's IP protected, right? And I think most companies have what's the word? Processes in place to make sure that doesn't happen. At IBM, we have to go through a lot of security checks, right, before we submit any or contribute anything to open source projects. And so I think working for the larger companies, I have found that that's typically a process that's been put in place to make sure that we don't accidentally do something, release something into public that shouldn't be put into public.
Yeah. Okay. Yeah, no, I think both of the topics you both covered very well. I have nothing to add. I would like to, turn it back to the audience and see if there are any questions from the audience. Yes.
My question is specific to Presto. I'm a big fan. We use it and have been using it for a long time. And my question, I've got two questions, maybe, if it's all right. The first question is, if I look at what sits in Presto, especially with all of its connectors, it's got a very broad spectrum of capabilities. And the first question is, how do you decide, and this is a debate we have in our business all the time, how do you decide where you draw the boundaries as to when you open source and when you don't, and what you open source? And the reason why that question is very prominent now in our business, because when that disagreement with Oracle came about, if you remember, the driver had to be removed, everything got removed, so everything in production failed. People created forks to try to recover from that. There were licensing agreements that were just enormous problems for everybody that I know about. And then what happened is AWS took it and created Athena, did a deal with Oracle, and then just sold it to our clients, right, as a cloud service. Right. So the first question is, how do you decide, especially with the complexities of commercial companies who sometimes say, well, you're not going to use this because I'm going to stop you from, and I had to remove it. I mean, there was I'm not sure which release exactly it was, this now probably 5 years ago or so. So it's probably it's a long time ago. And the second question is this then, how do you then maintain that base? Like you say, I love IBM's approach because you allow so many patents to basically be used because you protect it and then you let people use it. So how do you decide that?
So for your first question on Presto, Presto is a Linux Foundation project. So this is not a vendor-backed open source project. So I actually don't know what the Oracle beef was. This could have been when it was with another company called Starburst. I don't know if that was a thing, or I know. Yeah, they forked. Okay. So I don't know what the Oracle.
I think Oracle changed the Java licensing.
I see.
And then they changed the way that you were allowed to connect to Oracle databases. And then
I see.
the
So that was
Presto
an Oracle
community
thing.
decided just to remove it from the repo.
I see.
And when we did the build.
Okay. So my guess is first of all, there's not like one company or person that's deciding to do anything from a Presto perspective. It is a Linux Foundation project, so there's a whole board that decides these things. I think that situation most likely is nobody was going to support the connector. And so if there's no support for a connector, and support, I mean like the open source community, somebody in the community has to pick it up and support it, which is kind of volunteer work, right? And that's one of the challenges of running a community in an open source project, is actually finding volunteers to pick these kinds of things up. And so my guess is there was nobody that was going to do it. It didn't work anymore. And so we didn't want to confuse the community and leave something up that didn't work until we could find somebody to take it on. So if your company wants to take it on, you should do it. Cool. That's great. Awesome.
But I think that isn't it the same then if you think of what happened with the MySQL
and MariaDB, yeah.
So wasn't it? I think it all happened around the same time. The
yeah,
article
that
took
makes
a
sense.
stance against certain communities that then got people.
So now we're going down another path here of this idea of forking, right? And what it means to fork and forking communities. And I have a lot to say about this, and I don't want to bore everyone in this room with my journey of Presto and the fork that happened. However, if you want to talk some open source drama, find me later and I'm happy to discuss it. Anyways, I think long story short, the answer to the Presto question is because, and this is another kind of thing around foundations, right? So Linux Foundation, Apache Software Foundations, I think these are kind of the two gold standard foundations for the most part, of meaning a project that is a part of these foundations for the most part is neutrally governed, right? There are many different players, there are many different companies and people that are involved. It is not just one vendor backing the project. And we see issues like around licensing changes, right? I feel like there's always a little bit of open source drama every year. This year, lately, it was like Elastic and Redis, right? Like changing their open source licensing, the community in an uproar. And so open source is tricky in that when there are financial motivations associated with open source projects, it can get a little murky. And I think that's as developers who are looking to contribute and be part of open source communities, it's something to think about, right? Is this a project that has a neutral backing, a neutral foundation behind it, or is this a project that's governed primarily by one company? And you can see like who are the main contributors, right? Is it people from one company or is it a diverse set of people? And so it's something to consider. You know, for Presto specifically, there are many different contributors from many different companies, and we welcome like everybody. If somebody wants to come in and build a connector, we say, yes, amazing, let's do it, right? If you, and a great example is Hoodie, Apache Hoodie team wanting to come in and make sure the Presto Hoodie connector worked awesome. We gave them the committership rights for that, right? And they completely own that repo and they help manage it and make sure it's awesome. And we want that to happen for like all the different kinds of ecosystem partners that we work with. And I have found, and I've worked for both. I've worked with Presto, obviously, and I've worked with companies that are vendor-backed projects. And so it's tricky. It's tricky for both. And I think, you know, there is a balance in there somewhere, and finding that balance can be hard if you are focused on financials. Second question, I think, was about IBM patents and how I don't know. So I've been at IBM for a year now. I was acquired by IBM. Our company was acquired by IBM last year or 2 years ago. I think, you know, the research team is amazing and they put out so many patents every year. And I think it's just an internal discussion on, you know, what do we want to, and I will say, I think it's really awesome how IBM has been approaching open source over the past few years. I think they have kind of changed their mantra around, we want to do more with open source. We want to get more people involved in the projects we're working on. And so even over the last year, I've seen so much more coming out from IBM from an open source perspective. And I think that's going to continue. And so I don't know how they decide, you know, case by case what they do, but I will say, I think it's opening up a lot more.
One last.
Yeah.
Do you have a view on Watson, on what happened there?
I love Watson. I work on Watson.
But there was a whole journey, and I was part of a community that were deeply involved. And then
I think Watson was ahead of its time. I think, you know, now we've built Watson X, which is a portfolio of 3 different components. Watson X.data, which is our lakehouse. This is where Presto sits. Watson X.governance, which is kind of our governance and security layer, and then Watson X.ai, which is like our AI stuff. And so, you know, today the market is so saturated. There's, you know, we have data warehouses, cloud warehouses, we have table formats, we have transactionality layers, we have compute engines, we have all the data sources. And so there's so many different players in this space, in this data infra space specifically. I think the market is very crowded right now, and I'm really interested to see how it all starts shaping up. I'm sure you have perspective on this as you're building a lake house, I think, as well. I don't know how you position one house, but yeah. So I think I think we're gonna run out of time. I would love to talk lake house, and I'll give you your, because I think you should share.
So one thing that I want to add to the first question is like how features or things that get decided. Like Ali mentioned, it's never um, like one company or like one group kind of deciding. Being part of the PMC itself, like I've often seen this across releases where we put out communication saying, hey, we propose these kind of features in the next release, please vote. And oftentimes it is like if people are interested in specific features, they always come back and say like, hey, we want to see this thing going on and I'm willing to contribute. I want to drive the release and so on and so forth. So it's been like a complex navigation of people across the globe, and I haven't seen that there is like one particular company or like one set of one group of people like dominating the open source features. So they tend to kind of come in all directions. At least I haven't seen that in Hoodie, or like even Voldemort was like more of a LinkedIn's open source project. But even then, Goblin. I ended up like when I remember my days in Voldemort where I used to be on GitHub, triaging feature requests from people from other companies.
I think one other thing to think about too, I know I've talked about this idea of neutrally governed projects. Without naming names, I know a large B2C company that works with a technology, an open source project that they use at pretty massive scale that's vendor backed. And they were trying to merge in some security specific PRs. And those did not go through, right? They were not approved. And it's because that vendor wants to monetize those kinds of features, right? And so those are the kinds of situations that I think can come up when there's financial incentives involved with an open source project. I'm not going to name names.
Have you got a view on Sugar CRM?
Oh, do I have a view on
what happened with Sugar CRM?
Remind me what happened with them?
Well, they changed their license, and then a community broke away.
Yeah.
And so it's
this has been happening, I think, for the last forever, right? I mean, when I was at Couchbase, it was Mongo that changed their license, and they just totally pissed off their developer community. Just recently, WordPress had a whole situation come up, and that was crazy, right? And so I think open source isn't broken, right? It's complicated. And when you're building a business on top of an open source project, you have to answer to a board and you have to answer to a community. And one of those is eventually going to win. And so this is what I've seen just repeatedly over and over. And it's when you're a developer looking to join an open source project, I think those are just considerations that you should think about, both from a development perspective and from an end user perspective.
Anybody else?
so on that. I think that the big thing, my legal team always give me pressure because you got, broadly speaking, the Apache and the MIT licenses, that kind of two different schools of thought. So even if the company decides not to support, you can still carry on. What's your view on that? Because I think that, if we look at what happened in the AI world now, like Library Chat and some of those companies open sourced, or LangChain. But now LangChain is busy commercializing. So what they're doing is they're affecting the base repo and our Lang graph, so that means that the whole trajectory gets affected because the licensing. So we found that we now make decision on open source, not based on what it gives us. First and foremost on the license, if you are allowed to continue or not, and only then, and if you can't, we kill it, we stop using it. So I don't know what your views on that.
I think it depends what perspective you're coming from. If you're a company that has built something and you want to open source it, I mean, there's very permissive types of licenses and there's more, stringent licenses, right? If you're looking to build an open source community and you want to attract developers, you want to use the permissive licenses, right? The Apache, 2.0, I think MIT is okay too. But in my experience, those tend to draw the developer crowd if that's your intent. If you're a company that maybe that's not as important to you, you want to say that you're open source, and eventually, maybe you want to make sure that Amazon, AWS doesn't take your product and create their own and offer it in the cloud. I think that's what a lot of these companies are trying to protect themselves against, and I understand that. So I think it just depends what kind of perspective you're coming from. I will plug PrestoCon. PrestoCon's coming up December 3rd, 4th. It's at Meta offices in the Bay Area. It's free. We'll be having some really awesome people coming and talking about what they're doing with Presto. It's at Meta Fremont office. I didn't know about it either. It's very cool. It's a cool office. It's Cross Bay, yeah.
So I think part of it we already covered, but maybe what is your advice to developers who want to get formal buy-in from the leaderships, or to communicate the value of their open source contributions to their leadership?
I mean, I just want to tie it to my previous point, which is generally like the time spent in open source, it's always better to tie it to the project's need within their company, and then slowly like brand it to engineering branding and attracting talent. And these are ways that you can communicate to your eng leaders or about to convince them to spend more on ROI.
I think pulling data is helpful. So the projects that you're working with, how big are the communities? How many GitHub stars are there? How many contributions are getting added? What kinds of people are contributing to it? I think those are good kind of hard data points to share. And then kind of what we've been talking about, showing the credibility that you've established in this company, showing the types of people that you're working with, how you're bringing new ideas fresh ideas to the table, I think are all really cool things that you can point to that show really the work that you're doing in open source is credible and important.
Thank you. Any other questions from the audience? Okay. So looks like we're good. Any closing thoughts you have?
Say, take a look at lots of open source projects. Something might catch your eye. Something might be useful for you down the line. If you wish to change your stack or look for even more broader opportunities, I always see that as an individual contributor. If you want to expand your profile, that's a great way of doing, contributing and showcasing that.
I'll echo that. I think, and look for communities that are inclusive and welcoming. If you join a community and nobody helps you, nobody greets you, it's probably not going to be an awesome experience, right? And so look for communities that really help onboard new people into their projects, and take that seriously, because that's a good thing to be in a community like that.
So more than the project itself, community and inclusivity, welcomeness of the. Okay. Thank you so much.
Thank you.
Ali and Sudha. Okay.
Iris, can you wake up? Sorry, no sound. I can't hear the sound.
And present Brain Intro. Saishua Lin is an engineering leader at Bytedance, driving cloud-native transformation using Kubernetes for hyperscale compute workloads. Jia Deng is a software engineer specializing in control plane colocation optimization and profiling resource management.
Yeah, so I'll give a brief introduction on the background on why we're doing this project and some background about how this project related to open source, and then give you an overview on how we solve the problem, the system design, and then how does it do like its performance, then some future work. So KubeWharf is an open source organization from Bytedance built on Kubernetes. It aims to supply open source solution to address key challenges of large-scale cloud-native situations, including scalability, stability, multi-tenancy isolation, resource efficiency, and observability. So currently, KubeWharf have 7 projects. We open source 7 projects in 2 years. And we went to KubeCon last week and give a speech on Godel scheduler and Catalyst, where Godel scheduler provides some advanced feature like gun scheduling for machine learning workloads, FIFO, resource reservation like during off-peak hours to optimize resource utilization. We allow low priority tasks to borrow resource from online services and get resources back as quickly as possible when traffic rises. And like micro topology scheduling in NUMA level, real-time load-aware scheduling, etc. So the company takes those projects from open source, and then it's time for us to contribute back to the community. Cool. Let's take a look what's the problem we're trying to solve. So TikTok might be the most famous or popular apps or service that people know, but there's tons of business products in Bytedance, and it's keep growing rapidly. So what I listed here is just the tip of the iceberg. And we have more than 1 million active users per day. So we have to face the massive scalability problem. And mostly of our applications or services is based on Kubernetes platform. And the applications running on Kubernetes is diverse. We can roughly estimate those services basically fall into those 4 categories. Microservices for API, big data for data analysis and processing, storage for like users video and etc. data, and machine learning for AI models. To solve the scalability issue, there are 2 ways to go. One is to horizontally scale to have multiple clusters. The other one is to vertical scale to build a larger single cluster. Absolutely, we need to go both ways. We cannot go a single way. But I'd like to highlight some advantages of building a larger cluster, which could reduce resource fragmentation to improve resource utilization and lower management cost. So Kubernetes is a centralized architecture system, and all components to talk to the API server, and API servers depend on metadata server, etcd, which is the native supported database. But it is the sometimes it becomes the bottleneck because meta server storage carries all the traffic. So those are like very well-known figures. The left one figure shows is a CNCF cloud native landscape, which includes tremendous projects. But the right figure reveals that all the cloud native infrastructure is based on a fragile etcd. And let's take a look at how etcd looks like. It's a leader-follower architecture where the leader takes write and watch requests. The follower takes the read request. And among those components, it has an API layer at the top, and it's a single Raft module, state machine, multi-version concurrency control, and underlying it has BoltDB as entry storage engine. And the official recommended cluster size of a Kubernetes cluster is 5K nodes for a single cluster. And as we scale our clusters and take high throughput output, we found some issues. First, the API layer is not good at rate limiting, and it has issue of thundering herd on relisting. The multi-version concurrency control has issue of expensive read costs, which costs out of memory, and it has high latency due to paging reading. The single Raft module becomes the bottleneck. And the underlying BoltDB has problem on serialized write performance limitation, high write latency under high load, and it's hard to defragmentation online. So in order to solve the problem, we're trying to find, there are like two ways. One is the old way to see how can we improve the performance of etcd. Then there's a new ways to see if we can develop something new. So absolutely, we'll try to see what we can do for etcd. What we did is we tried to replacing the hardware with faster storage. We tried to fine tune the configurations. And also we try to split event objects to another etcd cluster. But as we trying to scale our cluster, we found that the root cause is from the etcd. We still have the problem that, like I said before. So if we want to keep scaling a cluster, then those tricks won't help. That's why we go to a new way, which is to design a Kubernetes-friendly metadata storage. And I want to add here is etcd is designed before Kubernetes. It's not designed for Kubernetes. That's why we want to build our own thing. Let's take a look how we solve this problem. So KubeBrain draws its inspiration from Kime project, which is an open source project. And what it does is it implements a subset of etcd API that is specifically optimized for Kubernetes use cases. It translates etcd transaction costs into the desired API like create, update, delete, etc. And it decouple its backend or underlying storage engine to support. You can choose more of your more familiar, mature, and widely supported relational database. So KubeBrain draws inspiration from that structure, but we're using we changed the underlying storage engine to have multiple options there. Then the question becomes, what storage capabilities are required by API server? And in addition to CRUD, like create, update, write, delete, then Kubernetes also need single key condition updating. So underlying storage must support comparison semantics. And as API server implement API trunking to support data paging reading, snapshot rate is also needed. And watch is also very important in API machinery in terms of list watch mechanisms. So I'll talk from the bottom to the upper layer divided into 4 parts. Let's take a look at the storage layer first. So in KubeBrain, we define a unified storage interface, which could support with underlying storage engine. Currently, we support ByteKV, which is an Bytedance in-house key value store, but also it could support TiKV, which is another open source storage engine. So between that, we have like different adapter for those different storage engine. Then up to the logical layer, I'll just give some like a sneak peek on like some features that we implemented in the KubeBrain. I'll introduce the key coding, the timestamp oracle, and the leader election. Speaking about the key format, so KubeBrain encode the raw key from API servers request into two types of internal keys to write into the storage engine index and data. So for each raw key, the index revision key has only one record, which stores the latest revision of the raw key. The revision key also acts as a lock, meaning that each update operation on the raw key requires a cast operation on the index to ensure consistency. The data record, which is the object key, has one or more entries, each recording a history version of the raw key and corresponding value of that version. The encoding format of the object is magic plus raw key, split key, then revision, where the magic is just a specified special prefix. The raw key is the actual raw key from API server. Split key is a component used to partition or split the data. And then the revision is the actual version of raw key. In a storage engine, all internal keys generated for the same raw key fall into a continuous range. This encoding method has some advantages. First is it could be reversible encoding, meaning you can obtain the internal key by calling encode, and reversely, you can retrieve the raw key and also revision from the decoding the internal key. And it's unified in the key value storage underlying. All the Kubernetes object data is converted into key value pairs within the storage engine, where each object has a unique index record for the latest version. It is easy for ranging construction. It's straightforward to construct the keys for a specific row or index, or to define a key range corresponding to adjacent rows or index values. And this could avoid hotspot writing issues. Since the key format is not monotonically increasing, it avoids hotspot write problems that arise from incrementing keys in storage engine, thus improving write distribution and efficiency. I just talk about the revision, so let's take a look how we use timestamp in the revision. So KubeBrain, like etcd, has the concept of revision for version control. When allocating a revision, it's necessary to ensure that the revision is globally monotonically increasing. The KubeBrain cluster's ID generator is only initiated from the promoted master node or the leader node. It is initialized using the logical clock interface provided by the underlying storage engine, like either TiKV or ByteKV. The initial value of the ID generator revision is set to the logical timestamp obtained from the storage engine. During the tenure of a single leader, the integer generated by the ID generator are monotonically and continuously increasing. When the master node fails and the leader follower node takes over, the initialization process repeated. The ID generation on the master node is continually increasing, but the storage engine's logical timestamp may not be continuous, and its growth rate is much faster than the leader node. This ensures that after a leader switch, the revision still increases. The maximum revision assigned by the ID generator on the old master node will be smaller than the minimum revision assigned by the ID generator on the new master node. So the ID generation on the KubeBrain master node is a purely in-memory operation, offers extremely high performance since write operation in KubeBrain are completed in the leader node. There's no need for network transmission when allocating revision for write operations. Therefore, this high performance ID generator greatly contributes to optimizing write operation performance and for consistency. Speaking of the leader election, it also connected to the underlying storage. KubeRain is based on, for our in-house KubeRain solution, it's based on a strongly consistent distributed key value storage engine, ByteKV, which implements a resource lock that points to a specific set of key value pairs in storage engine. The resource log contains information such as leader node address and lease duration. After the KubeRain process starts, all node initiated itself as a follower node and automatically participates in leader election in the background. During the election, the process first attempts to read the current resource log. If the resource log is empty or lease has expired, the node will try to write its own address and lease duration to the resource log using cast operation. If the write succeeds, the node will be promoted to leader. Follower node can read the leader node's address from the resource log to establish a connection with the master and perform necessary communication. However, the leader node is unaware of the presence of follower node. Even without any follower node, a single KubeRain leader node can still provide the API requires for the API server, but the performance will be compromised if there's one single node. Then let's take a look at the API layer. So from API layer level, centralized storage faces significantly challenges when handling large-scale queries, like expensive reads or write, such as full key space fetches, large-scale event queries, and operation like listing all pods or writing config max, etc. These operations are very resource-consuming and error-prone to overload or even cascading failures. Generally speaking, the storage system cannot downgrade its performance, but can only use rate limiting or prevent such failures. etcd has simple rate limiting protection. When the difference between the commit index and applied index exceeds a configured threshold, say the default is 5K, then etcd temporarily stop accepting requests and returns 429 too many request error. But ByteKV don't want to do that, so we provide a more advanced rate limiting capability on table level. Like we can cap the maximum read QPS. For example, you can limit the read QPS to 1K for each proxy to a table, or limit the scan through output to 10 KB per second per proxy, and proxy periodically refresh the table's latest status from master. On top of ByteKV, KubeRain provides additional mechanism to optimize read and write performance, such as streaming, rate limiting, and quota mechanism to prevent cluster overload. KubeRain supports queues rules based on object types such as by gRPC method, gRPC method plus request key prefix, or CPU intensive operations, latency, etc. And lastly, we can take a look at the client SDK. So etcd use pinged connection, meaning after a successful ping connection to a node, the client pings itself to the node, meaning it will continue to use the node until it's broken. But KubeRain read client no longer use the original like ping address approach or this ping connection. Instead, it now uses round robin load balancing to select nodes from the instance list, improving the scalability of read. List requests have been changed from unary to stream. So to improve the performance of list request, KubeRain gets the number of shards, then make concurrent streaming requests to corresponding ByteKV shard. So when perform a range request, KubeRain client retrieves shard information and snapshot version numbers from KubeRain server. For each shard, KubeRain client initiated a stream list request. For each stream list request, KubeRain sends a scan request to ByteKV. During the scan, the return data is pushed through stream to KubeRain client. Once the shard finished processing, KubeRain sends end of file to the KubeRain client. The KubeRain client continues receiving the data from each shard stream until get all the end of file. It then aggregates the data from all shards and forward it to the API server. All right, about all of those really dry system design, let's take a look at how it performs. So this is the comparison we run between etcd and KubeRain. So for the write operation, the P50 latency reduced to 1/6, P90 reduced to 120, P99 reduced to 1/4. And the get operation P99 latency reduced by 50%. Range list latency of 20 gigabytes result is reduced from multiple minutes to 10 seconds and guaranteed no out of memory. The performance improvement for the concurrent activities as well. It reduced write lock granularity, increased write concurrent through output. The raft group, we changed it from a single to multiple, improved write concurrent through output. And then for write transaction optimization, we handle cost operation push down to the storage, reducing the round trip time. Key format is well designed for partition splitting. We can finish transaction in one phase commitment to improve performance. So we have two types of clusters for our benchmark cluster. We with internal API server optimization, the cluster can scale up to 50K nodes and 2 million pods in a single cluster. And then for our production cluster, we currently have scaled up to 18K nodes with peak write request reaching 10K QPS. Some future work of KubeBrain is currently it's a single master write system. So we will continue further explore horizontal scaling and also discuss this in the community in the future. And currently the leader switching triggers released on API server side, which has significant data synchronized overhead. And the underlying storage engine we're using, like our in-house version use ByteKV, which has very high request on the machine, but it has like low utilization. So those are some fields that we'd like to improve. The barcode here is the KubeWharf project, which consists of all the 7 projects I just listed before. Yeah, that's it. Thank you guys, and I'm happy to take any questions.
Yes.
Thank you. So just now you mentioned that traditional etcd has roughly 5,000 members limit per cluster. Do you have any similar numbers you can share for KubeBrain?
Yeah. So the 5K node is like what etcd could support, and over here, so the benchmark cluster we build up to 50K nodes, and for our production cluster we have about up to 18K node in a cluster. Yeah, so this is to support, as I mentioned, like we need to solve the scaling issue. And one of the methods we're taking is to horizontally scale the cluster. So that's why we want to build a larger cluster. So for more traditional solution, we build a cluster for each like business need. Say for this cluster is for API, this cluster is for machine learning. But if we want to fully utilize the resource utilization, then we want to combine those resources or combine those business together. That's why we want to build a larger cluster. And to build a larger cluster, we need support from all those other components. etcd is one of the aspects, but also like scheduler, gateway, etc.
Is there a auto scaling like scale up and scale down, automatic or elastic? Like all the other vendors, like the cloud vendors.
What do you mean the vendors?
Like EKS, right? You can auto scale, meaning if the workloads are more, then it is going to look at a matrix and then scale up that node.
ByteKV provides that auto scaling abilities, but for KubeBrain layer, since KubeBrain is designed for large scale cluster, so meaning when we want to promote, so we still have some clusters based on etcd. Not all of our clusters are on etcd on KubeBrain. So when we build a cluster with KubeBrain, or if we want to promote a cluster from etcd to KubeBrain, we already know it's a very large scale cluster. So currently we have an initial size of ByteBrain and the underlying like ByteKV, but ByteKV have the like elastic ability, but not on the KubeBrain side. We specify the node over there, like the resource it needed.
Is there a Terraform module or some kind of automation, or is it like when you build a cluster, is it going to be like, this is my requirements, this is the size of my hardware, or is that some kind of a IAC like module to build the cluster?
Are you asking from the ByteBrain side or KubeBrain side, or from the more of the
The more
cluster
of
side?
a generic Kubernetes cluster, right? I mean,
Yeah.
so
Yeah. We have that ability. So when as a business, from a business side, you can specify what the resources you want, like what CPU you like, what memory you like, and the workload will be submitted into our the Kubernetes cluster, and then from there we allocate the specific resource over there. So it's more of I can get back to the landscape of all of our projects. Here. So what you just said is more of like a catalyst or scheduler, like Godel scheduler. So the scheduler would know like how many resource a workload would request or it would take, then schedule it to corresponding node. And then catalyst has the ability to know that if it has specific resource, then where like to already know like what node it needs to be allocated to, then what new amount it will be bind to, or like how many resources it takes. Because from the business side, it will only know like what the CPU or GPU or memory it requests, but it might know like other resource levels. So Catalyst, like those components work together to decide what the actual resource it requests or it consumes, and then allocate to the right spot.
You were mentioning going from a kind of a homogeneous workload across your kind of hardware fleet to trying to go to something more heterogeneous. Usually that implies that kind of CPU cache performance gets worse because you're running your time slicing between different kinds of code on the same CPU cores or the same sort of hardware threads. I really liked how you kind of went into detail about the lock contention, because that's such a key. It sounds like a very low level implementation detail, but it's like a critical path performance thing for this kind of system. In the thinking about kind of co-locating or multitasking these workloads on a greater part of the fleet, does CPU cache performance come into play? Like if you did do that, would you have done such a great job on lock contention just to then be stalled on memory fetches most of the
I
time?
think you are talking about rescheduling. That's how we solve this problem. So right?
Kind of, you were saying that like to get access to more of the fleet, you need to be able to
Yeah,
run
it's
a
not like a static,
heterogeneous.
like not
Yes.
static, but
Right.
more dynamic.
Yeah, yeah.
Right. Yeah. So upon scheduling, we have a lot of strategy to make sure that we allocate the resource or allocate the workload into the right spot. But this is more of a static path. We also have rescheduler, which we take real-time data. Then we know we monitor like if there's a hotspot or like the initial scheduling is not the right one. So during reschedule, we would take, let's say, this node already is a hotspot. Then we take the like the workload on it and reschedule to another node.
Gotcha. So you kind of you have telemetry that gives you kind of a runtime profile, and then you go, is that the right blade or node or container or whatever for that to be running on if it has that profile? And the answer might be no. Does that also help with if you have heterogeneous hardware in your data center, which
that's true.
I would assume, does that mean that, for instance, it's like, well, for this particular, for a KubeBrain or KubeWharf thing, that's where we get this kind of telemetry from it. Does that mean you would potentially learn, for instance, I'm not picking on anybody, but like, if it's this kind of KubeWharf workload, it can't be deployed to Intel, for instance. It has to be deployed to AMD. Is that the kind of thing that might bubble up to the scheduler?
Yeah, absolutely. Actually, you mentioned like two I can split it into two questions. So first is, it is true that some workload can only be deployed in some type of machines. Then like our scheduler would have the node selector. So like we label those kind of machines, and when we schedule those jobs, and when the business, like they submit a workload, then they would specify like what kind of machine they will need. So they are aware of that. And then speaking of, we have like various types of machine in one cluster. So during profiling, we also consider that. So when we profile a workload, then we introduce the part of the different machines. So it's kind of like when we're building a unique identifier to how to profile a workload, then we consider what business is that, and its deployment, and also what machine it runs on, because their performance could various.
Yeah.
Yeah.
And also some parts of the business might be healthier than others and therefore can afford bigger machines. Awesome. Thank you.
Are there special treatments for the more real-time sensitive workloads based on quality of service properties? So if you have a workload, like you're saying now, you've got a network switch that will decide certain infrastructure or hardware or whatever the cluster is going to be that it runs on. So is there a special treatment for the real-time versus the more or less time-sensitive interactions?
Are you asking why are we having like a real-time and?
No. Asking how do you deal with the treatment? Because you say that you do the selecting. Is that a manual selector, or is it something that could happen dynamically?
Oh, it's not manual. We have a scheduler to do the selecting, to do the scheduling. Is that what you're asking for?
I just want to think, is there special configuration needed for things that are more sensitive in real time? So if there's, if you think of, if you run an asynchronous environment, you might find that it's fine if some of the jobs could slow down a bit, but for some of them you need immediate feedback. Is there a special way that you treat that? Because I think that you seem to have solved the problem across the board. You could just.
Oh yeah. So our components, they kind of like work together. Say Godot scheduler is the one that do the actual scheduling, and Catalyst is the one to provide the data, like to guide the scheduling. And then KubeBrain is just like the metadata data server to support that high through output. Yeah, so they work together, deploy together.
Anything to add? Tajie?
Based on the priority, and then the scheduler will pick the resource for them. And then high priority will sometimes actually preempt the low priority tasks in order to guarantee predictable performance for real-time tasks, right? So there's a lot of layers involved into this, but we can talk offline if you have any additional questions. Okay.
All right, thank you.
Is Iris down? Iris? Wilson? Is Iris down? Can you play for Iris? They send it to the group. Okay, so real person. Yeah, because the Iris is parking in a parking space. Iris is our digital character's name. No. What is she doing now? She's parking our parking space. Yeah.
Oh, scary. The operator for Iris is parking. Thank you so much. So, Jia and Shaishu. Now we have Jian Pai and Harsha. So they will be talking about CloudWeGo Monolake. Jian Pai, did I say the name?
Yes. Okay.
Yeah, is a networking specialist on Bytedance's Volcano engine. That probably might be a term that people might not be familiar with. So it's equivalent of Google Cloud. in Asia Pacific regions, very
Basically, Bytedance public cloud. Yeah.
public cloud, yes. Infrastructure as a service team. So he's a networking specialist in Bytedance's Volcano Engine infrastructure as a service team with expertise in HPC and AI networking and protocol design. Harsha is a software engineer on Bytedance's Volcano Engine team, the same team, focusing on P4 programmable devices, DPUs, and using Rust to develop high performance infrastructure solutions. I've not heard of P4 in a long time. I'm I'm from networking, so
Somebody knows that P4 is hardware programming. Okay.
yeah, you can maybe tell them about what P4 is.
Okay.
Yeah, you can log into the meeting. And
Okay. Yeah, maybe. How you guys doing? How's the lunch? Good. It's fine. Yeah. Okay. Thank you, guys. Yeah. Good afternoon. Yeah. So I'm Jianwen, and this is Haja. Both of us come from the Bytedance public cloud infrastructure team. So today we want to introduce our newly open source project, Monolake, which is a high performance Rust-based framework that help people to build some enterprise proxy and some applications. Yeah. So Haya will probably will introduce this one more in detail. But this one actually is before that. This one is a new member of our CloudWeGo family. So basically, that's a CloudWeGo actually is a set of microservice middleware developed by Bytedance that can be used to quickly build enterprise class cloud native microservice architecture. So if you look at the yeah, so this one, how we go, the purpose is we try to build some high performance some components. Actually, it's most of the one is major in the Golang and the Rust. So majority is the Go, but recently we have more and more Rust-based project coming to the family. So we have the asynchronous RPC streaming capacity, non-blocking I/O, and that's a high performance. Another one is for the extensibility. So basically, we have a different layer of the framework, which we'll see in next slides. And also, we can support multi-protocol support, and also provide lots of the tools. So basically, in the CloudWeGo, right now we have more than 40 projects in that family, and there's more than 500 developers around the world, worldwide. Yeah. So that's a look at this one. That's a layered stack. So basically, that's you can see here. So Monolake is latest added to that family. We just open source last Friday, Monolake. But the other things that's already like key text and Hertz and Volo. So all of the project actually, this one is endorsed by the many projects inside the Bytedance. Even the Monolake, we already have 3 projects built on top of the Monolake. Haja will introduce later in detail. So you can see from the framework and the codec and to the I/O library and the tools middleware. So that's all of the CloudWeGo. So I think that's yeah. So I just passed the many time to Harsha. Maybe he can have a more detailed introduction of the Monolake project. Okay. Thank you.
Thanks, Shannon. So I can walk you guys through what Monolake is. So Monolake is a Rust framework to build high performance network services. So by network services, it can be anything from load balancers to API gateways, like HTTP proxies. So the full stack. So it can be anything. So Monolake is built on top of this runtime called MonoIO, which is developed in Bytedance as well. MonoIO is a async runtime, which is specialized for IO urine. Most of the ASIC runtimes in Rust right now are like built around ePOL and KQ, but MonoIO, is specialized for IO urine. There are some IO urine runtimes like Glomio and some newer ones, but they're not very mature as compared to like Tokyo, which is the most widely used runtime in like Rust. So Monolake is essentially like a set of like libraries that we open source that you can use to build network services. So those libraries are everything from like HTTP TLS libraries, which are like optimized for like IO urine, and then we have some special libraries which do like some context management between services and which can do some compile time checks. And like any and the core functionality, the core libraries do things like the worker thread management, config management, service lifecycle management, the full works. And Monolake has been used to like build a couple of products at Bytedance. I'll talk a little bit more about them towards the end of the session. So the runtime itself is already open source, and like all the core libraries have been open source as well. And we have a reference HTTP proxy implementation that like people can look at to see like what you can do with Monolake. And I want to talk a little bit about like the why, the motivation behind like trying to develop this framework. So Bytedance has a lot of unique requirements which require a lot of customization and edge cases which are not easily supported by like existing solutions like Nginx and Envoy, which are like like excellent solutions and have like good support out there. So the main reason is like flexibility. If you look at, for example, like Nginx, it has like a very rigid architecture. Say you want to like do something very simple, like for example, you want a new retry mechanism for a request, right? Like your request tries to reach its first upstream server and it fails, and now say you want to like send that request to your second choice upstream server, but with a different set of headers, right, in your HTTP header. That's It sounds pretty straightforward, but it's actually pretty hard to implement with Nginx in its current architecture, and it's not very developer friendly as well. And this is like nothing new. Like a lot of companies, like even like Cloudflare, have like open source a proxy called Pingor, and one of their motivations was like about like how hard it was to like like make changes to Nginx, and they would like like diverge from the mainstream Nginx, and it's really hard to like keep both in sync. So that's one of the main reasons why we wanted to like develop Monolake. And another thing is Rust is a pretty young language, and it's like there are a lot of changes, and it's like changing very fast. The existing runtimes and libraries like Tokyo are like pretty like rigid, and like they have a lot of users, so they can't move pretty fast. We can be a little bit more agile and like experiment much more. And IO urine itself is also like like a very new kernel feature, and it's been widely used for storage, but for like networking, it's like still pretty young, and there are a lot of changes and a lot of significant improvements as well, especially by companies like Meta and Cloudflare, which are doing a lot of work for networking and IO urine. So we wanted to use IO urine. And Rust itself has some benefits like memory safety, and we've kind of been able to use its like type system to like introduce some checks at compile time to like make things life easier for like our developers. And I'll talk a bit about that later as well. Um, yeah, next we can just go over like the runtime, the Mono runtime, which is a major part of Monolake. So like I said, like MonoIO is like built with IO urine kept in mind. And like just to give you an overview of like what a runtime does in Rust. So I think before that, you kind of need to understand what async function or async task is. So async task is like a regular function, but when it can't make any progress, meaning it's like waiting for the kernel to do something or anything like that, it yields control back to the runtime. And the runtime will then try to like drive some other async task and make progress, right? So the runtime essentially is like the main driver. It's kind of like a event library or event loop in like C or C++ would be like the best comparison. So our runtime Mono IO is very different compared to like Tokyo, which is the like the de facto runtime in like Rust. We have a thread per core model. So what that means is that any task that you spawn will be executed on the same thread, right? As opposed to like Tokyo. So Tokyo is very different. Tokyo has a multi-threaded scheduler. That is, it has a pool of threads, and any task which is spawned can eventually be executed on any other thread. So tasks move in between threads. So in Rust, because it's a memory safe language, there's a lot of restrictions. So any structure or enum, if you want to send it in between threads, it needs to implement the send trait. And if a structure has to be accessed by multiple threads, then it needs to implement the sync state. So that kind of like makes things hard for the developer because all the tasks need to be send and sync safe. Otherwise, they can't be sent between threads. So because we have a thread per core model and all the tasks execute on the same thread, it makes the developer's life much more simpler. They don't have to worry about multi-threading, mutexes, locks, and all that. It's much more simple and very different from Tokyo's like architecture. And the next big difference is the IO model, right? So if you typically think about like how like async IO works with like in the traditional model, for example, like event libraries, what they do is they use mechanisms like what is that epoll and kq, right? So for example, you want to know whether a file descriptor is ready to be read from or for write, right? So you would typically register via like the epoll a kq, and then you will get a notification, and that's when the application knows that okay, I can do a read or write now. IOUring is completely different. It's like in a way like pure async in the sense that you have a submission queue and then you have a completion queue. So anytime you want to do a read or write, you would add an entry to your submission queue and like pass a pointer to a buffer to the kernel, and then the kernel does its job, and then you'll get another entry in the completion queue when that task is done, right? So this IOUring has a like a submission and completion model, right? As opposed to the traditional kernel mechanisms, which are all like notification based or event notification based. So that means the async IO itself is fundamentally different with like runtimes which run on IOUring. And I think that'll be a little more clear if you look at traits. Traits in Rust is like similar to like what an interface in Golang is, right? So an async IO is like one of the fundamental traits that like every library uses, right? So if you look at on the left-hand side, the native traits, you see that we take ownership of the buffer. So sorry, I mean ownership of the buffer in IOUring. When you want to do a read or write, you have to pass a pointer to the buffer and uh, to the kernel. You need to pass a pointer to the buffer via the submission queue to the kernel, right? So because of all the memory safety guarantees in Rust, we need to ensure that like when the kernel is doing its job or after you've submitted your uh, entry in the submission queue, we need to make sure that the user is not dropping the buffer, right? So because of that, we need to take ownership of the buffer. But if you look at Tokyo, which is the event notification type IO, they just take a mutable reference, right? Because the application will get a notification from the kernel that like via epoll or KQ saying that you can do a read or write. So all you need is just a reference, right? So because of that, we have like completely different IO traits, and we had to like rewrite a lot of libraries for like HTTP and TLS and things like that. Yeah, 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 sure. And the next is service, right? So service is like the fundamental trait in Monolake. So we have the concept of like service chains. Like each service does like something very specific. It has a request and then it has a response type. And we have basically a service chain, right? Where we like, where each service wraps in a service. So you can see there's like a TLS service and there's a HTTP core service, which has all the codecs. And then we have HTTP handlers after that. And then, yeah, and we have some more like these are a little very Rust specific, but like we've made some new changes where like if there is a config change, you can like remove a handler or a service in your service chain like dynamically. So like your old connections will keep using the old service, and whenever the new service comes up, we can like, for example, like borrow like a connection pool from the older service chain. And yeah, we've done like quite a few things which are different from like Tokyo and like pretty unique. And then, yeah, we have like other service lifecycle management changes as well, where like you can deploy services in like stages. We can do like service versioning and like, you know, much. And this is some of the compile time checks that I was talking about. Um, as like a request passes through from one service to another service, we can do like, we do a lot of context management checks at compile time. So an application typically it has to describe what are the contents of its context, and then at compile time we can do a lot of checks. So this is a service which is saying that like, hey, I expect the peer address to be set in my context. So if I create a service chain in which an outer service is not basically setting this peer address, then this won't even compile. So you kind of stick to Rust ethos of like, if it compiles, it works, right? So if you set up a service chain which is not valid, then when you compile, it won't even like develop. So it makes things easier for like developers. I have some performance graphs. It's all on our Monolake repo. You can take a look at. I just wanted to walk through two quick use cases to show like the different like teams which have used Monolake. One of them is like a security gateway. So LLM chat services have like a lot of like sensitive data, and like we want to ensure that like privacy, right? So what this security, I can just go to the security gateway does is it identifies like user identifiable data, and then it pseudo anonymizes it. So basically it replaces it with something else. So only few services see the actual UID or user identifiable data. The rest of the services don't actually see this. So here you can see that service A talks to service B, and service A has the actual UID. Our security gateway will look at some dot notation, some information metadata provided by our the service operator, and then it identifies the different user identifiable data fields, and then it will overwrite it based on the pseudo anonymization policy, whatever the operator specifies. Right. So that's one use case which is being developed with the security team. The next one is the API gateway. So a lot of internal services in Rust use like thrift, but they expose that API through like HTTP and JSON to like the outside world. And they use Monolake to do like protocol conversions, right? So we've developed this library called Dynthrift. Dynthrift does conversion between like HTTP JSON to thrift without creating any kind of intermediary structures. And this is written completely in Rust. And this is like another handler or service in our service chain. And in terms of like, there's since Bytedance also uses a lot of Golang, we also have support for like Go plugins, and like we have another project called Rust to Go for like make function calls from Rust to like Go. Sure.
Yeah, I had a question on the secure gateway, the previous slide.
Mhm.
Yeah, so like, does it provide like protection against prompt injection attacks?
What do you mean by prompt injection?
Because like you're saying it's a chat service, typically chatbot kind of stuff, like people issue
No.
prompts.
No,
It has anything to do with that, or it is?
No, this you can think of this more as like a proxy which hijacks like RPC calls, right? So the security gateway itself doesn't know too much about what the service is doing. It has some very minimal information or metadata provided by the operator. The operator has to tell the gateway like what are the user identifiable data or fields, right? So they usually give it through some dot notation like this, like in your protobuf messages, right? Like through dot notation, you can just specify which are the UID fields. All the gateway does is it just passes the messages, say for example, in a gRPC stream. It'll go to these fields and then overwrite it. The gateway itself has very little information about like what the services are doing. So it tries to know as little as possible. Yeah.
Thank you.
So it doesn't really care what the application is doing on the back.
So how is that different than like a normal service mesh kind of thing, right? Because this seems like, yeah, like what are the unique features? Because it seems like, okay, we have the sidecar here that talks to, the gateway that talks to the other services. So this is like a pretty standard thing. So what are like some of the special features in this that makes it, useful for ByteDance?
It's just a pseudo anonymization that they're doing, right? So it's not related to service mesh or anything like that, in the sense that this is just a gateway. We're just using the service mesh to like hijack the traffic. So usually they would talk directly to each other, right? So we're just using the sidecars to like hijack the traffic, inspect the messages, and then like overwrite the fields that they consider to be like user identifiable.
Oh, okay,
data.
I see.
Yeah.
Yeah, that makes sense. Yeah, that makes sense. Yeah. Okay. Yeah, both of those use cases make sense. All right.
Yeah, I mean, Monolake itself is not like a single application or gateway. So it's more like just like a framework. So different teams use it for like very different.
Yeah.
functions.
I understand that part.
Yeah, I think that's pretty much it. Yeah, I just had like some, yeah, for at least for the API gateway compared to like their Go um, implementations before, they saw like significant performance improvements and like decreases in CPU usage as well. So yeah.
Actually, well, I guess while I have the mic, so for Rust to go, is that just using like is that just like a type safe wrap around like a C interface that you're using to talk to Go, or are you like actually writing into like the Go memory and garbage collected, all that stuff?
I don't. So that was written by another team. So I don't have the exact details about the implementation. But
Okay.
but if I remember correctly, I think it's a way to like. It's not just a normal FFI call. It has like support for like async calls as well. So your Go
Okay.
function call to Rust looks like an async function call. So
Yeah.
like, so there are some. It's pretty complicated. So I really
Okay.
don't know about the Rust to Go part. Yeah.
Yeah.
But that's not open source yet. But I think they're going to open source it soon. No, that's not yet open source, yeah, because it's still optimizing it.
Yeah.
Yeah, I mean that was more like a since there are like a lot of Go libraries already, and people can't move to Rust in one go.
Yeah.
So Rust to Go is more like a ramp for like other teams to like start like bootstrap solutions and start quickly. But ideally, yeah, we didn't want them to use Rust to Go. But
Yeah.
yeah. Is any other questions? I think someone behind you. Do you mind passing them?
The performance sounds really cool, and I like how you're kind of going to kernel IO completion ports like as quickly as you can. That makes a lot of sense. I'm kind of curious at kind of for the case of like a HTTP2 to Thrift gateway or almost web application firewall. What are the kind of requests per second that you get up to before you need to kind of go to specialized hardware? Like how far can you go in terms of queries per second or requests per second with kind of general compute before you kind of still need dedicated sort of networking accelerator hardware to help out?
Yeah, networking accelerators are not really, as far as I know from this team, is not really an option. We just use like just general compute for like everything. So we just scale out like horizontally, like to whatever, to meet whatever demands that they have. Yeah. So
Okay.
they have a separate like scaling mechanism, which I think ByteDance itself has some auto scaling mechanisms that they use. But Monolith framework itself like doesn't really like worry about auto scaling. I think it's up to the team to figure out like how you want to
Okay.
scale. Yeah.
Okay,
Because this is
and-
just like a single. This will just run as like a binary on like any x86.
Yeah. It's general compute, but I was just curious. Have you hit a ceiling where you go like, okay, we can't do a general compute in this,
Yeah,
you know,
I
like
don't. Yeah, I don't have like a QPS number or something, but generally we've noticed that like the CPU usage with like async Rust is significantly lesser than something like Go. So they have been able to reduce the number of cores that they use or like the VM count significantly, and that's one of the main drivers in like going from like a Golang solution to like Rust is they want to like reduce their costs by like decreasing their core count.
is that just because Go is a compiled language and Rust is a compiled language? So is it just the code gen quality is better, that much better on Rust, or?
Go has a garbage collector, right? Rust doesn't.
Oh, sure. Okay. But is that from hardcore profiling? You have the data where it's like the garbage collector is the thing that makes it that much more efficient?
Yeah.
Or
I mean, you pay a performance cost for having a garbage collector, right? Compared to like system languages like C, C++. So usually they are inherently like faster than like Go, which has a garbage collector, or Java and other ones, right? So you get a performance boost by just switching languages itself, but so that itself has significant savings. But on top of it, Rust async is also like very
right,
efficient.
concurrency's baked into the
Yeah,
language,
async
basically.
itself means that like, when you have nothing to do, you can like drive another task, another
Right.
async task, right? So you're optimizing your CPU usage significantly.
Right. And so when you hand off the workload to kernel threads pretty quickly, so your user land threads are then awaiting and therefore kind of free.
Yeah.
On the user, but that's on the user land side. That's in Rust, right? So on the kernel side, what's the thread scheduling like there? Does it not matter? Does it not?
It doesn't really matter. Like there aren't.
Sure. Yeah, of course. Yeah. Sure. Yep. Mhm. And I assume even for compression, decompression, maybe you don't use general compute, but use GPU compute, which is still like, there's a lot of options there for just getting some silicon in the server blade to do math for you that's not on the general CPU. So the general CPU is just focused on I/O. Mhm.
No, we're not using any, ASIC functionality or anything on DPUs or NICs to like offload anything right now.
The last thing I wanted to ask about is you mentioned HTTP2 here, but are you using HTTP3 or QUIC internally anywhere and needing to make an API gateway for those protocols as well?
Right now, we don't have HTTP3 support for Mono Lake, so we don't have it right now. So we just HTTP2.
Okay, thank you.
No, this. We don't use eBPF. This is just IO Uring. Yeah. Yeah, and since IO Uring initially has been used mostly for storage, more than like networking, but like for networking, there are like a lot of changes right now. I think Meta and Cloudflare are doing a lot of changes like zero copy and things like that. So I think with time, it should get like even like faster, significantly faster than like other kernel mechanisms. Good, right? Thank you.
Thank you. Okay, so we have the
Thank you
digital.
for that deep dive into Monolake. Now, let's welcome Xiang Song to present veScale. Xiang Song is a research scientist at Bytedance LLM team, specializing in scaling up large-scale distributed training systems for large language models.
Hi, thanks for having me. I'm Zion. Let me just share my screen. Can everybody see my screen properly? Hi, I'm Zion. I'm a research scientist working on large-scale distributed training for LLMs and accelerations at Bytedance. So I joined Bytedance at 2023. Before then, I was a research assistant at Carnegie Mellon University and Johns Hopkins University, dedicating to both systems for ML and also the machine translation. So pretty much the thing here is that you have an insider here who are working on the system and knows about the problems and know how to and figure out a way to solve it. So I'm going to share with you veScale, our newly developed PyTorch native LM training system. Excuse me, it's taking a while too. So in today's talk, I will cover the challenges regarding the distributed training and in the LM development and lifecycle, which motivate us to build veScale. And then I'm going to cover the design and core features, milestones and preliminary results of the veScale on several popular language models come next. And then I'll finish up with the future plans and updates of our framework. So we started veScale in about 16 or 17 months ago. As we all know that Bytedance is a very big company where gigantic number of use cases and business models are being developed right as we speak, right? And hundreds of AI models are under development and maintenance at the current moment. So before veScale, the predecessor frameworks, LM frameworks we used to develop our models, focused mainly on the performance of the 3D parallelisms. One of the examples, not surprisingly, is the Megatron LM. These frameworks are often efficient and highly malleable. The very characteristic also becomes its problem as they are very hard to use and it has a very steep learning curve. This caused us to spend many weeks extending just one model and spend also huge manual effort to maintain the model code. This work pattern actually motivated us to develop a new framework that focuses not only on the performance, but also on the ease of use, and thus unfolds veScale story. So before we go into the very technical details, let us look at some of the main challenges that we face with the old frameworks. Yeah, let me finish up with this page. Yes. So there are 5 major challenges here. The first one is that frameworks like TensorFlow and JAX do not support in-house support for the parallelization of a PyTorch model code. By far, Hugging Face is the largest hub of open source model code in the world, and 92% of the Hugging Face models are developed in PyTorch, and so are most of our in-house model codes. So definitely it has become a trend that we need to support to cater to this very large audience in order to make sure our LM ecology is well expanded.
The second one, which is also one of the main challenges, is that the model code and the system code are heavily intertwined. For example, in Megatron, we have a basic module called column parallel linear. Algorithmically, it is equivalent to the NN linear on the very right, and it also contains many arguments for tensor parallelism code, which is a system setup. However, model developers and system developers look at it differently when with pain. So since such design caused them lots of troubles, let's say if we intend to machine learning developers, it needs to add an NN layer to a model. He or she must also consider whether it is row-wise parallel or column-wise parallel, as well as how to configure these arguments. Also, when a system developer tries to speed up the performance, he or she could potentially modify the model code and lead to errors in algorithms down the road. So this intertwined model and system code costs us great human efforts to maintain our code base, which is not a very ideal situation. The third challenge is that existing frameworks have little support for automatic parallelism for industry level models and also frameworks. That means we need to always trade huge manual efforts for code optimizations and higher MFU, and this process is actually not very cost efficient. It also results in extra migration and synchronization efforts for our code development. The fourth challenge is that the poor debuggability of current LLM model code. For frameworks like Megatron that have system code and model code intertwined together, heavily together actually, we had the experience of 10 people spending 3 weeks just to find one bug in the Megatron linear module, which is truly painful. For compile-based frameworks such as JAX, it is actually a black box, and hence it is very hard to debug because we cannot break into the specific lines of code to really identify the problem. The fifth and last challenge is that the very few existing frameworks support robust and scalable distributed checkpointing, especially checkpoint restarting when we change the scale of the training workloads and number of GPUs we used. For example, we might have a model trained with thousands of GPUs and then fine-tune with hundreds of GPUs. We need to save and load checkpoints on different scales. This is extremely inconvenient without distributed checkpoints. And these are just some of the major drawbacks of the current frameworks, and which we really wanted to tackle. And in targeting these 5 settings, veScale has its own strategies against them. So first, veScale is definitely a PyTorch native code, so we leverage entirely out of the PyTorch distributed infrastructure to build everything from scratch. We also have very nice and clean decoupled system and model code design so that it's also easy to modify as well as also easy to change from algorithmic perspectives. The third part here is that it also supports automatic parallelisms. For example, as an algorithm trainer, I do not want to know about the system setup, but I also just want a model to be very quick. So the problem here is that all I need to do, the ideal behavior is I just have a few lines of API calling in my code, on my original model code, and just to make sure my model runs as fast as possible, as fault tolerant as possible. And definitely it should be easy to debug and also supporting this automatic distributed checkpointing. With that, we jump into the workflow of a veScale and how it really looks like. So besides the auto planner that I'm going to cover soon, the rest of the veScale is relatively mature and have very corresponding examples in our open source code, which I will going to demonstrate in a very later stage of our presentations. So first, at the start of this framework, we have this PyTorch native code written. We ideally want to achieve 0 code change on top of it on a single device. So we have this model which composed of different NN modules set up like in linear embedding and stuff. And then we're going to feed it to auto planner. So which means The veScale takes as input user-defined PyTorch native code composed of these modules, and we're trying to convert them into a parallelized, well-parallelized system engine, which has the same set of user development behaviors as the writing a single device PyTorch code. And namely, also supports these kind of like APIs, so which means we demonstrate these parallelization dimensions. We have an entire, in-house and unified plans for users to define the level of the parallelization methods and the options they have. Also including the, this in-house shardings or layer-wise shardings. And then we auto-parallelize the model across the multiple devices such that we're able to find the best, the most productive parallelization strategies for people to scale up their models. And then we'll have all of these setups, including from the very upper level, which is actually a parallelized API, down to the very bottom level abstraction, which we call dtensor, which is distributed tensor, a feature that is shared by PyTorch distributed infrastructure as well. So we're building everything from scratch and also relying on the power of it to make sure our communications and our computations can be best optimized. And with everything being set up, being established, we perform auto reshard to really converting our single model in eager mode or in compile mode to a very parallelized engines. Yeah, that's a lot of animations, and it actually takes time too. Yeah, maybe I need to rework on it in my next draft. Yeah. So so we have something called to wrap all these mechanisms up, we have this mechanism called high-level API. So what high-level API is, it just asks you to learn this simple entry point, feeding the model, feeding the system setup, feeding the way you initialize your model as if you're working on your local optimizers and model states. And then we kick it up for you. And you only need to just change a few arguments in your system level plan to make everything work. There are 3 settings we would like to. There are 3 settings based on abstractions that the foundation of the veScale. We actually observed in our conversation with the PyTorch community that there are actually 3 modes of execution modes that people are really interested in. So there are eager mode, compile mode, and eager and hybrid, eager and compile mode. So eager mode has the widest set of audience, especially for open source developers, as it relies heavily on the PyTorch eager executions. Build your model and actually make it run. The compile mode targets hardcore engineering teams who are able to really targeting to achieve the next milestone in speed and memory optimizations. As we allow users to convert their Torch NM models into TorchFX executable graphs. This also gives us opportunities to achieve higher performance and also graph optimizations, such as replacing a subgraph with big fuse operators or supporting graph capture of most of the popular model architectures in Hugging Face. So in the third part, I will show a code demo and some of the preliminary evaluation results. So right here is actually one of the code snippet we adapted from the Hugging Face. So what you can see here is that you import your models and config from everything from the Hugging Face infrastructures, and starting on line 17 all the way to down below, you have your normal training loop doing forward, backward, and optimizer updates, right? And these color parts are the very few lines we ask users to embed into their code, which means you only need to define this system level plan, as we previously said. And also there's the veScale parallelized entry point, which we return them as system execution engines, a distributed version of optimizer with the hooks. And also we also offer this in-house save and load checkpoints for users to do model shardings, to save to manage multi-process training and saving workloads here. So by that's what we're targeting, or that's what we're advertising as well. It leads to 0 code change of models, and also leads to 0 code change of training. in terms of how we write, how we approach a PyTorch way of writing the model code. And also like multi-dimensional parallel training in 5 lines of code. And there are also, I'd like to do a little bit of comparison between these two. So, so on the very left is just a normal training loop, just bare metal written in PyTorch. And on the very right level is a demonstration of how to use our high-level API to embedding with it. So you can see that you only need to partially modify your system plan and using this only entry point of veScale.parallelize to boost up your model. And that's it. That's how we call high-level API, which is very convenient and everybody, which makes everybody happy, right? And the other aspect, which we call low-level API, is you can see that the only difference is from line 11 to line 16, which means if anyone is interested in building up their code, like part by bit, for example, starting with model code, doing tensor parallelisms, data parallelisms, pipeline parallelisms, one by one, they are also free to do this way bottom up. So this is where we used to simulate the behaviors of using other deep learning frameworks like DeepSpeed or using Megatron LM, so that people can also naturally migrate to this behavior. And let's show some preliminary results. So first, so what you can see here is actually the bitwise accuracy, bitwise correctness loop in this curve of using single GPU model, which is the vanilla versions, and using different veScale strategies. So as you can see that the goal here is to see that given different levels of parallelism strategies and speed up, we're still able to achieve at least very close or bitwise accuracy alignment as if you're not using anything. So the problem here is that whenever in a large training models on a large GPU clusters, also always leads to different perturbations or different misaligned tensor computations. And we're able to fix all these detail here because if you're just building everything from PyTorch, it does not actually guarantee you that everything is going to be always correct. And that's a lot of down and dirty work here, and we are able to just fix it for you. Using either the mixture architecture or the llama architecture. So you can see it's just pretty alignment of red and orange. And so it's the power of it. And then there's also the nano-GPT here. And the other aspect we would like to sell is that besides the training accuracy, we also have improvements in MFU, which is the chief flops over the theoretical flops in terms of how you evaluate how fast your model is, symmetric. Compare with the Torch Titan, which is Meta's latest released counterparts for 5D parallelisms. So compare with them, we actually achieve 1.2 to 1.4x speed up in Mixtral and Llama architecture. Note that these are just examples of April progress. Now it's actually 7 months down the road, we're actually making better progresses here. And then I'm just going to spend another few minutes talking about the future of veScale. So first, we want to make our APIs as simple as possible. So there I show you a triangle here, which is the 3 major pillars of veScale we try to achieve, the major milestones we want to achieve. First, the ease of use, configured as simple API. Second part here is bitwise accuracy or bitwise correctness. And third part is the decent performances. Really make sure your framework is as fast as possible, right? And these are just the 3 of the major support we really want to bring to the PyTorch community, also to our internal folks. So to be very specific, there are a few directions in our roadmap here. First, we will continuously working on to improving our user experience and training MFU on eager modes. Second, we are working on extending Torch FSDP2, and we aim to improve on both performance and memory aspects, and support for FSDP2 working with other parallelization dimensions, which is so FSDP2 is actually another very popular framework or solutions that people will go to. The third part here is that we're going to improve the performance of our compile mode API to make sure it captures more operators and also other user behaviors. Last, I will also work on the refining remaining 2 additional parallelization dimensions, pipeline parallelisms, and expert parallelisms. So going back to our story of both benefiting our own model development lifecycle and also the open source community, that's what we're trying to achieve. Yeah, and these are just some of the comments we have from our friends from other entities are working towards the same directions. And so there are a lot of things that will happen in the future, and we foresee that there are several challenges, and they will continuously come up during our development. First, it's going to be the model coverage problem. So veScale now properly supports just tens of common operators, but there are actually about more than 800 of them PyTorch A10 operators in total. Many of them might have issues when running with dtensor. I believe PyTorch upstream is doing amazing work in this direction as well. So we'll try to find out incentives working together to bring it into reality. Second part here. Second part here is we also need to maintain the bitwise accuracy for all our business models for our LM product, Doubao, which is also, there's free demos here up on the website, so feel free to take a look. Third, there are many scenarios where we need to trade off between performances and ease of use. And let me also conclude this meeting by sharing a few updates. As of October, we have submitted our first veScale paper to MLSys 25, which is actually a top venue for machine learning systems. As of November, as of now, we're trying to showcasing, which is why we're here. And our next release, we're going to be about a plan API or more refined, faster, and better veScale FSTP 2.0. So that will be another feature we're going to release. Our next release will be a full-fledged ND parallelism API, including both pipeline, expert, MOE, and also plan API, and also other functionalities for high-level API. Finally, I would like to give you a big thumb up to my wonderful contributors and collaborators of veScale team, without whom this amazing framework wouldn't be made possible. Besides them, there are also many excellent interns who contributed to the veScale project. And finally, this is our open source repo. We look forward to having more excellent collaborators to grow our platform together. And for more inquiries, feel free to reach out via our emails and also via the QR code right here. Thank you very much. Okay. Yes, please.
I was wondering what kind of implications veScale would have on the creation of a computational graph during training. I know when a model is trained, this graph is created for the forward and the backward computations for gradients. So yeah, I was curious about like the implications of that computational graph with veScale.
Like I said previously, veScale is executed on 3 modes. veScale is executed on 3 modes: graph mode, compile mode, and hybrid mode. So what you're talking about has to do with the semi-hybrid graph mode and also the graph and also compile mode. Yes. So we definitely use a different approach. I mean, we're using combined approach to really capture model graph and operators and make sure we do the subgraph editing, graph partitioning, and also this insertion of communication primitives. So you're using infrastructure like FX or export, or using other like interpreter ways to really capture the model graphs. So it's actually a combination of multiple approach to improve our success of graph capture. Okay,
thank you.
Question. Yes, please. That gentleman over there.
Do you use Ray at all to help you with compute?
I see. That's a very nice question. So Ray is definitely one of the I would say the peer frameworks we're also having exposure to. So Ray is, we consider Ray as both of a RPC layer problems or RPC layer solutions or training layer solutions. The way how we define it is that veScale is defined as a training layer solution here. So as of this part, it is complementary. So So Ray, as of now, supports a TP solutions and DP solutions, right, for inter and intra-node communications. They are releasing a pipeline parallelism part as of this Ray Summit 2.0, but haven't grown full-fledged yet. But here, as of now, we have a pipeline parallelism that's already working and battle tested. Thank you. Okay, thanks, everybody.
So thank you so much, Yang Song, for this excellent talk. Let me just, so we are going into a break now, but we are opening up our feedback form. And so 1 second. So just to remind everybody who was not there in the morning, we have this excellent speaker that will be raffling up at the end of the Developer Summit. So 1 second. Yes, yes, we're in the break. Yeah, feel free to grab tea. There is still food remaining. So as I bring on the QR code, oh, why am I not able to join the meeting? So this is the form for innovator interest. So if you are interested in working with any of these projects, including veScale, KubeWharf, CloudWeGo, this is the form you need to submit to work with us. And here is the feedback form. If you're staying till the end, please don't fill the feedback form because we have the most important talks of the days on Rspack coming up after the break. But if you need to leave, please don't leave without filling the feedback form because we want to hear from you what you want to how was the event, what would you like to hear about next time. Okay, so with that, we'll gather back at 4. Yes, second helping of samosas, parathas with tea, Indian masala tea. Yeah, I was hoping that we'll have a bigger break, but again, we only have 10 minutes now. So, yeah, Kijing, can we have a talk now, do you think? Yeah, we can. Yeah, yeah, sure. Yeah. Hello, everybody. Sorry if I'm too loud. Can I have everybody's attention? Let's get back to our seats. There has been questions about uh, walkthrough, campus walkthrough, and unfortunately our breaks have been too short. Lunch was very good, so people didn't finish early, which is okay. You should enjoy lunch. So now we will do the walkthrough after we finish this set of talks at 5:30 before our evening event. So are we ready with the digital character introduction? Yes, thank you.
Is it all right if I replace your screen share? No, no, no. Yours is currently on the screen, so it's fine. Okay, awesome. So originally what I had written down was a different talk, but I had created this one at JS Nation quite recently. And to be honest, I think that this content's a little fresher and probably more interesting. So I decided to switch it over to something a bit newer. So essentially what I'm going to kind of talk through is just the rationale behind creating Rspack. So for those who don't know, Rspack is one of our, I would say, one of our highly successful open source projects. Essentially, we took Webpack and we rewrote it in Rust. So this is going to kind of be what we learned in the process of actually doing it, or why we did it as well. So just to give you an idea of the general scale of the infrastructure things here, you've heard probably a couple really good talks, gotten some peeks into various things that we build. So obviously there's like quite a vast ecosystem we have to support. So I work on the web infra team, so I help with all the tooling and stuff like that. And among some of the tools that we use, we obviously have series that you see here, everything from documentation generation, native cross-platform tooling, micro front-end solutions, hybrid native app solutions, web frameworks, diagnostic tools, all of that. I think we have about 1,000 products, something like 15,000 front-end repos, and this is like a year plus old info, but last I saw was about 10,000, weekly deployments a day. So that puts a lot of pressure on the infrastructure and getting things out. So generally, the complexities around actually building the underlying tools. So one of the big things that we've really seen is just what we have is complicated, and getting it all to work together nicely in quite a broad variety of platforms gets challenging to do, especially considering things like on-call obligations, stuff like that, where you really want to try and reduce the on-call pressure you're putting on the infrastructure team, considering there's 20-odd thousand front ends, thousands of developers, and so on. A lot of tools that we've kind of used in the past, you've probably also experienced this as well, but you'll have if you want your storybook, you use this. And then if you want to, have packages, you'll use that. And basically all your tools for building everything is a patchwork of random stuff that kind of works together, but maybe not so great. And this was kind of the challenges that we had seen as well. We also have just noticed, like in general, differences between our open source versus like internal operations. And again, probably one of the big things is the scope of responsibility. Most open source projects we find are generally quite single point of focus. You've got like React Native, which is in its name, or something like Next.js, which just focuses on web, but not often is there something that's going to have a really vast support tier, because typically they're not really expected from open source. And then again, on call and response times to problems. Anything, if we run into an issue here, our infra team is generally expected to solve just about any problem within 24 hours, with the longer tail end being 1 week. So things need to work well, And we have to make it work with a lot of exotic environments, interesting apps, and obviously things get bigger and bigger and faster as the company grows. So the problems continue to compound. So why did we end up looking at actually building a custom bundler? So some of the challenges that we really ran into was just the complexity of software. When I was at JS Nation, we actually had a really good discussion around simplicity versus complexity, and which way are we trending? And I think we're starting to trend now on the simplicity layer, but something everybody kind of misses is, yeah, we're getting more simplicity, and that should be targeted toward the end user, which is where you want it. But the problem is if you end up doing that without actually having the underlying horsepower, you can't make it simple for the end user. Like a good case in point is something like Next.js. It's generally quite simple to use, but that's because it's one of the most complex Webpack plugins that's ever been built. And that's why it is so simple, because they're absorbing the complexity. So generally, with the software getting more complicated, we want a more robust tool to handle all of it. Speed is also becoming a bigger and bigger issue. Finding solutions for stuff like native apps, or something like WeChat, which doesn't even use JavaScript. It uses JSON modules entirely. So needing a compiler that can build not JavaScript is quite tricky. Obviously, the requirements that we were looking for in this process is going to be speed. Stability is probably one of the primary things for making sure everything operates the business well. Something that can scale, not just in terms of like compile times or whatever, but it's got the API and it's flexible enough. The architecture is actually there so that as time goes on, it's a good investment, and we're not going to end up running into a problem where the tools are handicapping the business's ability to compete in the market. And a big one, really reducing on-call pressure. That's always a recurring theme at any infra team, I imagine. So how did Rspack actually start? So this kind of takes us back a little bit. So we have something called links in-house. This is essentially our cross-platform building solution. Any native app that's from us is running links. What Rspack actually started out it was called Speedy. So Speedy was an ES Build plugin, and the whole idea was we need something that's going to help us build our native apps better. At the time, our links engine didn't really support something like code splitting or things like that from several years ago. So one big artifact wasn't really a problem. We just needed something that would do that well. So Speedy did a great job as just a elaborate ES Build plugin. But again, we're working with a really large ecosystem here. So while it worked great in the native apps, where the main thing that actually pushed us into building a fully custom bundler was PIA. So PIA is essentially the hybrid solution. It's kind of native, kind of web, and finds that mix within there. But that means that the PIA apps are more impacted by things like network waterfalls, optimization, stuff such as that. And this was really where ES Build and Speedy just didn't work, mostly because of like problems with the chunking. You can't really control the sizing of the chunks. Some other weird quirks would kind of pop up in there. But essentially, it was the constraints it would have on our hybrid native apps that led us to needing a better solution. So we started to look into a Rust-based bundler for it. And I think the two main things we were really after was better control over the chunk generation and hot module reloading, because I think still there's not a whole lot of build tools out there that do HMR quite well, which I think depending on the project size isn't too bad. But if you have something like, say, an unbundled build and you have to download 10,000 chunks and you don't have any HMR, every single time you hit save, you're downloading 10,000 files again and again. And so we had seen that on our larger projects. Every save press would take 10 minutes just to waterfall through all the local files again. So what we started out with was, okay, well, what if we just rewrite ES Build? The idea wasn't let's go and just take Webpack and write it in Rust, but we went through a couple iterations trying to figure out what's actually going to work. So the easiest solution was, hey, ES Build does a pretty decent job. We liked how streamlined it was. Maybe we can just rewrite that in Rust and fix some of the problems that it has. So that's kind of where we started off. We were really taking inspiration from kind of a mix of ES Build and Rollup. If you actually look on our GitHub repo for Rspack, the legacy branch is still using the ES Build design that we initially had from way back when. Again, the main things we're trying to look at here is HMR, which you know, we didn't really find that ESBuild or Rollup had a good solution to. Bundle splitting, which also was hit and miss in both of them, and then CommonJS support, which ESBuild did a really good job with, but things like Rollup and so on don't have any support for CommonJS. So trying to see if we could just take the positives of both, put them together into something, and kind of get rid of any problems we had along the way. So, oh, did I miss a slide here? I think I might have. Okay, I think a slide might have gone missing. But there was another slide here around Rollup. Actually, no, I didn't miss the slide. My bad. New keynote. Okay, so essentially, that was kind of where we started out. So before doing anything, a general theme here is there's a lot of market research. Even at the engineering level, if you have an idea, it starts with an RFC. You see what's on the market, you see if you really need to do it, so on and so forth. So we ended up pretty much taking out every build tool that has been written to date. We took them apart, rebuilt them in various ways. On top of that, we also looked into things like the Rust analyzer and the TypeScript compiler to really understand how language servers work, as well as, you know, how bundlers are designed, what we liked, what we didn't, what works. And, you know, we did quite a bit of R&D here, various designs of module loading systems, plugin driver APIs, the works. There's pages and pages and pages of any bundler you could think of, been taken apart and kind of specced out to see how it worked. So a big thing that we'd also noticed was, and I don't know if we have an official term here for it, but what I've been referring to it as is like the product velocity or product velocity or latency. So what we had discovered and why we wanted a faster bundler and so on was, depending on how long your CI takes, we actually see a latency show up in how long it takes for the PR to get merged. So regardless of the size of the code base, what we found was there was, you know, a statistically significant trend where if you can compress down the amount of time CI takes, the latency on actually getting the PR merged drops quite a bit. So just to put in perspective here, if your CI process takes over 35 minutes, the median time to getting it merged is about 16 hours. If your build takes 5 minutes or under, or your whole CI process takes 5 or under, it takes about 15 minutes to get the same body of work merged. So generally the golden range would be, you know, ideally within the 5 to 10 minute range, because large products aren't shipping to production within 20 minutes. So in the 5 to 10 minute range, we get to roughly the 2 to 3 hour time from when the PR is open to when it gets merged. So that's kind of the golden target we were looking for. Closer to the 5 minute side, but you know, you can see the drastic changes that happen here. And what I really like about this is this kind of does show the, like what's the actual business impact of it being slow. Because yeah, if it only takes 30 minutes, if it was just that, that's fine. But the fact that developers end up going off and doing something else, I'm sure everybody's felt that before. Spend some time, if it takes 40 minutes, you go do something else, you forget about it, maybe tomorrow you come in, you see the build's green, and then you merge it. It's essentially what you would see to your product velocity. So with that in mind, looking at some of the bundlers we took apart, what we really liked about Rollup was it's very clean, very minimalistic. It has a great, really great output for things like packages and so on. Tree shaking in Rollup is also really, really good. It's good at dead code elimination, finding unused exports, sometimes a little too good when I'm doing package development, but generally it had some really nice strengths. But it also had some weaknesses. The biggest problem that we've seen this with quite a few bundlers actually, is most of them are hardwired to ESM. That means that the parser only understands ESM. Anything that you want that bundler to do, you have to first convert it into ESM again, and then it can understand how to process it. So this is a really, really big issue, especially in like large companies where you're not getting away from CommonJS, at least not for the next 5 to 10 years. So it also comes out with bugs. You know, a big problem with them is typically like how you support CommonJS and Rollup is you have a parser that takes non-strict CommonJS and converts it into strict ESM. And this has a bunch of really weird quirks that end up draining support time, causing unexpected issues, and again, just reduces the flexibility. We'd also seen Rollup is slower than Webpack because at least Webpack did have a build cache. And again, no HMR, and its watch mode performance was not very good on large projects. On the ES build end, robust CommonJS support, and its build speeds were very exceptional. However, the restricted plugin APIs really constrained what you can do. And again, trying to support a whole lot of things, you're kind of limited by what those APIs give you. It also ran into a lot of degraded build speed with just how the plugin APIs are designed. Mostly everything is a callback, so one hook is used for multiple phases, and when you have a lot of JavaScript plugins on your build, it tanks the build performance. It also doesn't have HMR, and implementing anything advanced just because of the small API of it, something like module federation is not really possible to actually implement. There's also various edge cases and so on that we've run into with CSS, so on and so forth, and client-side performance, because you can't control the chunk granularity, becomes a really major problem in production or development environments. But there are also challenges with Webpack's approach. Main one is it's a giant black box. So if something goes wrong, it's really hard to understand why, and most people don't really know how it works to begin with. So it's not a very user-friendly diagnostic cycle for most developers. This obviously creates a really high on-call burden for us. So we were able to solve at least diagnostics issues by releasing a project called Rsdoctor. And that is open source. It works with Webpack and Rspack if you do want to check it out. But the other major issue with Webpack is its performance. It did everything that we could want, and it did it really, really well, but it was just too slow, and it was very hard to understand what was going on if you didn't work in Webpack all the time. So when you get onto the larger scale projects, you lose all your build speed times. We're talking maybe 10 minutes for your dev server to start, and maybe 60 minutes for an actual production build to take place in CI. We had tried virtually everything under the sun to speed up Webpack, cache loader, thread loaders, messing around with the UV thread pool and node to try and, trade memory for, bigger buffering of IO. But really, there's only so much you can do, and ultimately it didn't really work. And its caching also, when it worked, was great, but when it didn't work was really problematic. So being able to actually recycle its persistent cache on something like CI was quite dangerous to do. Sometimes things would get stuck and you wouldn't know why until you clear the Webpack cache, and then it would work. So again, we lost some of that speed trying to apply this at like a production level. So what we then ended up looking at is, okay, what if we go for the dual engine approach, like what Vite has done? So obviously, because of chunking and so on and so forth in production, we really need that high quality, stable artifacts that Webpack can produce. So our approach was to do similar to Vite, use Vite in development mode, and instead of roll up for production, replace it with Webpack, which is something that is possible to do with Vite. But similar issues we've seen with just using normal Vite as well is the plugin reusability. You end up writing everything twice and things don't work well together because Vite itself is dual engine, so it's ES build and rollup glued together under the hood. And so trying to do ES build rollup and Webpack, or even just ES build rollup, you get a lot of inconsistencies or a lot of constraints because the weakest point in your bundler API is the weakest point in what you can do with your applications and with your builds. Performance issues were also really challenging. Again, this was mostly due to the network delays. If projects get large and you're going for an unbundled solution, if you go into incognito mode and you unclick the disable cache in your browser, it'll be quite quick, but in the reality is almost everybody has DevTools open and they have various Chrome extensions, and every single resource that goes through Chrome extension will hinder it. So even though on paper you can get the benchmarks for Vite to do pretty well in development mode with the 10,000 module graph, when you take any developer's machine, open it up and load it, it doesn't actually translate over. And a really big one was also just the inconsistency problem. What you're building in development mode has no correlation to what you're going to get in production because it's a totally different build tool. So synchronizing behaviors across different environments was a really high risk area that often bit us. So why did we go with Webpack's design? There were a few reasons. So one of the main reasons really was, well, first on the evolution here, started with this roll-up styled one with the goal of creating an efficient bundler. We had a bunch of complex use cases and lots of limitations along the way. And really why we ended up going to the Webpack architecture is we know that it was tried and tested. Webpack has been around for a decade and it has worked for virtually everything. If you go deep into Microsoft, all the big high revenue apps are still Webpack based for a reason. On our end, we've seen the same thing. Its architecture is proven and works. It's just too slow, and there could be more simplicity added into it. So too slow, too verbose. Other than that, architecturally wise and design wise, I would say it's still in a category of its own. So that was a big reason why we wanted to go for it. We also knew that it could do anything that we had wanted, including compile other languages that aren't JavaScript or output languages that are not JavaScript. It had the APIs that we needed. It was stable. It has been stable for a long time, great test coverage. And while it's slow, the architecture design of the compiler itself had a lot of room to continue being extended and expanded on, assuming you could speed it up so that it's a bit more competitive just in developer experience. All right, so one question here. Does anybody know what these have in common? Has anybody heard of these before? All right. That one, okay. So have you heard of roll down? Yes, so roll down is Veet's new bundler. Have any of you heard of farm before? It's kind of a new one that's been floating around out there. All right, well, basically, yes, all three of these are written in Rust, but the other common thing they have across them is all of their origins can be traced back to Bytedance. So roll down started out as one of the product engineers working somewhere else in the company. It was a side project. We don't take any credit for the building of roll down. He just happened to be working here trying to solve a similar problem. Around this time, we were also messing around with Speedy, so there was just kind of a convergence on whoever was doing it, let's get together. Ploy was the competing idea to Rspack. So the Enfer team had a split. One was working on this one was working on that one. The idea behind Ploy was Veet's getting really popular. What if we solved, again, all the problems that exist with kind of the dual engine approach? We made it quick, we made it stable, we made it reliable, and we could hook into that ecosystem. And Rspack was doing the same thing to the Webpack side. Ultimately, we went through a few reorgs, and we ended up getting rid of redundancy. The Ploy team merges into the Rspack team, and the roll down authors also came over to the Rspack team. And for a little while, we all worked together in harmony. Eventually, roll down ended up getting acquired by Veet, and it became its future bundler there, with some of the original authors who were on our Rspack team now going off to do their thing over there with roll down. Ploy ended up, obviously, the team merged into Rspack, but the author did end up taking the work that was done and actually releasing it outside of the company as Farm FE. And so the successor of Ploy was Farm, but they all have a trace back to Bytedance, which is kind of cool. So we've done bundlers once or twice. At least we have some experience floating around how these work, with 3 of the 5 build tools out there having some origin story that traces back here. The main things that we really wanted out of Rspack was, again, artifact integrity. We need to be sure that it's going to work and it's going to work at scale and that there's not going to be any surprises. Big revenue pipelines, lots of risk, really complicated projects, and obviously wanting to enable the business maximally. Again, another one is going to be just the business value. Since our main job isn't like an independent open source, the whole motivations here are a little bit different. So primarily what we're benchmarking, what we're looking at is what is the yield that we're getting off the investment we're putting into the bundler. We're not making a bundler that developers like. We're making a bundler developers enjoy to use, but that produces actual business value. And all the KPIs are oriented toward business metrics. Did it reduce the bandwidth? Did it increase developer productivity? Can we show statistical significance of this? Can we bring down the egress costs on our edge networks? All of these things are factored into every decision that goes into this bundler. So what we're trying to do was fundamentally different than a lot of other projects when they generally go and look at this. We had a very big business-oriented motivation. And again, what we had discovered as well is back when we were doing Speedy, why we kind of had bet on the ES build originally was it had just come out. There was a lot of iteration happening from the author of it. And we thought, hey, this thing can't, any problems we're experiencing now, they'll be worked out because it's very actively developed. Then it stopped. And this is kind of where we realized that relying on community projects can sometimes have a high risk because things that we were hoping would get fixed did not end up getting fixed, just as author priorities change or, any other scenario that can be outside of control. So trying to find long-term reliable decision makings was really key to trying to go out and build a bundler. In general, our whole idea has been so far, make it fast, make it work, and then we'll make it faster later. So if it needs to be fast enough, which is what I always kind of strive for. And again, in that chart that I showed at the beginning, we already know that once you're within the 5-minute or lower zone, the difference between a 30-second build time and a 4-minute build time, there's virtually no change in product velocity. So once you get into the habitable zone, if you're competing on speed further, well, yes, it might be useful. We haven't actually seen high yield out of chasing speed versus taking the power that we have and putting it into more advanced things like optimization or fancy features. And again, we can always come back and make it quicker. So getting it to be fast enough to solve the major problems, then make sure that it works one-to-one with Webpack's APIs, passes all 60,000 of Webpack's tests, so on and so forth. And then once we do all of that, we can start looking at our V2 designs and making it faster. A really big challenge in what we had seen from building all of these other bundlers or working on them, exploring them is, well, what we needed isn't there. And the challenge with that is we have to make it. And the challenge with that is it might not work. We knew Webpack did everything that we could want. So make it work was a lot easier to achieve. And usually what bites you in, or at least what we've discovered in designing and building a bundler, it's not that hard. Building a bundler isn't that hard. You can write it quite quickly. Designing one, on the other hand, is the majority of the time. The architecture, is it going to scale? Are these APIs actually going to work in the long term? That's what's really, really challenging. So getting that make it work part was really, really key. And then when V2 comes out, we can go and see, well, how could we speed it up a bit more? But we had a known benchmark that all we have to do is make sure that the output matches the output of Webpack, and we're gold. So one other big thing on that we really did like about Rspack, or the Webpack Rspack world, is they are language agnostic. So we'll take Rspack out of the equation for a moment, but Webpack and Rolla, or Webpack and Parcel, are the only two bundlers that are actually language agnostic. All the other bundlers, or most of them, are just ESM only. So everything has to get, converted back into ESM, and it has to eventually be emitted as ESM because that's the only thing that the bundlers understand. We really wanted something that could support more languages in the future. If we're thinking maybe, what about TypeScript in the future? What if we didn't have to use a transpiler on TypeScript, but the bundler could use all the information in TypeScript's, syntax for cross-module optimizations or link time optimizations? Or what if we had CSS that was natively supported by the bundler as well? Or what if we're dealing with languages that are not JavaScript? It would be very, very nice to have a tool that was actually language agnostic by design, kind of guarantees us a lot of runway. So that's one of the big things we were really trying to look at here in this language agnostic manner. It also just gives us better flexibility and scalability in general. So going into our API design, some really key factors. Obviously, JavaScript plugin support was a big one. There's still a very large kind of barrier to entry for somebody to want to write Rust if you've been a JS developer. So needing to make sure we have an API that is still accessible, easy to use, and robust for our teams and for outside users as well. This ensures that everybody can customize and scale it as they want. Performance, again, very critical that we can get that out of our APIs, and ensuring that whatever we're going to design is easy to configure and very easy to compose from either inside the compiler itself or from how users can layer capabilities on top of it. So our approach really was to try and strike a balance between how versatile can it be and how fast can it be, and then tailoring it toward generally the themes that we see happen across like large business environments. So getting into a bit of the ROI that we've actually seen from the work we've done. So probably the largest one, especially considering we're doing, again, so it was about over 10,000 weekly production deployments. So that doesn't include all the builds that go on every day and all the commits that get pushed through. So collectively looking at our CI, when we moved everything over to Rspack, we saw our CI costs drop by about 80%, which was quite a large drop. On average, we see each project save about 30 minutes in its build phase. We see in CI hours a day, It's about 200 hours per day per project, which comes out to about 72,000 hours a year in like just time recuperated. And then on the engineering side, assuming you have a dev server and you maybe kill the dev server and start it 5 times a day, which is pretty average, switch a branch, do something like that. Just on that little benchmark, we would see you would save about per developer about 7 hours a week. So it's essentially 400 hours a year in engineering time per engineer reintroduced back into the business's value. Some of the bigger numbers here that we've seen is from our outside users that we've worked with who we can't name who they are, but they reported back about a $32 million a year recuperation in cost company. On our end, we've seen it be in the 100 million plus per year in value returned. This is from cloud costs, engineering efficiency, product latency speed, so on and so forth. And then overall, in terms of product velocity, as we saw a 16-hour delay if those builds go up, we're looking at over 1 million hours in product velocity gain. We've also had other users report that our bandwidth savings have dropped by about 50%, which pulled in several millions of dollars on that end. Again, we're very sensitive to performance and egress costs, so chunking, things that Webpack can do, but maybe didn't do so well because it's complicated. These are things we've kind of baked into Rspack and baked into our higher level abstractions that are a lot easier to use. The rewards of that we can see reported outside, up to 50% savings in their bandwidth, which again, I don't know what that would look like on Core Web Vitals, but there's definitely going to be a large correlation there. So just in general, some future ideas that we are looking at. We have been playing around with the idea of potentially combining type checking and bundling together, since the type checking and bundling contain a ton of overlap in terms of how they're designed and the functions they need to work. Using TypeScript as a first-class language and actually making the bundler understand it all to do cross-module optimizations, marshaling of data so that it can be just more efficient and take advantage of things like, putting private fields on the class to have better tree shaking. All of that stuff we're busy looking at. Another big one as well is going to be function level remote caching. So if you have a build cache and you share it with another group of developers here, you can cache your thing, you can cache pieces that somebody else has built down to the function level. And this can be distributed, this is remote, and it'll all be open source, so you can host the build cache on your own infrastructure and set it up however you want. We're also looking into some other interesting areas like export level code splitting. Generally, when you do a dynamic import or split some code, it's taking whatever it imports and just moving it off to a new file. But we are looking at actually taking the exports you're using and moving them around based on where that code is actually used, so that we can refine the build output structure a lot more granularly and recombine it in a more efficient manner. And then as we get toward V2, a big thing we're going to be looking at is possibly introducing faster bindings. So really what faster bindings mean is a new API. The kind of nice thing that we'd noticed about the Webpack design is the API that we use in the plugins versus the API internally are not really tied to each other. So we can keep Webpack's architecture and keep working with it for a very long time. But that doesn't mean we're stuck with Webpack's outer-facing plugin APIs or anything like that that developers might not like. The architecture has a lot more mileage than any other parts, and just because of how we've built everything in Rust, the only thing that makes Rspack Webpack is a bindings file that connects it back to a JS API. So looking at the potentials of that in the future. Most likely what we're going to be looking at doing is probably aligning more with TurboPack's architectures in certain ways, just because they have made some really cool innovations there. And they're also looking at function level caching, so there'd probably be some good synergies going in that direction. All right, thank you.
Questions?
Hey, so I have a few questions. The first one is actually, you were comparing how the build time is correlated with the with how long patches take to merge. I think there's a lot of there's a lot of additional exploration I think that you can do there, because I think there's a bunch of other correlations that'd be interesting. Like something else that I think would be interesting to look at would be things like measuring the patch size versus the CI time, because frequently when you're working on a project that takes a long time to build, and then you're like, oh, should I make another patch for this thing, or no, I don't want the CI to run again. I'm just gonna shove it all into one giant thing so we don't only have to do this once. I think that'd be interesting to look at. On a similar note, I think that to look at the frequency of commits, I think you would see more modular commits. So just some things to think about.
Oh yeah, there's definitely dimensions to kind of pull into that.
Yeah.
To see, because when I first saw it, I'm like, okay, so what's the size of the repo as well, or how high
Yeah.
risk is the project? Are we talking all of them? So yeah, it's also it's hard to kind of pull all the data out of the CI, but I think generally, yes, it would be nice to have more dimensions. And I think the general approach here was to try and just say, okay, well, if we've done, I think there's probably X number of million commits done across everything. And then if we slice that by size of repos, kind of try to fix the
Yeah.
skew a little bit, and then say, okay, so what's a statistically significant
Yep.
latency regardless of size of repo? Especially with the introduction of Rspack, it also showed us, cool, if we take one of our largest repos and we drop the build by 80%,
Yeah.
does it also mean that the whole patch release process is dropped as well? So generally, we still saw the correlation, but there's definitely more dimensions I would love to add into the view. One, to just have a better understanding of habits and how things go on, and I think also to try and get rid of some of the skewing.
Yeah, I bring this up because when I worked at Walmart, I did a lot of this stuff, like trying to improve build times, working on our release pipelines, and these were some of the things that I looked at, and it was a really big benefit. And then also at the end, you talked about, oh, we're seeing these benefits in the in the build times, but then you didn't go back and connect that to the original thing where it's like, oh, well, how does this affect the average time for releases, or the mean time to merge? So I'm wondering what you
Okay.
saw there.
So I'll actually need to go and run the SQL queries again to see post what
Yeah.
our thing looks like now. But there's a whole document on what we had seen, but I think the general benchmark, the easier way to put it is like everything kind of dropped by 80%, more or less aligned with, well, one, on our cloud costs, but we also saw, I would say, I think it was, or on that one, I think roughly we're seeing like the product velocity was about a 60% gain or something like that in terms of the usual latencies on it.
Yeah.
It's also a little challenging because a lot of where I pull this data from, we also deploy module federation quite heavily. And so that also skews the newer metrics because now a lot of them use that. And we already know that federation will give any team a 300% output increase. So
Yeah.
it's hard to go back like in time and then re-correlate it to now as we've like added more dimensions of ways to distribute the build and link it back together.
Yeah.
But yeah, it would be cool to.
All right, I have a few more questions, but I think I'll wait for someone. Yeah.
Sorry, I think we're running out of time. So
We can chat in person if anybody has any other questions.
yes. So we here, right? So now we have our next speaker and the digital host. Are you ready? Digital.
Thank you, Zach, for sharing those exciting advancements. Now, we have a lightning talk titled Who's Busy Web Application by Yashas Ravi. Yashas is a Bytedance Rspack open source innovator and a student at Rutgers University pursuing a BS in computer science and biomathematics. He has worked on projects ranging from recommendation systems to Gen AI chatbots.
the meantime, we can continue the conversation. Sorry.
Oh man, we got an encore. All right. So something else that I was interested in learning more about is like beyond the original surface area of Webpack itself. I want to know more about how we can use Rspack specifically to like integrate better into Bytedance's infrastructure. Like, for example, like build tools like Bazel is really cool how they can kind of integrate into like every part of like Google's release cycle, you know, from, you know, development to speeding up tests. And, you know, it's this giant, you know, for those who don't know, you know, Bazel is Google's build system that sort of just builds everything at Google and has a bunch of other features. So when we were designing Rspack, how were we thinking of like on top of what Webpack does, how we can really make it like a first class member of, you know, the whole software cycle at Bytedance?
Yeah, this is a good one. I don't know if we've done a ton of like I think so generally how everything is usually modeled here is it's very have you heard of like the whole SSP? So I think it stands for Shared Services Platform. But the idea is like, cool, there's a tactical team that like builds one thing and you can recombine these parts to go and make new products very quickly without like bogging down like the product part of the team. So I think that's probably one area where there's probably just like a behavioral constraint that has stopped us from looking at that. Like, I don't know if you've used Goofy Deploy or, so the one thing I've noticed is things are like low density in terms of like the interfaces. Like when you want to go and do something, you go to this tool and then you go to that tool and then you go to that one. Meanwhile, I would rather have like a widget that did all 6 things in one go and I could like write a little, you know, hook for and say, hey, deploy my app on my infra the way that I want it every time with one click. So I think that this is a area that we need to go and actually look at how do we create a higher density like tool. Those are so there's one piece that's in Rust and then there's the rest of it which is just like write some integrations at runtime into Rust. So we'll have so like part of it is okay, we write new runtime modules that can communicate with the server and then prepare what we need at the build phase so that at the runtime phase this can connect here and then, you know, there'll be some kind of plugin that sends a payload to a server that knows how to read it, but generally still that kind of low density separation of concern thing. There is a project though that we have been looking at called Workbench, which essentially the idea is, okay, well, what if we can compress everything down into something a lot easier to actually use so that you don't need to have like 10 tabs open to create the release? Because all the tools are really, really awesome. I would just like them to be combined in a more customizable way. So I think that's one of the challenges we have. It's the nature of how everything is like, there's a specialized group that does just deployment. And it's like, okay, well, we have really good builds and really good deployment. How can we make an easier bridge where these things are more unified?
Like there's yeah, I think we're trying to go in that direction. So actually that's sort of like what I was getting at because I feel like, so I'm pretty new to Bytedance, but it seems like we're making a lot of moves towards this like more centralized and modular build and release tooling. So I was wondering like, oh, is Rspack, is that like part of the strategy or is it like its own thing?
Okay, I understand the question better. Okay, so the whole, if we zoom out a bit on here, what we're kind of calling this is the Rstack, and it's essentially taking things like Eden, taking things like documentation, things like VMock, and going, okay, how could we create a stack that's unified under some kind of common, for lack of a better word, brand? Which, okay, well, here's all the things we use. Can we design them so that you can use them independently? But if you use 2 together, they're designed to work seamlessly together. And then we can have something like a bigger plugin system, but that could extend beyond just what we do in Rust in the one tool. But could we create like a more unified approach without creating like a Rome tools type problem where everything's packed into one binary and you don't need 90% of it.
So digital agent, can you introduce Killa, or do you want to introduce yourself?
Hi, hello, everyone. My name is Kirilo. So I am a front-end chapter lead at Amelia Conversation Intelligence. In general, I'm working like 10 years in different directions. It was mobile, React Native, Ionic, Cordova, also a lot of heavy work with the web. Several last years, I working with the micro front-ends and yeah, technologies like Rspack and everything. Okay. A few words about our company. Basically, it's like a city for big tech. So we helping to automate the processes of the call centers and everything. But instead of old DTMF, we are using the natural language solutions. So you call, you tell what you want, and your speech recognized goes to text, and everything works in the background, and it's pretty cool. Here is like approximate scheme of how everything works, what we have and everything. Like we will return to it. So because we have a lot of different services, and it's basically how we evolve to the micro front-end architecture, which I will be talking pretty right now. So yeah, okay. So we had an old stack, like it's micro front-end solutions, but we have one shell app which has several micro front-ends. You see them on the right. There is like several, basically two variations how you can split micro front-ends, vertical or horizontal. We are using the horizontal split. So basically behind each road, you might have another single page application with any internal roads. It might be one page, it might be 10, it doesn't matter. But the idea here is that each service is independent. So the squads behind it can develop, test it, and deploy without relying on other micro front-ends and services. And it helps in development speed and everything. So but mainly our stack was like Webpack, Single SPA, and React. So Webpack is pretty obvious. Everybody knows what is it. The Single SPA is a micro front-end framework which helps with micro front-end solutions. The main feature here is that Single SPA gives you the life cycle. So that's the thing when you go to specific road on the scheme, you need to know which application to load. And this is how and when the Single SPA comes in. It shows you, it not just know that on this concrete road, you're loading this application and every nested road will be the same, for example. And basically our solution is quite good. Mainly I think regarding the micro front-end split, we are on a good side, but we still had challenges with implementation, and basically it was like infrastructure issues. So okay, let's start from the Single SPA future. Basically, even so, it's pretty great and everything works pretty fine with the Single SPA, but the lack of the innovation and how the project are developed and maintained, it has some questions, right? So it's still pretty good solution, but no significant changes. You still see that the major version was released like pretty recently, and it's nothing special, just some fixes and everything, but still it's solid solution. But we try to look what could be done better, how we can change current implementation, how it could be better and everything. Also, we had some technical complexity since things were implemented, and yeah, it had some drawbacks. So for example, for main shell app that orchestrates the micro frontends, we had the combining solution of rollup and webpack. It adds additional overhead on the pretty much everything. Mainly, it's the performance that suffer. Also, another thing that not quite necessary in our case, the SSR, because basically our Amelia cloud platform that I showed recently, yeah, this is one platform where you can go and customize everything. It's not really customer facing, so it's not a e-commerce or something. Mainly it's used by people trained by our teams or our internal developers who helps to build models and everything for the customers, and then our technology already faces the users. So SSR is like definitely an overhead in this solution, and we don't really need it. Another thing that comes with the SSR that if you right now go to the single SPA official website, you see that in the list of the solutions, there is a solution with dynamic imports. And combining with the import maps, it gives you like opportunity. So add name of your organization / name of the module, and due to using the import maps, it will understood which exactly module to import. And it's pretty cool, except the moment that it heavily relies on the node loaders, custom loaders, which is not really supported by the single SPA team. I think it was like one update in 3 or 4 years. So with I think last time it worked for me with Node 17, and yeah, that's not good. Another thing, yeah, it's long builds. Our main app starts for not that big application, 5+ minutes. We will have like lots of charts where I'm comparing the solutions, so we'll see them. It's not very good. Again, the complex local setup, it has like too much overhead with the SSR, and they had to use the Express. So basically, it's Express app that wraps everything, and yeah. So it's combination of everything, and it's pretty difficult. So in the search of the solution, I found this. So initially, of course, we were looking in the direction of the model federation, but as every client, I wanted everything fast, cheap, and good. And yeah, the model federation, of course, gives like it's a very good solution for the micro front ends, but it does not give us the life cycles, which is like pretty crucial, since we have already like several like I don't know how many 15 20 applications inside the shell app, and we don't have that big team to write some custom solution with the life cycles and everything. So we try to look for something that will suit our needs and still do the trick. So that's how I find out about Modern.js in one of the Zach's tweets. So basically, it's yeah, for those who don't know, it's a full stack framework that gives you all the cool stuff that has the remix or the Next.js, so CSR, SSR, other isomorphic development stuff, BFF as API service, other things out of the box, TS support, many other things, file-based routing, and of course the micro front-end support, which comes from out of the box, and it's pretty easy to implement micro front-ends with the Modern.js. Underneath, of course, it used another framework which called the Garfish. It's again the Bytedance framework, which heavily inspired by single SPA, but in combination with the Modern.js, it gives us way more capabilities, and yeah. So yeah, of course, already with the latest version, so Modern.js supports 2 bundlers, Webpack and the Rspack, but since I think latest versions, the main bundler for the Modern.js always will be the Rspack, but you still have the option to switch to the Webpack. So yeah, I won't highlight in something about Rspack. Zach told already a lot of it. The migration process is like, it's very project specific, so probably it won't give you much information. It was 2 separated processes. One is migrating the micro front ends, which was pretty easy. You just remove everything related to single SPA and Webpack and replace it with Modern.js. It was pretty trivial, nothing special here. So Modern JS, by the way, comes with the like many utility packages that basically every project use. So React router, helmet, styled components, which very helpful. And rewriting the shell app. Yeah, here we definitely had way more work, especially that modern JS at the moment provides the capabilities of BFF and middlewares, but you don't have the full server access at the moment. So here you might have some issues. For example, right, if you had the Express server on the as the main app, we had to rewrite some Express-based middlewares. Luckily, we had not many of them, but still, for example, the most popular one, for example, you need to control the course, right? And yeah, you can't do that straight away because underneath, modern JS use different framework. Hono, it's still not JS-based framework, but it's a bit different, and yeah, it requires some customization from your side. Yeah. Also, yeah, we did some refactoring because I said we had too much overhead with some basic structures, but we try to do it as minimal as possible, not to change too many things. So luckily we have like end-to-end tests, unit tests that we can rely on and see how the process goes, where things failing and not. And since we started like how many, probably a little bit more than 6-7 months ago, we're still using the modern JS module. Right now, most probably the best solution is the Rsleep. Recently, I saw there is new articles regarding how you can migrate from the modern JS module to Rsleep, but yeah. Okay. In few words, yeah, this is the configs. It's pretty difficult to understand what exactly happening, but on the left side, we use the rollup, the bottom part with get plugins, basically everything Bubble, Common JS, SVGR, it's a separate plugins that goes to the packages on and create the huge list of dependencies, which is also pretty difficult. And on the right side, this is the new config, which is pretty minimal. There is like very simple things that easy to understand, and yeah, nothing special. That's the great part, that Rspack immediately provided everything from out of the box, and yeah, that's very cool. Okay, benefits. Basically, right now I will be showing the diagrams. I did comparison on how processes goes for the micro frontends, since we can run them individually without our shell app, and how it impacted also our shell app. So yeah, this is just a regular server startup time. So we can see here that Rspack almost 5 times faster, which is quite big difference. So 2 and 3 seconds for the Rspack is like nothing. It's very fast. It's, yeah, the size of the micro frontend is not that big, but still the time is pretty impressive. And comparing to the Webpack, it's very good improvement. This is the build time. The build time is a bit more trickier because here we can see that I did additional comparison for Rspack with TypeScript support, because underneath, as you can see that the regular build time for Rspack is again pretty fast, and it's way more faster than the Webpack. But when in game comes the TS, basically here I mean the TS fork check plugin, which checks that you don't have any TypeScript related issues during the build. You shouldn't really disable for production builds, but we can still see the dynamic that the part, this plugin basically written in the JavaScript, and it adds additional overhead on the build. And even for the Rspack, it increases the build time significantly, like rounded to 3 seconds and 10 seconds. So 7 seconds of just running that plugin is a lot. Yeah. Build size. Here, it's pretty expected, but still, I didn't expect it very big different sizes of the micro front ends because I choose specifically the most optimized one, and yeah, the build size it still became smaller. But what surprised me that we removed only few dependency, and modern JS out of the box comes with way more dependency, and we still reduce the size. It's very cool. Yeah, I forgot to mention one more thing, that all my comparison is for the pack with SVC. So SVC already speed ups the Webpack pretty heavily comparing to the Babel, and yeah, so if we would be comparing with the Webpack with the Babel, probably the results for Webpack will be way worse. Okay, here we comes for the more interesting parts. So this is the shell application, the one that orchestrated all the micro front ends, and here we don't see the same 5 times difference, only because the process already was pretty not good, let's say like this, because we start the server, and in the parallel with the for this old server, we in the background building with the rollup all the packages. So I decided to replicate same behavior for the new application, and due to 70% of packages are still on the modern JS module, it shows not that good results. But I think till the moment it's until the moment we migrated to the Rsleep, and probably the build will definitely go for the server setup time go under the 30 seconds and probably below, because we won't do this overhead with building packages specifically for the server startup time. But again, still it's a reduction in 113 seconds per build. Actually, the startup time, which for developer is very crucial, right? So we already saw in the DAX diagrams how much time it could be saved for when we are scaling this, not from small team, but the team of 1,000 developers, and yeah, it will be huge. The build size, this one surprised me the most. So yeah, we have like 41% reduction in bundle size. Probably our combination of the Webpack and the rollup did some very not optimized things, but yeah, I didn't expect that it will go so low. So, but still, it's interesting. We see that the optimization in the Rspack with the tree shaking definitely doing its tricks right. So. Okay, that's the pure build time. Yeah, here we already see that, yeah, the pack is slower, so it's closer to the results of the micro front end, but still it's not reaching the 5-time difference, again, due to modern JS module. Probably when we replace it, we will get way better results. I expected, like I said, 30 seconds, because the server start time and the build for the Rspack is quite similar, and yeah, it still will save a lot of time. Yeah, 185 seconds per one build, and yeah, I don't know how many we do in each day. Probably the metrics will be collected like right now we are in development environments, and yeah, probably as soon as we migrate all applications in the staging, we'll start collecting the info, and probably next time, or maybe 3 months, 6 months, I will share more information how much time was active. Okay, we still I try to do the migration as minimal as possible, not to change too many things, but still many improvements might be applied. So I want to highlight some of them. As I already mentioned several times, we want to utilize the Rsleep because it suits well for building the packages and everything that not needed during the runtime. It could be pre-built, and it should increase the speed of our builds pretty significantly. We want to utilize the module federation because we have the internal library of the UI components, which is pretty big. And right now we need to follow and see where which dependency they always bundled in each micro frontend, which again creates additional difficulties. So yeah, for example, 15 micro frontends using the same package, it might be different versions, but since they are loaded in one website, we are loading 15 versions of this package. Biome.js, yeah, it's probably the easy win because it's a replacement for the ESLint and the Prettier. It's very straightforward. It's easy to set up, but the speed, again, the Biome.js, it's a Rust written tool, so the speed is very fast. So developer experience with the pre-commit hooks or pre-push hooks where you're using ESLint and formatter will be very significantly speed up. And another thing is NX. In my opinion, it's the best monorepo tool, which gives the cache capabilities. It's so, for example, right, you are running 15 packages build, it cache it, and after that, it will run only on those who are changed. So it's for the local development and the developer experience, it's quite significant. I think that's it. If you have any questions, go ahead.
I have a pretty specific question about when you were comparing the difference in build times for when you had TypeScript versus not TypeScript. Something that I wanted to learn more about is that you would think that if you're doing type checking, then just like running TSC, that would be like a constant amount of time of increase. But when you are running the type checking with Rspack, it adds like 7 seconds. But when you are running it with Webpack, it adds 12 seconds. So yeah, is there something that like I'm not understanding about how Rspack or Webpack talks to TSC?
That's a quite interesting question because I also quite interested in it. I start digging up. So basically, the Rspack not doing something very different. So it's still a fork of the fork test check plugin, but it still adds some wrappers for it to communicate with the Rspack. But yeah, some things. So my understanding, I don't have a correct answer why it's happening, but yeah, probably your idea that the time should be constant is definitely more logical, but why it's happening, it's quite.
All right, thank you.
Also, I think that the results of this, some of the build times could be different, right? So
Yeah,
you're running
maybe some error bars on the number. Yeah.
No, it's also depend. You're running like on the local machine and even in CI/CD. Like sometimes you get the difference like 5 seconds, sometimes 10 seconds. So it's not a constant time even in the isolated environment. So
yeah,
unfortunately.
Yeah.
Okay, thank you.
Okay, thank you so much, Carol. So I think we went out of order. So, oh, okay, yeah, go ahead.
Thank you, Kirilo, for sharing your migration journey with us. As we approach the end of our event, I'd like to invite Sujata Tibrewala back to the stage for some concluding remarks and our raffle draw. Congratulations to our
Hello, sorry, we went out of order. We need to introduce Yashas. Yeah, we already did, so we are fine. Yeah. I'll share the feedback form QR code. So this is the QR code for feedback form. Please take a screenshot, and now we'll let Yashas go. Good. Go ahead, Yashas.
Hi, everyone. My name is Yashis. I'm currently a student studying computer science at Rutgers University, New Brunswick. So today I will be speaking about a web application that I'm developing called Who's Busy. It's a social networking application, and I'll also talk about how I integrated Rspack and the benefits and the improvements that I observed from that. So what is Who's Busy? So Who's Busy is a social networking application where users create accounts, add other users as their friends, enter data and when they're free during the week, and they can also view when their other friends are free. The main page in each user's account would be the profile page. The profile page displays when all the user's friends are free, and it's displayed in this image here. So essentially, each row represents a friend for the specific user, and each column represents the day of the current week. A color that's more blue means that that friend is more available on that day, and a color that's more red means the friend is more busy on that day. For example, Henry is one of this user's friends, and Henry is free on Saturday, but he's not as free on, let's say, Tuesday. So that's kind of how to interpret this grid that the web application shows for each user. One thing to note is that Who's Busy is currently an app that I'm refining and improving. So I haven't deployed it yet, and I'm still working on making the front end better as well as developing the back end functionality. So these are some of the other pages in the web application. This is the current data page where users can add data on when they're free during the week. So for example, here they select a color where red means that they're more busy. Color that's more blue means they're more free. And then they color like each hour of the day in the current week based off of like how free they are. So here, like the user entered that they're 50% free on Wednesday at 10 a.m., meaning that they might be free or they might be busy on that specific hour. However, on Friday at 8 a.m. on November 22nd, they're like super busy. They're 0% free. So like when the user enters the data like this, their friends can see when this user is free, and that makes it easier for them to schedule time. So how does the scheduling time work? Essentially, when the user selects one of their friends, they can chat with them in this messaging interface here. The messaging interface allows for adding messages, deleting messages, replying messages, as well as liking messages. And when the user clicks like one of the friends from the profile page, they have this chat bot, and they also have this little grid which shows like how free is that friend on each hour of each day. So for example, here the user can see that Henry, who's the friend, is free at 2 p.m. And the user can just chat with Henry and say, hey, like, are you free on 2 p.m. on Tuesday? And like this is a very convenient way for the user and his or her friends to basically schedule time in like a very efficient way. So that's basically the whole point of this application. So Who's Busy was created using Create React App or CRA. CRA uses Babel to transpile the JavaScript code to JSX. I'm sorry, the JSX to JavaScript, and uses Webpack to create the production and development bundles. So when I use CRA, the development bundle took 4.14 seconds to load. And then when I migrated to RS Build, it took only 0.33 seconds. This is a really significant improvement since this is like a 92% improvement in the development build time. And this kind of effect can really accumulate if the developers rebuild the application lots of times in the day, or there's a lot of developers working on these applications. And this 3.8-second improvement can really add up to several hours or even days. I also wanted to touch on the hot module replacement. When using RS Build, the hot module replacement only took 0.05 seconds for each edit that I made in the source code. So essentially, the point is that RS Build has significantly faster builds in development mode, which can have profound impacts on the development experience. So now I'm looking at the production perspective. For Create React App, the production bundle was around 4,492 kilobytes. And for RS Build, the production bundle was 702 kilobytes. So essentially, this is an 84% reduction in the production bundle between Create React App and RS Build. So this can have profound impacts on in the deployment phase. So CDN costs, bandwidth efficiency, as well as like reducing the page load times for the end users can have real profound business impact. I also analyzed the Lighthouse metrics. So the Lighthouse metrics are basically the set of metrics developed by Google, specifically Google Analytics 4, to basically measure the efficiency, measure the efficacy of like a web application. So here in this comparison, the significant differences are in the largest contentful paint, the total blocking time, and the speed index. So briefly to explain what these are, the largest contentful paint is the amount of time it takes for the largest visible content to load up in the screen. The total blocking time is how long it takes for the user to be able to interact with the application. And the speed index is how long it takes for the visible features in the application to appear to the user. So these reductions basically show that the user can interact with the application faster by the lower total blocking time, and they see most of the web page show up sooner from the largest contentful paint and the speed index. So this is basically reiterating that by using RS Build, the end users have a better experience viewing the application on their end, and this can lead to a smoother use of the application. So as I said earlier, this project is a personal project that I've developed from my free time. However, I did want to look at the business perspective. So let's say this was being used by a company. This was used in this case by a company that has 50 developers, right? So what would the estimated business impact be? So the first thing I want to say is that the migration to RS Build only took 5 minutes. And compared to most of the development that goes on in a mid or large size company, 5 minutes of migration time isn't really that much. Looking at the 3.81 second reduction in the build time, this can really add up. So for example, if there are 50 builds per day, this is 3.2 minutes saved per day per developer. And then if there are 50 developers doing all these 50 builds per day, that's almost 160 minutes saved per day. Now, these 160 minutes saved per day could be used to build other features or increase or optimize other functionalities of the application. Another perspective is the finances. So looking at these 160 minutes saved per day, if the cost of each developer is $50 an hour, this is $132 saved per day. Over a typical, if we assume a 5-day typical work week, this is $34,800 in savings per year for this hypothetical company. So now looking at the production perspective, suppose this company has 1 million active users. So we have the reduction in the bundle size of 4492 minus 702, right? And then this is an 84% reduction. And suppose we have 1 million users, this leads to 3.79 terabytes in saved bandwidth. And this can lead to huge savings for the company. I can't really point out specific numbers because different companies use different CDNs and there's a lot of variability in the cost per data use. However, like this is a very significant difference and can lead the company a lot of financial savings. As stated, this is an 84% decrease in the bundle size. There was a Cornell paper that stated how eliminating superfluous code reduces the page load times by 5 to 10%. Looking at RS build, this is basically the functionality of tree shaking, where unused code is basically eliminated. And using that logic, we can estimate a similar reduction in the page load time of 5 to 10%. Now, this reduction in page load time can actually affect the lighthouse metrics discussed earlier. For example, the largest contentful paint and the total blocking time. Even a 1%, even if these like lighthouse metrics cause a 1% improvement in the engaged user sessions, this means that for 1 million users, that's more than 10,000 more engaged user sessions per month. Just for clarification, an engaged user session defined by Google, it's basically a session that lasts more than 10 seconds, has at least 2 page loads, and has some kind of type of like conversion event or some sort of user interaction that's meaningful. So like this is if we have more than 10,000 user engaged sessions per month, this is real business value, and this again goes to show that RS Build can have like a truly significant impact on not only the development experience, the cost savings, as well as the user experience as well. Thank you. I'd love to take any questions. Oh, and that's my LinkedIn. Feel free to connect.
So I think one of the points you made, you could actually, I think a point of improvement there is when you were showing the difference in the lighthouse scores. It looks like when you were, it looks like that when you were running these, you were probably like running these on your laptop or something, because like, given those numbers that you were sharing, like these numbers are like a lot faster than you would normally expect for, loading like 5 megabytes of job or even like 700 KB. So I think that if you reran these numbers on like a realistic smartphone, just some run-of-the-mill Android phone, and then with some realistic like network speeds, I think you would see a much bigger improvement. Like going from a bundle of like 5 megabytes down to 1 megabyte, you'll see a much bigger improvement in your LCP, in your TBT. So yeah, I think you'd have much more like eye-popping numbers if you weren't running it on your like local machine.
Yes, that makes sense. Yeah. I think a point of improvement would be to show the differences in other devices like mobile devices, as well as like varying network speeds, and demonstrating what the difference would be in those scenarios.
Can I shake the tree even further? Meaning, is it fully optimized or there is room for optimization in case of RS build and the Rspack?
I would probably say yes. However, I'm not sure how Rspack is like implemented like on the lowest level in terms of like how much tree shaking is done. From my knowledge, I know it's a lot more tree shaking, minification, and code splitting than like Webpack. I think this is a question that
it's a question for him
Zach.
there. Yeah.
Yeah.
And second question, and it may go back to him as well, which is is there any issue in building progressive web apps as opposed to just a regular web app? Can I build it? And is there any issue with building it using RSBuild or Rspack?
So by progressive, could you clarify?
Like with mostly web apps, you cannot just bring down and attach that to a home page as an icon. But if it's a progressive web app, it's highly optimized for Lighthouse, as well as then I can just go to the home page and drag an icon to the home screen. So it looks like an app, and it is a web app, but you're not going through an Android or an Apple Play Store. And so most people are trying to bypass that check with the Play Stores by building progressive web apps. Yeah, the workers, yeah. That's much bigger than I have a progressive web app based website, and I'm going to try Rspack tomorrow. So
yes, the migration is actually really simple. It's just including a few configuration files and changing some aspects in the React scripts in package.json. So it's the migration is like pretty simple, and yeah, it does yield a pretty big difference. So I definitely
just at a high level, this is a horizontal approach, right? I can just build it for any application, and I should see benefit with Rspack compared to Webpack.
I would say so, yes.
Yeah, not specific for a certain use case like micro front ends or anything like that.
I would say it would apply to any front end that would front end application that that's using like Webpack or any other. I know definitely for Webpack, the migration to Rspack will yield like certain benefits no matter like what the functionality of the application is.
Sounds good. Thank you.
Yes.
Thank you. Okay, we're out of time, but we can continue the conversation over dinner before we break. The most important thing. Thank you so much, Yashas, for that awesome presentation. Thank you. And so now is the time to announce the raffle winner. I need a volunteer to click the button on random generator, and should be a Bytedance employee. Okay. Because they are not getting the raffle prize. Yeah. So it is on my phone.
I did sign up for fun, but I said if I ever won, I'm just gonna give it to someone else.
Okay.
I like the feeling of winning, so I always try to.
Okay. Cool. So we'll.
So I still hope I win. Then I don't even.
So you'll press the button one more time if you are the winner.
But they also know inside that I was.
Yes, that's true. 60 is Runzen Wang. Ah. Oh, sorry, you didn't have to. Yeah, this one. Yes. This one. Yes, you got it right. So that's the sound bar. Yeah, by the way, our innovators can vouch for this. They also get this as welcome gift. Yeah. So once more, a big hand for our 2024 innovators who have contributed heavily, and the presenters. The innovator presenters today. Thank you. Okay, while I will also do a little bit of acknowledgements today. So here's the innovator interest form while I'm doing that. So with this, so online audience, you can log off. We are done with the presentations part of the summit. Thank you so much, everyone, for coming today. Thank you so much, the speakers. I know you have put in so much effort. Of course, innovators. And last but not least, our star volunteers, Dr. Kejing, Wilson Wong, Tina Su, and other Bytedance employees who have helped in organizing this conference, who have been promoting this, and like, making this conference a success. A lot of people have traveled just for this conference, and I really appreciate that. So with that, we get to the food part, and there is a evening meetup as well, and I will let Wilson or Tina talk about that schedule. And in the meantime, if people want to do a walkthrough, looks like for the evening food, we have pizzas, but there is leftover food from lunch as well. So you're welcome to have, the chai should be still hot because it's in a hot case. The tea, I mean, sorry. And the food, samosas, etc. is still there. Pizza is there.
Yeah, for the evening's event, probably if you register, then you what you need to do is like you still need to go to the front desk and check in again. So that's a policy. So if you didn't register this night meet up, then probably you won't be able to join this event because it's two separate events. Yeah. But I mean, we will have this meetup every 2 weeks, and you can join them through the Luma. Like if you have like a Luma app, then you can download it, and later you should be able to register for that event. It's every 2 weeks. I think it's an open source meetup. It's like the Bytedance open source meetup, but we will have people mainly talking about the AI technology, all these new new technologies.
No, it's a different group. It's not the Bytedance open source developers meetup group. It's a different event. Yeah, you can attend. Yeah. So today, has anyone of this audience joined that group? Okay, 3 people. Oh, okay. So looks like we have to escort. So, yeah, is the food for them or no? No, right? No, okay. Yeah. So then what we can do is we can do the campus tour. And if you want to stay back for food, then for speakers, at least we can honor the, we have the food in the cafeteria. But for others, I'm so sorry. We'll have to say bye for now. And then we can go from there. Okay, so for those who are, I'm so sorry for confusion. Those who want to do the campus tour, which was asked for, please come with me. So I thought